Okay, hello everyone, and welcome to our international workshop on new methods on dog behavior analysis. I am so excited to see all of you. I'm a bit speechless. So you are hosted today by our incredible Data Science Research Center, and the person responsible for operating this event is Moran Altman. I don't know if she's here, but we will have to thank her later when she arrives. And we are the organizers of the workshop, the Tech for Animals Lab. Before I present a bit about our lab, I would like to give you some exciting numbers. So we had over 80 people registered physically for this workshop. Not everyone is here, but as you can see, quite a lot of people are here, and we are so happy to see you. The mixture of people coming from different fields, organizations, and are all interested in dog behavior. That is really amazing. And another amazing figure is that we have over 300 remote participants. Not all of them are watching us right now, but they will be watching the recordings later. I think this is amazing, that this multidisciplinary topic is generating so much interest. And I think it is a great opportunity to start the discussion between the fields who are interested in dog behavior. So I would like to show you an introductory video about our lab. We are located here at the Information Systems Department of the University of Haifa. The University of Haifa promotes multidisciplinary research, and that is why it has been a wonderful environment for our lab, because in our lab we have researchers of different fields: AI people, data science people, dog trainers, cognitive scientists, anthropologists, and so on. And this has also been possible by University of Haifa creating this wonderful environment for us. So I will show you a short video, just to an exposure of some of the projects that we are working on. And you will see here the room of our lab. It's just on the 3rd floor, so you are welcome to come and visit us during the break and see how we really work. That's my dog. So these are just some projects that we are working on. As you can see, we do a lot of different species, from beetles and aphids to really large animals such as tigers and lions. But today is all about our favorite animal, which is the dog. So I think this is a very exciting and a very timely moment to be having this workshop and to be discussing the future of dog behavior analysis. This is because of three important trends happening currently in this field. The first trend is that dogs are generating really a lot of data. As we will hear today from Asaf Dagan, who is the chief veterinary scientist of PetPace, which is an Israeli company producing one of the best smart collars for dogs, PetPace. We will hear that dogs are producing really a lot of data, and we can have a lot of different insights about their health, welfare, behavior, and so on. The other trend is that we currently are witnessing amazing advances in AI. I mean, all of you have heard about generative AI and ChatGPT, but this is just the tip of the iceberg of what the AI can do in this field, and we can take advantage of the latest state-of-the-art technologies in computer vision, sensor, data science, and so on. And finally, there is also the trend of developing more accurate methods for measuring behavior. And today we have our Italian guests, very exciting talks that will show you what is the state of the art in the field of measuring facial analysis. We have the DogFACS tutorial, and you will see what we can do. So these three trends coming together create really an exciting opportunity for us all to engage in this discussion. And it is really wonderful to have here people from therapy, from veterinary science, shelter medicine, behavioral medicine, dog trainers, working dogs organizations, and AI and data science people. All are here in this room. It's really amazing what can come out of this discussion. So just to give you an overview of the exciting day that is awaiting us, as you can see, we have representatives from cognitive science, veterinary science, and AI and data science. So we have our exciting guests from Italy, Giulia Pedretti and Chiara Canori, who will tell you about their research into facial expressions and dog behavior. We also have Tiziano Travain, who will also speak about really state-of-the-art approaches of how to measure objectively dogs' welfare and also to measure emotions. We have a remote speaker with us, Annika Bremhurst, who is a long-time collaborator of our lab and is also a research associate of the lab. Unfortunately, she cannot join us, and she has recorded her presentation remotely, but she will be here to answer our questions on Zoom later. And we have three exciting veterinary experts: Stefan Bloyer, who is an expert in behavior, and Tal Asif, who is an expert in shelter medicine, and Asaf Dagan, who comes from the industry and is the chief scientist of the PetPace company. So each of them brings a very unique perspective into our discussion. And finally, our very own Dr. Marcelo Feigelstein, who defended his PhD successfully this week. And he will be presenting his exciting research about recognition of animal emotional states. So this is the program for today. And it is also time to thank the people who made this event possible. So we would like to say a big thank you to the Milatin Group, who are our sponsors for the event. Thank you so much for supporting us. And you will get a very nice gifts at the end of the event, so stay until the end. That's a good incentive for you. We would like to say a big thank you to our president, Professor Ron Robin, and to Tzameret Zohar, who is here. She made it possible for us to have the remote participation, and we are really thankful to you because there are 300 people who are watching and will be watching this streaming. And we would like to also say thank you to the DSRC Center and to Moran Altman, who operated this event, and to the Faculty of Social Sciences and the Research Authority, who also supported this event. We really feel your support. It's really important to us to make this event happen. So thank you, everyone. And this is just to remind our remote participants of the ways to stay in touch with us. We will be updating in our Facebook group on today's discussions and talks. And we are also monitoring the Discord channel and the YouTube channel so that if remote participants have questions or remarks, we will be able to ask them for you. So please stay tuned. And I would like to now invite our first speaker, Giulia Pedretti. to mute this.
Oh,
Yeah,
yes.
Okay. Narine, will you help Julia?
This is for it?
Okay. Good morning, everyone. I'm very glad to be here, and I'm very surprised because Anna, the idea of this workshop was just a kind of a big lab meeting to discuss our work with her meeting, and then I don't know how, thanks to her organizational skills, became this international workshop in which we will try to talk a little bit about visual signals, especially this morning. So I wanted to present you a little bit our lab, since we are a few people talking this morning. We are located in north of Italy, in Parma. And as you can see in this picture, we are me, Giulia Pedretti, Chiara Canori, and Tiziano Travain, who will speak later. And we also collaborate a lot with the University of Veterinary Medicine of Vienna. There you can see our supervisor, that is Paola Valsecchi, and our collaborator from Vienna, that is Sara Marshall-Pescini. So our university has a very long history of and tradition of ethology, so studying the dog behavior from an ethological perspective. Most of you do research about animal behavior and performance, or is a trainer or a handler of working dog. And as you probably know, dog behavior and cognition scientific research exploded in the 90s and is now very, very well spread worldwide. However, it has been mainly focused on dogs' ability to perform a cognitive task or to read human gestures and communication. However, the scientific research about dog communication has been a little bit not so well studied. So I don't know, maybe I would be happy to share what is your experience about your dog trainer and your training program. Where do you base your knowledge about dog communication? Because, for example, in Italy, most of the dog communication research and what they teach in dog training courses is still based on observational studies from the 1970s, like the book we can see here from Michael Fox. So in our lab, we are focused on studying domestic dogs from an ethological perspective, and in particular, dog communication. When we talk about communication, communication is the action of an organism that alters the probability of the behavior of another organism, so the recipient of the signals. Dog communicates through different channels. We can see here in this video that I will play. Here we can see dogs expressing their communication through the visual channel, so postures, facial expression, moving into the environment. Then this video is very fast, I don't know if you saw it. They express their communication with vocalization, so through an auditory channel, like barking. They express their communication through chemical signals. Here we can see a dog that marks and another dog that sniffs the marking of this other dog. And then we also have the tactile channel that is very important. So dogs are social animals, they like to sleep together, sleep like in contact, and this is very important for their social network. This morning we will mainly focus on visual signals, this presentation and also the work of my colleagues. In these pictures you can see an husky that is yawning during an obedience competition. Then you can see a border collie that is licking its lip during a sit and rest command. And then you can see a lot of facial expression going on in this social interaction between the two labs. So you can see the puppy that is greeting the yellow lab, and the yellow lab that turns its head, blink, and put its ears backwards. We will talk a lot about this kind of signals. But let's go a little bit more into what is a visual signals. A visual signals is a behavioral pattern, so a behavior, that have evolved through a ritualization process to become efficient as a communicative signals. And we can call it a display. So display is a behavioral pattern selected as a communicative signals. Here we can see an example of the fox. This gape, so so this open mouth is a threatened signal. That was before an antecedent of the biting behavior. And through the ritualization process has become stereotyped and has a function of threatening without the consequent behavior of the biting. A very famous example that is from the book of Darwin about the expression of the emotion in human animals is the threatening and submissive posture in the dogs. So we can see the threatening posture that had before a function that was to have the body and the muscles ready for the aggression, but has now gained a meaning for the conspecific as it is, so in a frozen posture. So if a dog exhibits this kind of posture, the other dog should understand that this is a threatening signal. And on the contrary, the submissive posture that is all the contrary about facial expression and body posture. So you have a dog that is lowered, ears backwards, very soft movements of the tail, and it indicates an appeasement and submissive intention. I will go faster because I'm already late. So how do these communicative signals originate? Communicative signals can originate from intentional movements, as we can see the threatening postures and the gait that was preceding the bite, from conflictual activities. Often animals have two conflictual intentions. I want to approach you, but I am also very scared about you. So I do this kind of behaviors that show this motivational conflict. These postures and this facial expression can be selected through natural selection to become a signal that this dog or this animal is stressed or not in comfort. And then we have displacement behaviors. What are displacement behaviors? We have been focused a lot on the study of displacement behaviors, as you will see. Displacement behaviors are behavioral patterns that are displayed apparently out of context or not with an apparent function to the ongoing situation. These include acts of self-maintenance like yawning, licking, scratching, but also activities that are displayed towards the environment, like manipulation of an object, digging, drinking a lot. What are these signals? So in classical ethology, these signals have been considered indicators of frustration and motivational conflict, but also measure of social anxiety and stress. It has been shown that in primates, societies that are less stable, so in which there is no stable hierarchy and conflict are more frequent, the animals displayed more of these kind of behaviors compared to more stable society in which the conflict is less probable. So in general, these behaviors has been classified as indicator of stress. It has also been suggested that they can function as coping strategy to help the animal to cope with this stressful situation and to lower the arousal linked with the situation. A more recent hypothesis is that these behaviors have been also selected as communicative signals to communicate the state of stress or the emotional state of the animal in that situation. Dogs, as you probably know if you're a handler or a trainer, show a lot of displacement behaviors, have a lot of displacement behavior in their repertoire. They blink, they lips licking, the yawning, the stretching, the scratching, shaking off, but also behaviors directed towards the environment, such as digging, sniffing, and manipulation. So the question about my PhD was, are these behaviors stress behaviors, or there is something more? Because as you will see in the presentation of Chiara, there is the hypothesis that these behaviors have been selected for as communicative signals. And how can we know whether they are stress or whether they are communication? Just a little recap about what is stress and what is arousal. So stress is a temporary condition of the autonomic nervous system as a response to a stressor that can be of different nature. We need to remind always that stress is a specific response. So stress is not always negative or always positive, but can be both. And we can define the affective state of the individual, so how the individual is feeling, based on two components. The arousal, that is how much this organism is activated, and the valence, So does this organism perceive this situation as positive or negative? So we will have positive excitement if the organism have a high arousal, is very active, and also a positive appraisal of the situation. We will have frustration, nervous stress if we have high arousal and a negative appraisal of the situation. How can we measure the state of arousal of, for example, a dog with different physiological measures and parameters that can be cortisol, heart rate, and heart rate variability. What do we know about the correlation between behaviors and stress in dogs? So there are different studies conducted mainly in the 90s, 95, 98, from this group of research for Birda and colleagues, in which they exposed dogs to different stressful stimuli. We have a sound blast in the first study, and then in the second study we have two categories of stimuli. One that are sound blast, electric shock, and falling of an object in the kennel of the dog that are not predictable. The dog didn't know that this was about to happen, and not social. So there was no trainer, no experimenter who came to give this stimuli to them. And then we have two stimuli, so the opening an umbrella and the restraint, so the dog was restrained down with the leash, that were predictable because there was an experimenter that was coming towards the kennel, going inside, and administer this stimuli to the dog. What they observed, they then measured cortisol to see whether this behavior, whether some behaviors were associated with the increase of cortisol. And in the first study, they saw that cortisol was associated with tongue out, snout leak, so lips licking, paw lift, body shake, and a general low posture. In the second study, they saw that cortisol was associated just with a low posture and was exhibited just when there was not predictable and not social stimuli. While when there was a social stimuli, so a person coming there and administering the stimuli, dogs were performing lip licking, body shake, and yawning. And these kind of behaviors were not associated with cortisol. So in the conclusion of this study, the author suggested that they may have a communicative function, so not be just stress, but maybe the dog is exhibiting this with an intent towards the human that is there. So then we have a more recent study from Anika that we'll present later, in which with a more modern system, because as we will talk about later, the problem also with the studies when I started my PhD was that each study had a different ethogram. So each researcher was defining on themselves the definition of the behavior. So maybe they have some behavior that were defined as the dog is licking just the nose, and some other that were considering mouth licking as nose lick, lips licking, just putting out the tongue. So it was very difficult to like understand the results, what were the behaviors that were taken into account, because all the ethograms or all the definition of the behaviors were different. So as we can see later with the DogFACS tutorial, this was one of the first studies who take into account a standardized way of measuring facial expression and expose dog to positive high arousal condition and negative high arousal condition. And they observed that there were specific facial expression to the positive condition and other specific facial expression that include also some displacement behavior as blink and nose lick that were exhibited in the negative frustration condition. So just to sum up what we said in the introduction and how can we test our research question. When we have communication, we have a signal that is emitted by a sender, and that will change the behavior of a potential receiver. So how can we study if a behavior is just a stress signal or has a communicative intent? In etology, this has been studied, testing whether this kind of behavior, for example, lips licking, is actually dependent on the presence of an audience. So I can talk alone, but the probability of me talking is higher, hopefully, when I have someone who listens to me compared to when there is no one. So what we did, we varied the presence of the audience in a potentially stressful situation for the dogs. And we see whether the behaviors were depending on the fact that there was someone there or not. This was our first study that has been published, it's nearly 1 year now, in which we exposed dogs to positive anticipation and frustration. We modified the presence or absence of a human experimenter in the frustration condition, and we measured salivary cortisol before and after the test. So here you can see how the test was conducted. There was a wooden panel dividing the room, in which there was this, I'm pointing, but it's the computer. There was this window that opened, and then the food was there. So the dog could see the food for 5 seconds, and then the panel was open, the dog could take the food. Then we had the frustration condition, in which the food was there for 5 seconds, and then was moved away. The panel remained closed, the dog could not take the food. And then we have the frustration human, in which the procedure was the same. The dog could see the food for 5 seconds, the food was moved away, and there was a human experimenter looking straight into the dog's eyes for the whole duration of the test. We took a cortisol measure, so this is just to show you that this is a non-invasive procedure you can easily do with all the dogs, especially the ones that are big and have like soft lips. They have a lot of saliva around. So you just hold a piece of food and then you pass this cotton swab into the dog mouth. And we had 49 pet dogs. Half of them were shepherd-like, like Malinois, German Shepherd, and half of them were like hunting-like dogs. So with floppy ears, more squared face, and more soft lips around their mouth. So just to repeat and be clear, our predictions was that we would have observed the stress indicators in the frustration non-social when comparing it to the positive condition, and we expect them, so these kind of stress signals, to be positively correlated with cortisol. And then if a behavior as a communicative component, we expect them to be exhibited more in the frustration social compared to the frustration non-social, and to not be associated with a stress measure. So we analyze everything with DogFACS that I will not explain here because we have half an hour of it afterwards. And these are the behavior that were exhibited by more than 10% of the dogs in at least one of the conditions. This is the statistic we performed, so we consider the presence or absence of the behavior in one of the 5 trials we conducted, and then we model it in function of the conditions. And we had as a control predictor the dog type, so whether they were shepherd or hunting type dogs, the sex, the age, and the trial. Here are our cortisol results. As you can see, there were no changes in the different conditions between the pre and post-test. However, we had an association between the pre-test cortisol and post-test cortisol. So dogs who came to the lab very excited, they also had higher cortisol when they left. But our frustration test did not elicit higher levels of stress in the dogs. So what about the results of this first study? So when we compare the positive anticipation with the frustration non-social, we saw that dogs exhibited higher likelihood of ears forward in the positive condition compared to the negative. And we also saw that this behavior was negatively associated with cortisol. I think that TV is going to power off. So what we conclude was that maybe this behavior is a good proxy for attention. So dogs who came there less excited with lower level of cortisol were more able to stay focused on the food stimuli for the duration of the test. When we compare, on the other hand, in the frustration non-social compared to the positive anticipation, in the frustration condition, dogs move their head on the side more and sniff the environment more. And these two behaviors were positively associated with cortisol concentration. So the same, but also the contrary from what we saw before. Probably dogs who came there more stressed, more excited, less able to stay focused on the stimuli, where the dogs that were also turning their head more away and sniffing the environment, maybe to try to cope with that situation. About the comparison between the frustration human and the frustration non-social, we saw the dogs exhibited higher likelihood of ears forward, ears flattener, nose lick, blink, and also tail wagging when the human was present. And apart from ears forward that we saw above, all these other behavior were not associated with cortisol concentration, suggesting a possible communicative component of the signals. So dogs were performing these signals when the human was looking at them, and not when there was no one there. So these are just some interesting slides I was not able to present in the other Congress because the time was much more shorter. So these are about the differences between the morphologies in the dogs. So we observed that, oh, yeah, okay.
So we need to put the TV. Where is the? Oh wait.
Yeah.
Off and on.
Yes.
So I understand you measure cortisol levels through saliva.
Yes.
So you just how do you have a reference?
The baseline.
Yeah.
Say off.
We didn't have the
Okay.
baseline.
So how do you know? So you have just the pre and the post,
Yes,
right? You don't
exactly.
know.
No, we don't know what is the state, the emotional state of the dog at that time of the day during the other
Yeah,
days of the
because
week, for
they
example.
can
Yes,
change
so
really.
we thought a lot about this. We were thinking about taking 5 days of baseline, but so these are pet dogs who come to our lab, do the test, and then go home. So we
So
should
these
have.
are going to be more stressed out because they're out of their
Yeah,
normal
yeah.
environment.
So these are all dogs that come around the campus because we have a big park or are used to come to like kind of space like dogs that works, maybe do a lot of dog sports and so on. So we didn't observe like also the cortisol level were all very low when they came. But yes, we fought a lot to ask the owners to do the baseline. But there was no way that we could go into 60 owners' house for 5 times in the morning or so on. So we should have need to rely on owners taking the slides. And we thought it was too much complicated.
And why didn't you use urine cortisol?
Julia, could
What
you
if-
please speak into the microphone?
Oh yes,
Yeah.
sure. Why didn't we use urine? Because
Yes.
also that I used urine for my master. We collected the dog urine, and it's kind of much more complex. So we could have done when we came into the lab, but the same, like asking the owner to collect them for maybe 1 week at the same time of the day would have dropped our sample to, I think, maybe 20 dogs. So yeah. Obviously, when you work with shelter dogs or with lab dogs, it's much more easier because you plan your design and you say like, okay, I need a baseline. I will collect this baseline at these hours. And when you work with 60 owners, it's also kind of a little bit of effort to make them come 3 times for the test at the same hours. Because I didn't say it, but they came 3 sessions in 3 different days, and we asked at least to come like more or less at the same hour. So if they came in at 9 a.m. the first time, we asked to come also at 9 the other 2 times to also kind of control for this circadian rhythm of the cortisol.
That's bias.
Yeah. So here are some differences about dog morphology. We observed ears downward much more in shepherd type, no, in the hunting dogs, as you can see here in green. And then we observe ears flattener, much more in shepherd type dogs. And also we observed tail wagging, much more in hunting type dog compared to shepherds. Shepherds don't wag their tail, maybe they're not so happy, we don't know. And what we did afterwards, we also do the same test with a new cohort of dogs. So the dogs who participated in the first study did not participate in the second study. And this time we wanted to see whether there was differences when the audience was not a human but another dog, so specific. So communicative signals are evolved through natural selection to change the behavior of a possible receiver. So our hypothesis was that dogs would have exhibited different communicative signals towards other dogs compared than towards humans. Even because, I will say it afterwards, what do we know about the difference of the interaction between dogs and other dogs, or between dogs and humans? So studies from the Wolf Science Center, that is a center in which packs of wolves and packs of dogs have been raised and kept under the same exactly conditions, show that dogs cooperate with humans to obtain food, but they do not cooperate with their conspecific to obtain the food. So there is this very famous paradigm to test cooperation, is this string pulling test, in which the dogs, or the two animals, that is a dog or a dog or a dog and a human, needs to pull at the same time to retrieve the piece of food. So if just one of the animals pulls, the string will just come out and the apparatus will not move forward. So it's a cooperative task in which you need to wait for your partner to come there and pull with you to obtain the food. And they observed that wolves are very skillful at cooperate, and they pull together and they obtain the food. Dogs are skillful to cooperate with human, even without training, but they are not skillful to cooperate with partners, because what happens often is that a dog can stay close to the apparatus where the food is, and the other dog does not even come close to the food. This is also in line with the fact that dogs, in this kind of situation, so these are packs of dogs that live in this big fence, and they share everything, like space. They are always together. And they observe that dogs do not share food resources compared to wolves. In wolves, there is a lot of aggressive displays going on. They growl at each other. They show a lot of threatening behaviors, but then at the end they share the food. Dogs, a dog comes there, and the first dog that comes and stay around the food resources, the other one does not even approach the food. So they have a kind of more of an avoiding conflict strategy than a managing conflict strategy. And also, as we observe with our owners, pet dog owners are not sensitive to subtle dog facial movements. So we often ask when they come, so when do you see your dog yawning or licking its lips? That is not when he's going to sleep or when he's eating, never. And then the dog maybe has already yawned 3 times and licks their lips a lot of times, and they will say, no, they don't do that. So the scientific hypothesis is, okay, if my receiver does not get my communicative signals, I should not perform it because it's not efficient. So we had the hypothesis that there is a different appraisal of the situation, and also that dogs display different signals. I need to move forward. So what we did, we trained a dog to do what also the human experimenter was doing in the first study. So staying still, and this time looking at the food, because it was a little bit difficult to train the dog to look at the other dog and staying still. So in this video you can see the Rhodesian Ridgeback is my dog trained to look at the food, and the Shepherd is the dog that is tested. So they are confronted to each other, and you can see here that the German Shepherd here puts the ears downward, move the inner brow razor, licks her lips, do a head turn, wags, and then she decides to give up and go to the owner and avoid the possible conflict around the food. So also here, cortisol was not changing before and after the test. What we observed was that when the dog was there, so the first condition, these are the 5 trials, because we did 5 trials of 5 seconds. We can see that the dog is staying in proximity the first trial because they don't expect the other dog to be there, so they happen to be there near to the food. But then on the other trial, when they realize that the dog is always there looking at the food, they just don't even stay close to the window. In the other condition, it's high variability, but they stay more in proximity to the apparatus and the food, even when the human is there. What we found this time, we found that the only behavior that was influenced by the presence of the human, and even not a significant level, was tail wagging. Then we found that on the other hand, when the dog was there compared to when no one was there, dog exhibited much more facial expression and also tail wagging. And when we compare the two social conditions, so the frustration dog with the frustration human, we can see that in the frustration dogs, dogs perform a wide plethora of facial behaviors compared to when the human was there. And there was this time no association between cortisol and behavior, even if the procedure was very similar. Cortisol is a little bit tricky, and this time we could not reply the first study results about the association between behaviors and cortisol. So coming to the conclusion, there is a big difference if we look at the first study and the second study. So in the first study, when the human was there looking at the dogs performed a lot of behaviors. In the second study, the human was always looking at the food. So it can seem like a small difference, but probably for the dog is a big difference, because there are other studies that show that dogs are sensitive to the state of attention of the handler, of the experimenter. So it's possible that just the fact that in the second study the human was not looking at the dog but at the food is the cause of the fact that the dog didn't express all this facial expression. And this is also very interesting, should have been further investigated. So the only behavior that in the first study appeared to be frustration signals, so positively associated with cortisol, are head turning and sniffing the environment, while in general tail wagging and facial expression seems to be very flexibly exhibited based on what audience is there looking and attending to these signals. So we concluded that they could be communicative signals. What do they mean? This is a whole another question that Chiara will now go a little bit into it. So thank you for your attention.
Thank you.
I'm a little bit
Any questions for Julia? I would like to make a request to all speakers. Please repeat the question because the remote participants do not hear the audience. So.
Okay, I just wanted to ask if the difference between cooperation between the wolves and the dogs is because the wolves grow up together in packs and the dogs basically grow up with their owners.
So in this lab is like an outside environment in which these packs of dogs were like street dogs that were brought there as puppies, and dogs and wolves, where they conducted these experiments, grew up together. So same conditions. So packs of dogs grew up with the other dogs, and packs of wolves with the other wolves. Yes.
Then why would you think there was this difference?
Yeah, the hypothesis is that since wolves are a species that is based on cooperation while hunting, they are still selected and keep on this cooperation with conspecific. While in the selection and during the domestication process, this skill of cooperating with the conspecific has changed, and they rely more on humans or on scavenging, because village dogs, as you can see in some countries that are still there, they do more scavenging than hunting together. So they lost this kind of cooperation with their conspecific. Yeah, these are very cool studies. If you want, I can give you the public. These are all public, published data, so you can go on and check on them.
So thank you, Julia, for your presentation. I had a question on vet and my field is veterinary behavior, and I thinking, did you assess the dogs before the experimentation? Are you sure that they are normal dogs?
No.
You take Malinois, for example,
Yeah.
they have a strong tendency to develop sort of hyperactivity,
Yeah.
ADHD, with low tolerance to frustration, and then perhaps you will have sort of misinterpretation in your results.
Yeah. So the question is whether we took into account the previous experience and the sociability of the dog, the level of excitability, and so on.
Yeah.
So yes and no. So we theoretically know that, but we didn't have a test that was assessing dogs' personality. Actually, this was one of the things we discussed, because, as you said, obviously they can be very big differences between also the positive anticipation and frustration. Because you saw my Weimar runners, they were just there. Okay, you move the food away. Fine. Not doing anything. We had Malinois and we had Shepherd that tried to pull down all the apparatus. So this is for sure like also probably one of the cause of the difference in behaviors we saw between hunting and shepherd. But then another point, the very important point, is when the human is there. Because we had dogs, also from search and rescue, or dogs that were very used to do things to obtain food for a long time, because they were dogs that were doing sports. So when there was a human condition, they were suddenly like, okay, you don't give me the food, I will sit, I will lay down, I will do this, I will do that. And then there were other dogs that are less used to perform behaviors for the humans that were not doing anything. So that's also why in this paper we said, okay, there can be a communicative component, but we don't know what they mean because we had this different variety of dogs. So we would need to do more specific tests to see, okay, we just select sociable dogs that are positively attached to humans, because we also had dogs that when we were looking straight into their eyes, they were like, oh my God, you want to kill me, and they were just going away. So there was a big difference, yes, between the different dogs. Cool.
Do you know anything difference between stray and pet dog communication? Between dogs and between dog and human?
Yeah, so there are a lot of studies conducted by the Veterinary University of Vienna, the Veterinary Medicine University of Vienna, because they have a free-ranging dog project in Morocco in which they study free-ranging dogs. And they also had some studies in which they tested dogs in Vienna, and then they tested the street dogs on the same kind of test. Obviously, then the conditions are a little bit different. But if you want, I can email you the study that are published, and just like you can have a look at them. But they didn't do anything still about specific signals, so they were doing a study about the preference between petting and food. So there was an experimenter giving the food and an experimenter giving just petting, and they saw that there were no actually difference. So dogs, street dogs and also pet dogs were choosing more or less on chance level to go to the person who was petting or giving food. So yes, there are interesting studies about that, but there is not a very easy and simple, straightforward question about this.
Any more questions? Julia, I have a short question. Stress, does it have an emotional component? You said it is a response of the neurosystem.
Yeah, so I think as I showed it to you, stress is the activation of the system. And then we need to combine it with the appraisal that the dog has to the situation. That can be positive, can be negative, can be based on previous experience or also on learning. So if a dog is trained to perform behaviors, when the food is there, he will be excited and in very cognitively active and trying to perform behaviors. So we always need to put the stress, the activation of the organism, into the history and learning experience of the dogs to evaluate. And we need to try to assess these before the test and select and have this into our mind.
Yes. Thank you so
Thank
much
you.
for this amazing presentation. Thank you. So now to our second speaker, Chiara Canori. Are you ready?
May I ask you to just move the computer here? Thank you.
And we need to, the TV is off again, so...
No, because the presentation is over.
Okay.
No, the presentation is over. Thank you. Annika is right after. Yes. Okay. Welcome everybody. I'm Chiara Canori from the University of Parma, and first of all, I'm so glad to be here presenting you my research project. My presentation, which I hope will not be repetitive after Julia's, is entitled Unraveling Canine Diplomacy, Investigating Dogs' Communicative Signals Through Video and Audio, which is what we are doing right now in our research group. So, first thing first, what am I going to present? After a little bit of an introduction, again, a short introduction to not be so repetitive after Julia's speech, I'm going to present the training approach study, which has been already published, what we did and what we couldn't afford, and then what brought us to now, so what we are doing right now, and which comes up to the video study, which is a study we performed this year, and what are we planning to do again. So a little bit of an overview about dogs themselves. So I think everybody here knows that dogs descend from wolves, from which they've inherited a high sociality and also a complex communicative system for social interactions. Of course, they're the first domesticated animal ever. They've been domesticated about 18,000 to 32,000 years ago, but lots of studies are prone to move this date even farther. And dogs have been bred not only for their socio-cognitive abilities, but also, and especially, for their ability to formate strong social bonds, not only with other dogs, but also with humans. In fact, dogs have two main social partners, which are other dogs, so conspecifics, but also an heterospecific partner, which are us, humans. And also, another thing that dogs have inherited from wolves is a complex visual communication. Julia little explained this to you, but again, wolves and dogs shared this visual communication, which includes not only postures and wagging of the tail or vocalizations, but also displacement behavior, as much as more subtle behavioral displays, such as changing in facial expressions. So some of these very same behavioral displays have been identified differently in dog scientific literature. They've been identified in classical ethology literature both as displacement activities and self-directed behavior. Displacement activity, again, is common to be seen in situations of motivational conflicts where the animal is prone to perform different behavioral displays all at once, so they do something else. And also self-directed behavior, such as self-scratching, yawning, or auto-grooming, are considered to be indicators of frustration and stress and social anxiety. But also, in the late 90s, they've been identified as stress-related behavior. So some of these behavioral patterns, such as lips licking, snout licking, yawning, sniffing around, have been identified to be performed as a coping strategy in stressful situations. But I'm not done here, because the most interesting part is that there's another hypothesis, which is the appeasement signal hypothesis, because some of these very same behavioral patterns have been also identified to function as communicative signals, as appeasement signals, reducing the likelihood of aggressive behavior in the social partners. So yes, foundation for the appeasement signals hypothesis are to be found again from Michael Fox's books, so it came out from the 70s, because the foundation is the cutoff signals hypothesis found in Canis lupus. So wolves have been observed to use these behavioral patterns, which includes lips licking, snout licking, submissive postures or actions, as much as ears flattener or sound postures again, and subtle changing in facial expressions to cut off an aggression between pack members, but also to avoid conflicts between pack members. So as every other signal in the animal world, we have a signaler that change the behavioral patterns of one or more receivers, which wolves are all conspecifics again. And this makes possible this to work correctly. But then, so now that we are up to this, we know that there's the cutoff signals hypothesis, we can take a step forward, which is the calming function of some of these behavioral patterns in dogs. So these very same behavioral displays have been identified in dogs but with a slight difference, because dogs are conflict-solving animals, and according to this hypothesis, they avoid escalation and conflicts since the very beginning, and also use this behavioral pattern to reconciliate following a conflict. But the interesting point is that dogs are probably prone to use these behavioral displays not only towards other dogs, but also towards humans, because again, we are the other main social partner of dogs. So I do think that some of you might have been familiar with this book, On Talking with Dogs by Turid Rugas, which is the book in which is raised the calming signal hypothesis. It came out in the late 90s. But again, in the dog scientific literature, I've identified some of these displacement activities differently. Here I just reported you a few of the studies that identified the behaviors on the left, such as lips licking, nose licking, yawning, paw lifting, and more. We have a whole file with these behavioral displays identified in dog literature as stress-related behavior. And so the connection between these behavioral sets and stress is strongly backed by observational evidence. Several authors, therefore, do not recognize the intentionality of these signals and their presumed communicative function, and they assume that they are just the results of arousal caused by stress, as Julia stated to you. But, okay, now we have to take a little step back before talking about appeasement signals. And why do we need to take a step back? Because before talking about calming signals or appeasement signals, we still have to understand if they are communicative signals, because we still do not know that. Are they stress signals or are they communicative signals? It's a step back from the appeasement signal hypothesis, but it's still something more than just, the displacement activities, they're just related to stress and frustration. And this brings us to the aim of my research project and our research questions, which are they communicative signals, which is probably the more general questions, the great general questions, but it's also, I think, the most difficult one to answer. Are they more expressed in conflict-ridden situation rather than non-conflict-ridden situation? And do they elicit a feedback on the receiver? Our general prediction is that dogs would exhibit displacement activities more frequently when exposed to conflict-ridden situation rather than exposed to non-conflict-ridden situation, if everything I've just said is real. And this brings us to the training approach test, which was one of our first studies. The paper is online, so you can find it on Animal Cognition. The aim of the study was to investigate whether displacement activities, also identified as appeasement signals in dogs, are exhibited more in conflict-ridden situations versus neutral situations, which were an unfamiliar human approaching them in a threatening or a peaceful manner. So the hypothesis is that, again, some behavioral displays have an appeasement function and are used to prevent or reduce conflictual situations. And our prediction is that this behavior should then occur more in conflict-ridden situations rather than a neutral one. Fast background on the training approach test. The TAT was firstly validated in early 2000 and is a paradigm that investigates dogs' reaction to various cues and consists basically in exposing dogs to threatening or neutral/friendly situation. Basically is one or more unfamiliar human approaching them, walking, threatening, screaming, threatening them, or just peacefully smiling, etc. The training approach test has been applied, of course, to study coping styles in police dogs, again, aggressions in shelter dogs, as much as to evaluate dogs' attachment to their owners. And interestingly, in 2017, this work from Finks and colleagues investigated the two behavioral displays, which were lips licking and head turning in dogs exhibited in 19 different situations, including human approaching them in a friendly or a threatening manner. They basically found out that head turning, so turning of the head, was basically more common during threatening stares and screams rather than friendly gestures. And also lips licking was more frequent in response to threatening stares and friendly greetings rather than threatening screams and physical threats. But limitation of the study was that they basically exposed all dogs to the 19 stressful situations all at once, always in the same order, so it's actually difficult to split if the response was specific to a certain test, a certain trial, or to the general stressful situation itself. So up to what did we do? We tested 53 dogs. It was a within subject design, so each dog underwent both the peaceful approach and the threatening approach. As you can see in this little scheme on the left, we had the stimulus, which was an unfamiliar experimenter, hidden behind a green panel, and there was a camera person that just gave the start. The stimulus recalled the dog's attention by whistling a few times and then just came out from the green panel in a peaceful / neutral manner or in a threatening manner, and then just stood there behind the camera at about 3-4 meters from the dog, which was leashed and behind the, besides the owner the whole time, and kept their threatening or neutral expression for 30 seconds. So basically, this is what I just explained to you. The stimuli were different female experimenters, which were, all of them had their hair pulled back and dressed in a similar manner, so to avoid bias. And the threatening human basically worked out the green panel with a bent position, staring still at the dog that we know to be a mild threatening signals for dogs, and never averting their gaze with their hands behind the back. While the neutral human or the friendly human just walked out the green panel in a natural manner with relaxed position, averting often its gaze from the dogs, so not staring still at them, and smiling the whole time. This is basically one video that showed how it worked with the friendly human. So it was a third signal, the experimenter whistled, and then just walks toward them. This is it, so just went like that. And this is an example of the threatening human approaching. Okay, and then after testing all the 53 dogs, it came to the behavioral coding, which took us a long time because we developed 2 different ideograms, one with facial actions and the other one with general behavior, including postures, vocalization, displacement activities, self-directed behavior, etc. While coding, it came up that dogs actually assumed 2 different attitudes toward the experimenters. There were dogs exhibiting offensive defensive behavior, such as growling, lunging, barking towards the approaching experimenters, and dogs which just stay there, chilling passively. Then we categorized the first dogs as reactive dogs, and the second as non-reactive. Everything was coded by Solomon Coden and then analyzed thanks to R. And basically, we modeled our model basically analyzed the interaction between test conditions and attitude and analyzed the frequency or duration of these displacement activities. And we did find out that displacement activities of blinking, nose licking, and lip wiping basically were more expressed by non-reactive dogs regardless of the condition. So it didn't matter if the approaching human was threatening or neutral. The less reactive dogs were the one signaling more, basically. While head turning was associated, again, with no reactive dogs, but in the threatening human condition. So no reactive dogs, while the human approached them in a threatening manner, were more prone to do this, so just turning the head. And now I think it's an easy question to to do what about an interspecific encounter, of course, because yes, we did test dogs with their interspecific partner, but what about conspecifics? Obviously, I think it's quite impossible to have something like this tested in a standardized way, because yeah, this is my dog's doing different social classes and he acts quite differently, even though those two dogs are familiar with him. So what about a training approach test with intraspecific? Well, we actually did that. As you can see, this is unpublished data because we tried and it was a failure. Because even though we thought to be a standardized test, there were actually standardization problem again. I'm gonna show you in a few moments. We tested 50 dogs. Again, within subject design, they were approached by a friendly or a threatening dog. The threatening dog were also indicated by dog training facilities, so we do know for sure that those dogs were indicated as dog-reactive dogs. So they were reactive in their everyday life, but when it came to our test, they basically were not. Out of 50 encounters, we were able to have just 4 truly threatening reactions from dogs. So this is an example of the threatening approach test. These 2 dogs were supposed to have the threatening approach. So on the left, you will see a German Shepherd, which was supposed to be the threatening dog. And, well, you will see in a few moments that she's everything but threatening, because she came out and then averts her gaze, starts sniffing, averts her gaze again, wipes her lips, then came there, rolls a bit, and then starts crying, and the other dogs became more reactive than her. So yes, this is one of the best tests we had, so it was a mess. And
do you think it would be better if you would be in a more controlled room? Because it seems like the dog is very distracted.
This was a question that we got, but we tested these dogs in different facilities, and we also had different spaces, and few of them were smaller than this, so there were less distractions, but again, the reaction was the same. So we do not think that there was a matter of the environment. Yes?
Did you ever try the video of the dog?
Yes, this is what I'm going to, exactly, that's the next point. So this brings us to exploring canine behavior through videos. Exactly, you spoiled that for me. So yes, how did we manage to solve the problem? Basically by using videos. Because why videos? Yes, it allows standardization. With just a few good videos, we can test a large amount of dogs, and also it's been successfully validated by previous study. Quick overview again on the state of the art. So this is a paper from our colleagues from Padua. They basically try to assess whether dogs are able to recognize a video of conspecifics, and so recognizing a dog as a dog. They show videos of dogs or an unfamiliar quadruped species, which were cows or horses, depending on which species they were familiar or not, following either a dog's vocalization, so barking twice, or another unfamiliar sound, which was a frog croaking twice. Basically, this test consisted in, they had this large television, and this dog, which was a natural-sized dog, walked in, stood at the center of the video, barked twice or croaked twice, and came out. And the same was performed with the horse or the cow itself. Again, it was within subject design, so each dog underwent 4 trials, one with the dog barking, one with the dog croaking, and one with the other mammal species barking or croaking. And they found out that dogs showed greater interest at the barking and dog pairing, which could imply a conspecific recognition towards video, yes. And also, this is another study performed by Albuquerque and colleagues, which focused on the mouth-licking behavior, and they basically investigated dogs' ability to perceive and differentiate expressions, so angry and happy expressions of humans and dogs, and understand whether dogs can actually respond to this information. They basically present dogs a combination of facial expression, so angry facial expression, of happy facial expression of dogs and humans, combined either to a neutral vocalization, which was a Brownian noise, or a positive vocalization, or an angry vocalization. They focused on the mouth-licking behavior, and they found out that mouth-licking was more frequent when dogs were looking at negative faces, especially when looking at humans' negative faces, which may imply an emotional understanding of these expressions, and also that the mouth-licking behavior might have been selected for facilitating dog-human communication. As Julia explained to you, other studies underline the fact that we are not so good in recognize dogs' communicative system, but probably they evolved something to communicate with us. And now, coming back to this, which I've already shown to you, I can add my methods, which is exposing dogs to videos of different conspecifics performing threatening or conflictual behavior, which we hope that solve the problems we had with the threatening approach test between conspecifics. So this brings us to our first video study. This was our flyer to tell people to come and test their dogs. And this has also been up for a few weeks now, so you can find on Applied Science. The principal aim of the study was basically exposing dogs to a standardized conflict-ridden and non-conflict-ridden situation and measuring the occurrences of displacement activities and facial expression according to the DogFACS. The hypothesis, again, is that some behavioral displays serve an appeasement function and are used to reduce conflicts. And then we expect this behavior to be more displayed towards threatening conspecifics rather than a neutral one. But in this case, we also had a secondary hypothesis, because it has been proven that dogs' behavioral reaction can be elicited by social relevant conspecific auditory cues. In this paper from Farragut and colleagues, they basically concluded that dogs are capable of recognizing a dog's growling and matched with a different dog size. So we do know for sure that dogs can have reactions that can be elicited by a relevant auditory cue. But we do not know if the visual cue is enough to elicit a response. So our secondary aim was investigating whether the visual component of the stimuli could elicit an appropriate response for dogs. And this brought us to the inclusion of an artificial sound. So basically, we created an artificial, non-species relevant auditory sound, because we knew from the other studies that species relevant sound also can elicit some attention from dogs. And in this case, the auditory element could have played a significant role, and then we expect a higher occurrences of these signals in conditions linked with the natural sounds, or either could not have any role in eliciting a response from dogs, and in this case, we do not expect differences between the natural or the artificial audios on the behavior of the tested dogs. So what did we do? Basically, we recorded two different stimuli, which were comparable in both size and morphology. So we had a female Weimaraner and a female Rhodesian Ridgeback barking threatening or just having a natural attitude. Everything was recorded in a natural background with a natural ground, and then of these long videos we collected and cut some seconds. To maximize the ecological validity of these reactions, we had these dogs barking in front of another dog passing by the fence area, so the dogs were actually being threatening, so the bark was not just asked for them, they were actually barking towards another dog, so it was a real reaction. And basically our two auditory cues were barking or just panting for thermoregulation due to heat, so a natural reaction. And this is an example of our videos with natural sounds. an example of the same videos with the artificial sounds. I don't think PowerPoint messed up with the panting, but okay, this is it. As you can see, the frequencies, the amplitude, and also the hertz of the artificial sounds is the same of the natural sound, because we modeled the artificial sounds with Adobe Audition based from the natural sounds, and the Rhodesian had a lower barking that we registered with a phonometer, so we had the higher frequencies for the Rhodesian, because when we made her bark inside the testing room to have our natural reaction again, she had a louder and a lower barking than the Weimaraner, so we had a natural reaction again. And here's an example of how our test went. Each dog was tested twice the same day. They could either begin with one or the other dog, with the natural or the artificial sounds, and with the one on the other reaction. So in this case, the German Shepherd began with the natural Weimaraner barking, and soon after this first video, she undergoes to the same videos with artificial sounds, and then after 5 minutes of a pause, she began again with the opposite video, so with the Rhodesian panting artificially. Since it was counterbalanced, other dogs began with other videos order, of course. And then there was the okay, and there's the other side. And it went on like this, and then again, after 5 minutes of a pause, she had another session. So then it came again to the behavioral coding. We coded everything according to the DogFACS and also according to a general behavioral histograms, which includes postures, vocalizations, locomotions, and also the wagging of the tail that we did not register, actually, as long as displacement activities and self-directed behaviors. Everything this time was coded with Boris, which is Behavioral Observation Research Interactive Software, a software developed by our colleagues from the University of Turin, which works basically on everything from Linux to Android. And what did we find out? Basically that regardless of the auditory condition, dogs looked significantly more at the threatening videos rather than the neutral videos. They basically were more interested in dogs barking rather than dogs panting, of course. But then, oppositely to our predictions, behavioral displays of blinking, sniffing the environment, yawning, lip licking, and nose licking were significantly more expressed in the neutral condition and not in the threatening one. So here the reference level is the threatening stimuli and the estimate is negative, so all these behavioral displays were more expressed in the opposite reference level, which was the neutral one. So what about our findings? Both studies showed some analogies, also in the results we found out. So the threatening approach study showed that no-reactive dogs showed more putative appeasement signals in both conditions, so the threatening approach in human as much as the neutral approach in human, suggesting a possible link of these behavioral sets with a non-aggressive attitude. And the video study showed that displacement activities seem to not be used as appeasement signals to interrupt aggressive encounters, but rather in potentially ambiguous contexts. So I don't know what you're doing, so okay, white flag, I'm doing something else. And so this was the research question we tried to answer with these two studies. This was our prediction, and it looks like they're not like we thought. And these results suggest that displacement activities are not used as appeasement signals to interrupt threatening behavior, but may rather be exhibited in ambiguous contexts when the behavior of the dog or the person is most difficult to predict for dogs. And coming now to my last research question, which is, do displacement behavior elicit a feedback on the receiver? This is actually my work in progress, and now I'm coding the behavior, so hopefully in the here we have some answers again. And last but not least, how artificial intelligence can help us in coding the behaviors, because in our research we face the challenge of manually coding dog behavior, a time-consuming process because we have months in coding all these behavioral patterns. First of all, due to its efficiency and accuracy, it can help us have unbiased analysis and also reduce the manual effort. But it can also help us in visual attention detection. I don't know, I think it could help us in tracking if the dog is actually looking at their stimuli or something else, and also to have a general pattern recognition. Behavioral patterns are consistent or different in response to certain stimuli. Final, are the signals calming signals or stress signals? Further research is still needed, but hopefully in a few years we'll have some answers. Here's the long-lasting references, and yes, just thank everybody for the attention. If you have any questions, I'm here to answer. Thank you so much.
Thank you. If you have a question, please repeat it.
Yes, of course.
Any questions to Chiara? I think this is...
Okay.
Thank you, Chiara, for your
Thank you.
presentation. I have questions for you and for everybody.
Mm-hmm.
Finally, can't we categorize these two types of reactions? There is one which is very minor reaction, licking lips and yawning, which are more emotional and even perhaps conditioned. And they are not like cognitive reaction, not voluntary reaction. And the others like barking and waging tails or whatever, which are more intentional, cognitive, which is not the same part of the brain, finally.
Okay.
And I was thinking that your results perhaps show that the dogs that didn't react for the aggressive dog, but react to the not aggressive dog, like only with licking and blanking and everything, was going through an emotional reaction, but he has enough inhibition not to go inside a cognitive reaction. You understand? So
Yes, okay.
I'm trying to translate it even in what is happening in the brain.
Yeah, basically, I was asked if there's some differences in the control, actually, the dogs has to not react as reactively as it can be a barking or a lunging or a wagging the tail when performing less intentional or as light as behavioral cues such as lips licking or blinking or else. Did I understood correctly? Yes?
Yeah.
Well, actually, we can't assess the intentionality of this behavior yet. So probably some dogs are less prone to act reactively. Probably this could be due to breed issues, breed selections. We did not assess for breed selection in this last test, so we do not know if, I don't know, by testing all Malinois and then all Golden Retrievers, we could have different attitudes also, I don't know, derived from breed selection. But yes, I do think that probably there's some inner control in the reaction dogs could have in choosing if having explosive and no reaction towards dog approaching them in a threatening manner or a human approaching them in a threatening manner, rather than just decided to avoid conflicts from the beginning. I think this is actually, it can be, I don't know, probably a result from their personal experiences, personalities. It depends from a lot of what's going on in their life, what are their social experiences, what is, I don't know, their relevance.
Can I
Oh, yes?
something? Yeah, I mean, this is really our question.
The intention.
Because sometimes it seems just an emotional reaction. Like
Yeah.
even if you look at dogs, also, I mean, we all have dogs. Also, on personal experience, sometimes it's like, okay, they are nice because they de-escalate, and you say, okay, they are de-escalating because they are controlling themselves, so they do displacement behavior just to help them to release the tension. But some other, especially for the dog-dog interaction video, we have interaction in which you see like a dog coming there, maybe a little tense, and then blinking, turning the head, and then the other dog also de-escalate. So the question is, do they mean, like, do they intentionally express also this, or is just
A
a
reaction.
physiological
Exactly.
reaction?
Exactly.
But by now we
We still don't know.
Many
That's the
tests.
problem, actually.
I
It's not-
think the feedback of
Put an eye on them.
the feedback of the receiver is the main
Okay.
point that we will maybe answer, but we are having a lot of difficulties getting this.
I have a very technical question. Looking at the videos that the dog were watching videos, you chose two angles of the cameras. One was from above,
Yes.
and the other was also from a bit of. I
Okay.
would expect you to focus on their faces or see, because they were moving their faces. You can see more faces.
Okay.
And it would be easier to analyze the expression.
Actually, this was a technical issue we had because we planned to have multiple cameras inside the room, but we did have some problems with the USB connection, so we couldn't afford to have more than 2 USB and the video recording at the same time. So we plan to have 4 cameras, 1 frontally, 2 laterals, 1 from above, and then the video all processed at the same time. But unfortunately, we couldn't afford to have all of this. We tried different programs, and we had to make a choice. So we chose for the frontal camera and the most lateral camera that allowed us to record the whole room. But yes, the preferential choice was to have multiple cameras for more details on the facial expression movements. Yeah, so yes, it was planned, but unfortunately it didn't work out.
Any more questions?
I think you mentioned that you work with both police dogs and shelter dogs.
Yes, the training approach test was actually validated also for that, yeah. I did not work with police dogs or shelter dogs, but the training approach test was validated also by testing those dogs.
Did you notice any general differences between or maybe police dogs were less reactive because they're more used to situations when you
Sorry, I couldn't
Can
hear.
you speak up, please?
Yeah, sorry.
well, I would assume that maybe police dogs are more used to be in threatening situations
Mhm.
than shelter dogs, or maybe it's the other way around. But did you notice any?
Okay, actually, there were different studies, so it was not the same studies assessing common strategies in shelter dogs or police dogs. There were 2 different studies. I've just reported to you to have a general state of the art of the paradigm. But right now, actually, different studies are also assessing the training level of the dogs when comparing them. So it's often put in if there are advanced trainer or also medium training or just intermediate training or no training at all. So different studies also control for this, but in that case there were 2 different studies. You're welcome.
Was there any, did you got to, and the size of the dogs, was it manipulated in some way? Was it the normal size?
Oh, okay, yes, sorry, I thought I said this. Yeah, I was asked if the size of the dogs shown in the video was the natural size or manipulated. No, they were natural size dogs, and also the sound was natural. So we had both the Weimaraner and the Rhodesian in the room. We basically measured them next to the screen, so we had the natural size of the dogs, and also made them again bark or pant after a run inside the room to have also the same audio as natural.
Yeah, we have a question from YouTube. So, a great deal of dogs' reactions depend on proxemics, as far as I can tell. Did you take that into consideration for the video part?
Could you please repeat?
Okay, yes. So this is a question from YouTube, since a lot of dogs' reaction depends on prosemic, and if we did take account of that for the video part, actually, no, we did not. So yes, but this was also due to the fact that the room was not much large, so we had, yeah, exactly. We don't have the. It's not like 3D exactly. We also don't know how dogs perceive video actually, so we just have this 3 per 4 meters long room. So we have the screen there, and as much as we try to measure, and yes, it was actually homologous, so it's not like some dogs could go under the screen and some others are behind the back, behind the front and the head of the room. But yes, we did not take this into account because, again, we don't know how dogs also perceive the videos. So.
I mean, they have all the same distance.
Yes, it was 1.5 meters. They were, I also shown this here. As you can see in this slide, the dogs could not go after this one red striped line on the floor. So all dogs were about 3 meters to 1.5 meters to the screen, but not under the screen. They could not just came under the screen. But this was the best we could afford with our room and facilities.
And the problem is that you want clear videos, because if you allow the dog to move for long, then you don't have the videos.
Okay, any more questions? So I have
Okay.
a remark. Chiara, I really enjoyed your presentation, and I really liked your remark about AI and its function. I would like to add that the role of AI should not only be for behavioral coding, because in our lab we call it twisting the machine's arm to think like a human. So the best you can get using this approach is being a very good expert like you. But another potential way is to unleash the potential of AI and ask it, do you see any difference in these two situations? And we already have seen in our research that even if there is no presence of action units, the machine still sees some signals there. So behavioral coding would be maybe the first step, but we would like to also go much further with AI and really let the machine discover some things that the naked human eye cannot see. So thank you so much.
Thank you.
So our next presentation is by Annika Bremhurst, and she has pre-recorded the presentation, and she will be available for questions on Zoom. So 1 minute, we will set up the recording. And our apologies for this inconvenience. And after this talk, we will have our coffee break. So while Narid is setting up, I will explain a bit. So Annika has been working with our lab for quite some time, and her data was actually the first time that data collected in a controlled environment was used for AI analysis of facial behavior of dogs. And Tali Bonet-Chitrit will explain her part later today. She's here already.
Hello, my name is Affective.
One second. Can you hear?
From DogFACS, and I'm really happy to present to you today my talk with the title From Observations to Algorithms, Canine Science Foundation for AI-Driven Dog Emotion Analysis. So my talk today focuses on the scientific process of collecting, analyzing, and interpreting behavior indicators of canine emotions. And this lays kind of the foundation and the basis and is the groundwork that is required when we want to develop AI algorithms that should be capable of detecting canine emotions. And this intersection of behavior and computer science and technology is really an emerging field in behavior research. So when we want to kind of develop an AI application for detecting emotion states in dogs, the task that we have ahead of us is twofold. There's a two-step process. The first step, and our immediate goal, is to understand and document emotional expressions in dogs and to establish reliable and valid behavior indicators of emotion. And kind of this is the foundation and the groundwork that sets the stage for our second part, for the development of AI algorithms that can then kind of recognize these behavior indicators in order to infer on a dog's emotional state. And the focus of my talk today is really strictly on the left side, so on this initial part on the behavior research. And this kind of sets the stage for the subsequent AI modeling. So what I will do today is that I will cover some of the key aspects that aim to establish behavior indicators of emotions in dogs. And I want to take you kind of through this journey that we usually do in our canine behavior research and essentially some of our kind of key aspects and key thoughts or decisions that we have to take when our goal is to develop and to establish emotion indicators in dogs. So what I've done for this talk is that I created 4 different parts. The first one is the conceptualization of emotions in dogs and other species. The second one covers the data collection that we do when we want to kind of collect data on emotional expressions in dogs. The third part is on the data analysis, and the fourth part is on the validation and the future direction. So let's start off with the conceptualization, and I want to kind of initiate our discussion by setting kind of this very conceptual boundaries, namely what are exactly emotions? So how can we define them? And emotions are usually seen as very short-term affective states, and these states are considered to be activated by specific stimuli that are also labeled as emotion competence stimuli and Wearable. I will present to you which types of stimuli these are in the next slide. But it's important to consider that the stimuli, that environmental stimuli that can trigger emotions, have to be of personal significance to the individual. So I just said that there are certain triggers that trigger emotions, and these are typically rewards and punishers. So whenever a reward or a punisher is anticipated, is present, it is omitted or removed, different emotional states can be triggered. So the key takeaway here is that emotions are not just random, but they are reactions to a certain specific stimuli that are of significance to the individual. So what happens when an individual is experiencing an emotion? The emotions are considered to be multi-componential phenomena. This means that whenever an individual experiences an emotion, different types of changes are triggered that accompany the emotion. We see subjective components about feeling states that accompany an emotion, behavior changes, physiological changes like for instance changes in heart rate, as well as changes in cognitive processes that all go together with the experience thing of the emotional state. And the purpose of my research and of this talk today is on the behavior. Why? The behavior has some advantages. Behavior is always kind of observable, so we can collect the data not in a non-invasive way. And behavior can also be assessed kind of in a very wide range of different environments. So this offers you a really broad applicability. And it means that we focusing on behavior, in the behavior component, in order to infer on emotional states in dogs, really has some advantages. But I've just said that different kind of types of emotions can be triggered. So, what kind of types can we differentiate? And there are two main approaches or two primary frameworks that we usually can kind of differentiate in emotion research, which is the dimensional or the discrete framework. In the dimensional framework, this means that we differentiate between different kind of dimensions within an emotional space. And usually this covers dimensions like wavelengths, meaning that we differentiate between positive or negative emotion. And this discrete frameworks really look at emotions more as unique entities, like for instance fear, frustration, or happiness. So they are really very discrete entities, each with its own set of behaviors and also physiological responses that accompany this very specific emotional state. And in emotion research, what's also important is really to translate our kind of theoretical constructs into empirical research. So this means that it's really essential to operationalize emotions, which involves providing concrete and measurable criteria for each emotion under our investigation. So take, for instance, frustration. So we could define frustration operationally as occurring situations where an expectation is not met, such as, for instance, when an anticipated reward is either unattainable or diminished in quantity or quality. So the aim with this operationalization is to turn a rather abstract emotion concept into situations or contexts that are empirically measurable and then testable. And I've just spoken about emotion indicators. So what are emotion indicators? So those are empirical variables such as behavior expressions that reliably represent the specific emotion under our investigation. So those behaviors qualify as emotion indicators that are consistently observed across different situations and contexts where the certain emotion in question is present. So think, you can think of emotion indicators analogous to diagnostic tests in medical sciences. So they offer really objective, measurable criteria. And the reliability and consistency of those indicators are critical not just for our scientific understanding, but also for the effectiveness of the AI models that we want to develop subsequently. And the quality of those indicators directly impacts the performance and the reliability of those of this AI-driven emotion analysis. But now let's come from kind of this theory and concept to practice. So as we transition from our foundational principles to the more applied aspects of this research, I suggest that we focus just on a single emotion as an example that could kind of guide us through the remainder of this talk. And I would like to focus us on the emotion of frustration. So operationally, we can define frustration, as I've already said, as an emotion that occurs when an expectation is not met, such as when an anticipated reward is inaccessible or reduces data collection and also the data analysis in this blog. So please keep frustration in mind as we proceed. Okay, so I now want to focus us on the data collection. And if we want to collect data on emotional expressions in dogs, we first have to make one very kind of fundamental decision, namely where do we want to collect our data? So what's our study environment? And here we can differentiate between two different settings, namely a natural setting and an experimental setting. And both have kind of advantages, but also kind of things to consider with regards to kind of the validity of our emotion indicators. So natural settings allow us to study naturally occurring emotions, and they give us really real-world conditions, but they can counter a certain set of uncontrolled variables. In experimental settings, we can experimentally trigger a certain emotion that we want to study, and this also allows us to kind of, or gives us a better controllability of additional variables. However, it might not be always reflect what happens in a broader or more natural context. And usually our research question dictates which setting we want to use. So if you're trying to identify reliable indicators of an emotion like frustration, then on the long term, using both settings, so natural and experimental settings, where in both settings we look at which behaviors are consistently expressed whenever the dog is kind of in a frustrating state. This is really vital for the reliability and validity of our emotion indicators. So, however, let's now decide that we want to use kind of an experimental setting in which we look at behavior expressions that are accompanied to frustration in dogs. So, if we have now decided on experimental setting, I've already said that we need to induce a certain emotion that we want to study. So, emotion induction means this is the planned triggering of the particular emotional state, the frustration that we want to look for. So, this emotion induction is usually guided by our operational definition that we have established, as I described earlier. So, for example, if we are looking at frustration, our experiment could involve a setup where our dog learns to expect a reward, and then suddenly doesn't get a reward or gets less of the reward than expected. And it's really important that a proper planning and validation is conducted, because it's really crucial to make sure that the experiment really causes the emotion that we want to study. And I would like to show you an example here, because in my research I looked at positive identification and frustration in dogs. And as I said, so we created an experimental setting in which we could induce and elicit frustration. So dogs first learned to anticipate a reward to come within a certain experimental apparatus. So you will see now on the left side of the video how this works. So the dog learned to approach this apparatus, and after 5 seconds, a reward was delivered. So we created kind of an expectation state in the dog to always kind of get the reward. However, suddenly, and as you can see in the video on the right side, so exactly the same happened. So the dog was removed of sleep, so approached the apparatus. After 5 seconds, the reward was delivered, as always before. However, now there's always kind of a transparent window in between, and now this window doesn't open. So the dog can see the reward, however, the dog can't get the reward, which we assume to trigger frustration in the dog. And then we can look at the dog's behavior response in this frustration state. So what's really important, but often underemphasize is the validation of this emotion induction. So it's really important that you kind of validate that your experimental setting that you can create it in order to elicit a certain emotion you want to study really triggers the emotion that you want to study. And what you can do is that, for instance, you look at physiological or behavior markers or proxies of these emotions. So certain, let's say, behavior markers that have been associated with frustration in previous studies. So you should find them in your experimental setting in order to make sure that you're really triggering the right emotion. You can also use pilot studies and expert consensus in order to kind of validate that you're really triggering the certain emotion that you want to trigger. And that's part of the validation is with regard to the emotion competence stimuli. So as I said, both reward and punishers, they function as emotion competence stimuli, but it's really important to note that such stimuli that trigger emotions must be of personal significance, as I've already said in the beginning. However, this can vary between individuals. So in other words, not every reward or every punisher that you consider to be effective must necessarily be kind of experienced by each individual as such. So the validation process becomes not just kind of best practice, but it's really important with regard to the experimental integrity and that you really make sure that these reports or punishers are really experienced by the individual as such. And for this purpose, we can use kind of, for instance, preference tests for reward and aversion tests for punishers. That because they really allow us or can allow us to be kind of first steps that make sure or that shows about the efficacy of these stimuli on an individual basis. And the last part I would like to discuss with regard to the data collection is the subject selection, because with dogs that's really a very important decision. You know that dogs can be really highly variable. So we know that dogs are the morphologically most variable mammalian species on Earth. And it's really important to decide whether you want to focus on a certain breed or whether you want to focus on kind of a selection of certain breeds or study dogs in general. So the choice kind of the study subject is not just a logistical decision, but it's also a strategic one, because it can really significantly influence both the internal and external validity of your study and also the data sets you are generating and the AI model you train with this data set. So it's really important to note that it could be that in earlier stages of the AI development, a more kind of narrow approach, so just focusing on one or some breeds, can really improve kind of or make the model training easier. However, it may restrict the model's generalizability, which then has to kind of be worked on in subsequent studies where you test kind of for different dog breeds or different types of dogs. But as I said, that's a really important kind of basic decision that you have to do with regard to your data collection. Okay, so let's now think that we have collected all the data that we wanted to collect in an experimental setting with dogs experiencing frustration, and then we want to analyze this data. And for this data analysis, we have again we are confronted with different decisions that we have to kind of make when we want to analyze this data. The first one is levels of behavior we want to look at, because behavior can be really complex. And we have to decide how, which level of behavior we want to look at. So there are kind of different options. We could, for instance, look at more global tendencies like approach and avoidance, or avoidance if the dog is approaching or avoiding a certain stimulus or a certain place in the environment, for instance. We could also go a level deeper, looking at single body parts, like for instance the tail or the paws or the face. Or we could even go one level deeper and look at micro-expressions. So let's for now decide if we want to focus on the face and look and identify facial emotional expressions in dogs. So why is the face kind of very promising? Well, from dogs we know that they can exhibit a very wide variety of different facial behaviors, almost as many as we know in humans. Especially from human emotion research, we know that there's a very close connection between facial behaviors and emotional states. So it's a very kind of promising kind of way of research or way of looking at dog emotions if we consider their faces and look at which facial behaviors are accompanied emotional experiences in dogs in order to find those that can help us to reliably infer the emotion in our dogs and then to develop subsequently AI models that can automate those detections. However, even if we have decided for looking at the face, we still have to decide on how we want to measure those face expressions. And there's one method I would like to highlight, and I will just use a few words because there will be a separate talk on this method, namely DogFACS, to the dog facial action coding system, which is a very unique method to measure facial movements in dogs in a very systematic, standardized, and objective way. And as I said, just a few words. So DogFACS is an anatomically based system because it allows you to measure facial appearance changes, so changes that you can kind of observe in a dog's face due to facial muscle movement. And DogFACS allows you to measure 5 different movements of dog's ears, different movements in dog's eye areas, the upper face area, and the lower face area. So it allows you to measure a wide range of different movements in the dog's mouth area. But as I said, we will go in detail on the subject in a separate talk and also show you different examples on how this can be done and how exactly DogFACS is working. However, even if we have decided now that we want to use DogFACS, we still have kind of other decisions to make, namely on the metrics that we want to use, because we could use different metrics when we want to measure behavior. Could just look at, let's say, a certain ear movement and see whether it's present or absent in a certain video snippet, for instance, that we are analyzing. We could also look at the frequency, so how often a certain movement, like an ear movement, is occurring, or we could even look at its duration, so how long this movement takes. For instance, how long the ears are laid back against the head, or we could even look at the intensity of this movement. So let's say how strongly those ears are laid back. And the metric we select is kind of crucial because it influences the kind of insights that we can draw. And it should be in line with the specific research question we are investigating. So the last part I would like to cover here in this talk is the reliability assessment. So reliability is the key of scientific rigor, and it holds especially true also for behavior research. And you can look at kind of two different types of reliability assessment. The first one is the intra-observer reliability, which means that kind of the same observer codes the same video 2 times with some kind of temporal system, and then we assess how consistent these coders, these observers' codings are over time. And the second type is the inter-observer reliability, which means that 2 observers' code let's say, the same medium, and then we analyze the consistency. And reliability assessment is really important also when we use standardized coding systems like DogFACS, because it's really important for the quality both of our research and of the data that we that we compile and the data set that we put together, but also for the AI model that we train based on this data. Okay, now let's continue with the fourth part, so the last part of this talk, meaning the validation and the future direction. And I would like to start with the consistency, because as I said at the beginning, an emotion indicators of behavior that is consistently linked with a specific emotion across different kind of contexts. So it's really important to acknowledge that it's not sufficient to identify a certain behavior based kind of on observing it and associating it with this emotion in a single situation. So what you have to do is to test different contexts in which the emotion you are interested in is triggered, and to look at cross-situational or cross-kind of test consistency, because our goal should be to identify those behaviors that are consistently associated with a certain emotion, as like frustration you are interested in, because only those behaviors have potential to be emotion indicators. And although, so if we find behaviors that are kind of consistently associated with a specific emotion across different contexts, this does not really necessarily mean that they are really accurate emotion indicators. So it's really important that we specifically measure how accurate they would be if they would kind of function as an emotion indicator. And what's helpful in this regard is to use diagnostic accuracy assessment, which is traditionally used in medical sciences. I will not go into detail on how this is done in this talk, but I motivate you to read my paper where we have used exactly this approach. And we found that even those facial expressions that were consistently associated with positive anticipation or frustration across different contexts, they still, if we look at them as kind of individual behavior indicators, they were not really highly accurate in identifying either positive anticipation or frustration for the emotion they were associated with. And this is really interesting and important because it means that we should rather kind of look at emotion indicators more as in combination either with other facial or also body expressions, because emotion expressions are multimodal. They're not just the face, or it's not just kind of one movement, but usually it should be a combination of facial and body expressions that qualify as emotion indicators. But for this or on this topic, we really lack very systematic and comprehensive research. Yeah. And the last part is the triangulation, because if you want to interpret kind of a certain behavior to be associated with emotion, it's important to not just look at the certain behavior, let's say at a certain ear movement, but it's really important to kind of triangulate and use different sources of information if you want to interpret whether a dog is experiencing a certain emotion. So we should look at dog's general behavior tendency, like approach or avoidance, because those differ between different emotional states. We should look at the dog arousal level, we should look at the general context and the contextual kind of features, so whether rewards or punishments are present or omitted or thwarted. As I said, in addition to the dog's behavior expressions, in order to make kind of better inferences on the dog's emotional experience. So this was the whole journey we got kind of behind us. And you can see if we want to identify immersion indicators in dogs and do kind of the behavior research part, there are so many different decisions you have to make. And those decisions are really important for the next steps, so for developing our AI models. So to conclude, and some take-home messages. Studying dog emotions is really a very complex endeavor, and there are some important kind of choices to be done in this research. So there are methodological choices, the choices with regard to kind of the types of dogs, to the metrics, and all those decisions are really critical for the data quality and also for the AI model performance later on. So it's really important to consider the reliability assessment and also looking at, as I said, the different metrics. We should look beyond this kind of associations, but also think of different methods how we can assess the accuracy of our potential immersion indicators, for instance, using diagnostic accuracy assessments. And we should consider behavior kind of multimodally, so looking at best at a combination of facial and body expressions if we want to infer dog emotions. And as I said, triangulation is really essential later on. So if we want to interpret and infer on a dog's emotions, it's really important to look at different types of sources, so not just the behavior, but also arousal level, context, and kind of more broad behavior tendencies. And then to go from this experimental setting into more natural settings to have kind of more real-world implications and applications, as this kind of research also has. So as I said, we are kind of, if we want to develop AI models to detect dog emotional expressions, it's a two-step process, and I just focused just on the canine behavior part for this talk, but it should give you kind of some insights on this part, which are also important for the development of the algorithms. Thank you very much for your attention. If you want to reach out to me, you can find here my website and also my email address. So yeah, as I said, thank you very much, and I'm open for questions.
Okay, thank you. So our apologies if the quality of the recording was not good enough for the remote participants, but in the room it was quite clear. So Annika, can you please speak so we can try to hear you? No, we cannot hear you. Wait 1 second, please. Maybe.
Try again.
Yes. Annika, we cannot hear you.
Let's see if anyone has questions.
Yes, anyone has questions to Annika? We can you hear us, Annika? She can hear us. Okay. Anyone has questions? We will also put the recording on the website so the quality is better. So since we cannot hear Annika, then we will take the questions offline then, and we will take a break. Thank you, Annika. Okay. Okay, break. Coffee break. Annika, can you hear us? No, we cannot hear you. before the break, were there any questions to Annika? She's now with us and is able to speak. If anyone had some comments or questions for Annika? If not, then you can also comment on the YouTube channel and she will be monitoring your questions there. Thank you again, Annika. And now to the DogFACS tutorial by Chiara and Julia. Please do not forget to speak into the microphone so the remote participants can hear us.
Okay, so here we are again. So this time we will have a little DogFACS tutorial in which we will also ask your participation. So you're all ready, I hope. So we will go a little bit into what is the facial action coding system, who developed it, when and why. Then we will have a short background on the development of the animal FACS, facial action system. And then we will go into the insights to the DogFACS. So some examples of the action units and action descriptors, and then we will do some exercises, practical exercises. So I'll wait that all can sit because now I need the participation of dog handlers, dog trainers present in this room. Okay, so I want that someone describe me what he or she is seeing in this video. Volunteers. I will play it again.
We say, like now, what we
Yeah.
see in the video.
Yeah, like spontaneously, what do you think? What do you see?
The dog is panting
Yeah.
and is cute.
Sexual avoidance behavior.
Then something else?
There's nose licking at some point.
No sleep?
Too good.
And I don't know about the eyes, but so let's start from the beginning. Okay, then the ears. So the ears are being somewhat at the beginning are relaxed and then they're tense. The lips are relaxed at the beginning, and then you can see this like there was some kind of stimulus at some point that interrupted the dog. I can't tell anything about the eyelids because of the light. That's basically it.
Okay,
Okay.
perfect. Thank you. Now we come to another video in which I will ask you to say something about the black and tan dog, so the small one, the poor dog that is bald by yellow. Any volunteers? Okay, thank you.
What she's up to?
She gets attention from the big dog because she's
Okay.
smaller.
Okay. And then?
We see play behavior.
Okay.
And the little dog seems to be uncomfortable.
Okay, nice. Thank you very much. Okay, so let's go on with what is the facial action coding systems and when it was developed. So the first facial action coding system was developed for humans. So the aim of Paul Ekman, that is a famous psychologist from California who was studying a lot. He also wrote a lot of edition from the Darwin famous book about facial emotions and expression of the emotion. That was the first book talking about facial emotion and its interpretation. And they developed this system because they wanted to get free of the inference description of facial emotion. So all the study that came before this group of research were describing the facial expression the researchers saw as already as emotion. So they were putting an inference to what they were seeing, as a little bit some of you did with these DogFACS videos. So you can describe an emotion saying the dog seems in discomfort, the dog seems stressed, the dog is playful, but you are putting like already an interpretation on what you see. These psychologists developed this system because they wanted an anatomically based system that would describe all the facial movement without having any inference. So without saying this is a sad expression or this is a playful expression, but just which movements, which muscles are moving when the people or the person is doing this expression. So it's now used also by research, by us, but also have some other application. So just to have an idea of the extent of the use, this is actually used by animator, computer scientists interested in facial recognition, including Disney, Pixar, animation, EA Games, and Apple developers. So one citation that really make you understand what is the aim and the goal of this kind of system is that the measurement must be made in non-inferential terms that describe the facial behavior, so that the inferences can be tested by evidence. What does this mean? So we need a way to measure the facial movement, and then what this facial movement means and indicates to the practitioner or researcher need to be tested by experiments, so putting the animal or the human in different conditions, then measuring the facial expression, the facial movement, and then statistically testing whether this kind of facial movement is actually more frequent in a situation that is stressful compared to a situation that is not stressful.
And actually, after the human FACS, which was developed in the late 70s, we came up to different animal FACS. We do not only have the DogFACS, which we already shown a little bit to you, but we also have 8 different animal FACS systems, which is, we started with non-human primates. So the first one was the chimp-FACS, which was followed by the MAC-FACS, gibbon-FACS, and orang-FACS. These were the first animal FACS adapted from the human FACS, because we do know that non-human primates are similar to us. Okay, as you can see here from this picture, we have indicated with different numbers the same musculature, with just a little bit of changes. For example, the brows for humans are highlighted by the number 1 and 2, but for the non-human primates is highlighted by 1 plus 2, for example. But yeah, for almost everything else, there are the same exact codes shared by human and non-human primates. But then, they did not stop there, because they actually developed other animal FACS. Began with the DogFACS, which was actually the first one of the animal FACS developed after the non-human primates. It was developed in 2013 by Bridget Waller, Katia Cairo, Katie Pierce, and Ann Barrows and Julian Kaminsky. And it is actually, again, the first FACS modification to a non-primate species. What's interesting about the DogFACS is that, again, when comparing it to the human FACS, we can see some analogies. As you can see here, there are some movements which are just coded the same, and other movements which are coded a little bit differently. For example, the other brow raiser is not seen in dogs because the musculatory region is different. But then we have other movements which are seen quite the same as humans, but the musculature involved again is different. And so they added the one code again up front the human code. So for example, the inner brow raiser in human is just coded by 1. In dogs is 101. Or again, the eye closure in human is 33, in dogs is 133. Because when you see in the table the facial musculature, the muscles involved in these movements are different in dogs or in humans. For example, involving the eye closure and the blinking movements, which are the last ones, 43, 55 for humans, 143, 155, 45 for dogs. In humans, we have the relaxation of the levator palpebrae, while in dogs, we have the orbiculus oculi, which are shown in the picture above. But also, what they did was having an exact idea of the movements of the muscles involved to dogs' facial movements from their rostral view and their profiles. More precisely, they split those movements in upper face muscles, which includes movements of the frontal region, of the superciliary protuberance, of the brow ridge, third eyelid, on the stop region, and the infraorbital region. And then there's the movements involving the muscles of the lower face, basically the muzzle and the nasal philtrum. But as you can see here from the profile view, there's also another more general identification. For example, the movements of the pinna, which are the movements of the ears, as much as all the movements of the lower face, including the nasal area, the nasal sulcus, and two movements involving the mouth muscles, which are mouth corners and the mental region. But also, DogFACS does not end here, because it is also important to have an idea of the complete profile of the dog. Cranial and caudal, as you can see, I tried to draw that to you, involves everything which comes up from the up of the head towards the tail of the dog. It's all that region. Then we have the rostral, which is basically towards the apex of the nose, and also the ventral part, which is actually from near the lower face of the dog towards the abdomen, and then the dorsal part, which is actually this one. But now it's also important to understanding the cause in the DogFACS, because it's not just like that. Okay, we have an idea of the frontal view, of the profile view, but then everything is into codes. So what is up to that? DogFACS is split into action units, which are actually the movements of facial muscles that can be detected during observation. The action descriptors, for which the muscular basis is not identified, and they can cover broader movements that can also impact AUs. So we can have an action descriptors that also have an impact of an action unit, and then gross behaviors, which are general action that can be coded again by using the FACS system, but as you can see in a few minutes, are actually general action.
Okay, so given the classification, so the manual is also organized by action units, action descriptors, and gross behaviors. We will now go into some examples. We will not give you like all the action units, even because maybe you are already confused by the landmarks of the dog. So now we will just have some examples to make you understand how this works. So considering the upper face action units, we have the AU101, so the inner brow raiser. So it refers to the lifting of the inner brow region, and it's performed by the frontalis muscles. So here you can have an example of two different dogs. So dogs obviously don't have eyebrows as we do, but they have a skin protuberance above the eye that can be lifted. It's a very subtle movement, but in some dogs, such as Doberman Pinschers or the Cocker Spaniel here, that have the black and tan color, this is obviously more evident because they have a really like a circle of different color where these movements happen. But also some other dogs, like the Rhodesian Ridgeback here, they have a lot of skin. So in some movements you can see it very clearly. So in the above picture you can see that both the inner brow raiser are lifted, and in the lower picture you can see that just the left inner brow raiser is lifted. Because another important aspect of the DogFACS that is also it also considers the lateralization of the behaviors. So for example, some facial movement can be lateralized, so there can be just the left muscle or the right muscle that moves. And this is very interesting because there have been different studies, especially on tail waggings, that shows that the fact that the dogs move one region of the body on the right or on the left can have different meanings and can be indicators of different emotional states. So this is also an aspect that I think needs to be studied further. So about this particular inner brow razor, a researcher had a lot of attention on it because it has been studied in a study by Kaminsky and colleagues in 2019, in which they had they studied muscles of dogs and wolves, of cadavers of dog and wolves that they could gain, and they actually showed that the dog had these differences in the muscle region of the eye that allows them to do this behavior, so this raising of the inner brow, and that wolves actually don't have this. And since this movement is related in humans with sadness and in dogs, actually, as you can see here, when the dogs lift this inner brow razor, they have this pedomorphic appearance, so they appear like babies because the ears are getting bigger. They hypothesized that this could have been a muscle selected because of human preferences, because humans have a tendency of empathy and nurturing behaviors towards something that seems more nice and infant-like. However, so they also suggested that they can have a communicative function. However, later study from Anika that we hear talking before actually was kind of putting down this hypothesis because it was showing that this behavior is not influenced by the presence of a human, but is more influenced by the simple movement of the dog. So as you can see here, the Rhodesian Ridgeback has the head low down and then looks up, and there is this movement. So also in our study, we didn't see that this movement was influenced by the presence of a human. So here we need to always put a lot of attention of not over-interpreting also the facial expression. So even if there is a study that shows that this movement is influenced by the presence of the humans, then we need to replicate it in different contexts and see, okay, should there be a simpler explanation? Maybe this is just because in one condition the human is here, and in the other condition the food is here. So in one condition the dog is looking down, and in the other one is looking up, and then the results show that the inner brow razor is just there when the human is there, but this is just because the dog is looking somewhere else. So this is a very important point to take into consideration when we design the studies. Then other upper face action units is the blink. So blink, the dog closes its eyes due to the relaxation of the levator palpebrae muscles and the contraction of the orbicularis oculi circular muscle to move the upper and lower lid, closing the eyes. There is a differentiation that we didn't have here from the blink, that is defined as the dog is closing the eyes for less than half a second, and the eye closure that is more than half a second. So if the dog is sleeping, you would go to eyes closure and not blink. So the blink is a very rapid movement. Then we have lower face action units that, as Chiara said before, consider the lower part of the face. And one example, a very scenic one, is the nose ring and upper lip razor. So these are two action units. 109 is the nose ring and 110 is the upper lip razor, but are very, very often coded together because they indicate the nose is raised, usually accompanied by the upper lip. So wrinkle can be formed next to the nose on the dorsal part of the muzzle. So the dorsal is the upper part, as you can see in this nice picture of my very gentle dog.
Julia,
Yeah.
in brachycephalic dogs, would it look completely different?
No.
You would not see it?
Yeah, you would not see the nose wrinkle because it's already wrinkled. And also they do much more effort to have the upper lip razor. But I mean, you can also between dogs, so here we don't have a picture of a shepherd-like dog, but we can see in the video afterwards. Shepherd-like dogs have more tense like skin around the mouth. So this movement is much more easier, even between my two Weimaraner's. So for this dog is easier because he's a little bit smaller and the skin around the mouth is more tense, so when it grows, it's really like lifting the lip. The female has like more soft and more skin around the mouth, so her growls are less like threatening than the male one, even if it's the same breed, like with humans, like we have different appearance. So these movements, so a lot of action units are related to each other. So AU25 is the lips part, and AU26 is the lower of the lower joint. And obviously when you code, these behaviors goes together. So if you code nose wrinkle and upper lip raiser, and the dog has also the open mouth, you need to code also lips part and lower jaw drop. Exactly. Then we have an interesting action unit that we saw before in the videos, and is the lip corner puller, in which the zygomaticus muscles pulls the corners of the lip towards the ears, as you can see here. So like if the dog is smiling. And this is interesting. We should make more studies about it, because anecdotal evidence and also a lot of trainers say that this is a sign of stress. No, you didn't. Yeah, I mean, there are no scientific study about it, but a lot of books you can see that this is reported as a stress indicators when the dogs do this kind of smile, but has never been tested. So this comes back to the citation we had before. We need to have an objective measurement and then to test this by evidence. Then we have the mouth stretch. That is, the mouth is open by lowering the lower jaw and actively stretching it open, exposing the teeth, tongue, and oral cavity. The yawn is also a mouth stretch. But we need to be very careful, because sometimes what we consider yawn is really like all the pattern of yawning that has longer duration. Mouth stretch, we need to code it even if the dog showed this behavior for a very short time. That maybe in our common knowledge we would not even consider it as a yawn. And is also always coded together with the lips part. Now to the fun part.
And now, yes, this is the fun part, because about the ear action descriptors, there's some conflictual evidences actually, because DogFACS recognize 5 different action descriptors, but states something that we did not see actually, or better, we did see something that on the DogFACS is not reported. So the first one is EAD101, ears forward. So basically the dogs pulls the pinnas forward, okay? So like that, when they're attentive to something, they just pull the rostral part of the pinna forward. The second one is 102, EAD 102, ears adductor, which is actually a slightly similar behavior such as the one prior. I'm going to show you this again, okay? We selected pictures in which we hope the difference is clear, but I can assure you that it's not that easy to differentiate these two behavioral patterns when coding videos. In this case, it's just the ears come up front and near to each other, but also these two movements are differently detected depending on the camera position again. For example, in one of Anika's studies, she basically found out that positive anticipation was during positive anticipation, Labrador retrievers express significantly more the ears adductor behavior, but when it came to our study, we found out that it was the ears forward behavior. And when talking to each other, it just came out that it was probably, yeah, exactly. It was due to the camera position and the apparatus 8. So also that provokes a difference in the position of the ears of the animal recording. Then we had EAD 103. I swear to you, these dogs were not threatened to do these phases. Ears flattener, which is basically the pinnas disappear behind the back of their head, next to their neck, and they had this completely round. And it's more common to be seen, actually, from our study resulted that it was more common to be seen in shepherds, probably because it is more easy for them to just put the pinnas back rather than hunting dogs. But as you can see, also hunting dogs like Weimaraner can perfectly perform the ears flatten behavior. And here we are to the ears downward, which is the other behavior we found in our paper to be expressed differently between shepherds and hunting dogs. Because again, probably due to the ears morphology, hunting dogs are more prone to express this behavior of just pulling their ears down instead of back, rather than shepherds, which again can perform perfectly these behaviors. But as you can see, Julia's dogs just put their ears like that, and their long ears, they have a certain weight, and the ears downward, the action descriptors. But when my dog does the same, it's just like a little step back than the ears flattener. For him, it's easier to just put the pinnas back than down. And now to the final part, which is actually a little bit of a problem here, because when reading the DogFACS, it's stated that dogs with floppy ears can't rotate the ears. But I do think that we know that that's not true, because of course dogs with floppy ears can rotate the ears. It's just a more subtle movement than a shepherd rotating its ears. Again, here Julia's dog is rotating her ears. She's heard a sound of a bird and she just do that. It's completely different from this one. I just want to make it clear. From this. Pinnas are not up front again. They're just rotated. Okay, but again, it's different than a shepherd rotating its ears. Also, these behaviors can be coded as a lateralized movement. There are some pictures again of this movement lateralized as ED100 for left, L, or right, because of course they can also move only one ear. Just to have some evidences, to prove that dogs with floppy ears can rotate their ears, we collected bunch of pictures of different dogs, different breeds collecting one or the other ear, and we have more pictures again. Because, yes, even though it's not stated in the manual, we did observe this behavior, and we do think that dogs with floppy ears can actually perform the rotation. It's just more subtle than the rotation of a shepherd, of course. And then we came to the action descriptor, which are basically the movements of several muscles, and again, one action descriptor can also be coded along as different action units, as Julia said earlier. So the first one is the lip wipe, AD37. Again, this is a behavior that can be lateralized, because it can be a left size lip wiping or a right size. Basically, the tongue wipes the lips from the mouth midpoint till the mouth corner. So if the dog does this, it's not lip wiping. Lip wiping is just like that, when they open the mouth and licks the corner of their mouth. Likewise, it's the nose lick. Tongue wipes their nose, which also can be a little bit lateralized. In that case, dogs does this behavior of just putting the tongue not in the middle of the nose. Nose lick also includes just tongue flicks. So if the tongues just have this serpentine attitude to show the tongues out of the mouth and touching a little bit of the nose, it's again a nose lick. And finally, gross behavior, which are more general behavioral patterns. Again, this includes a lot of behaviors such as different head turning, head up, head down, but we reported here just a few to give you an idea. Here's the AD126, which is the panting behavior, which includes the whole mouth, of course. Basically, it's a heat regulation mechanism where dogs open the mouth. Again, we code this along with AU26, produce the tongue rhythmically, and this is the AD19, which is basically the tongue show behavior and breaths, but it's coded as AD126 for the DogFACS, which is panting, along as AU26 and AD19, obviously. Or also behavior like sniffing. AD40 is the sniffing behavior. It's along to the FACS because, yes, again, this includes other action units and descriptors. Differently from humans, dogs do dilatate and compress the nostrils, and it can be seen also naturally to the nose or next to the nose. Not done again, because the gross behavior also includes vocalization. Different types of vocalization occurs. There's not specific cause for barking, whining, growling. So any sounds produced by the dog, this is the statement, has to be coded as AD50. Then if you want to, I don't know, have some regard of a certain vocalization, you can add some, I don't know, some noise, for example, AD50 barking, AD50 whines, just to have a more precise code. Now, it's time to test your knowledge after we explain this to you. We are going to show these videos again. Unfortunately, there's a spoiler. Okay. Okay. So, what's going on now here? Basically, according to the DogFACS, we now see that this dog has the ears flattened because she is hearing a storm coming. And then, as you can see here, there's AU25 plus 26 because she has jaw drop and lip parted. Again, AU112, which is this behavior where the lips are towards the ear, like smiling. And this is objectively, because we don't know what she's afraid, she's scared, she might be whatever she wants, but this is what we see according to the facts. She's panting.
That you also spotted before.
And
Sorry, the jaw drop together with lip part always? Can it be separated? No. Always come together.
Yeah.
In dogs.
Yeah, because obviously to draw the drop,
Yeah.
you have to.
Yeah, because when you
It's
lower
difficult.
the jaw, the jaw, then the lips are
Yeah,
part.
so is there a point in coding both these? I mean, they also always come together.
I'm thinking about yeah, it can happen that when the dogs are much close, you can see a little bit of a jaw drop. But
Depends also on the morphology,
yes,
because
exactly.
you have like a Great Dane that has
Exactly.
a very like soft skin, then it can lower the jaw, but having still the lips that are together.
So it's
But, yeah,
basically,
the
yeah. And finally, the AD19, so basically the tongue show, because she's right now. Oh no, I'm not done, sorry. Forgot about the blinking and the nose licking. So she blinks different times, so we can code this both as frequencies or durations. And finally, there's a nose lick. Sorry, do you have an answer?
There is a question for you two.
Mhm.
Have you checked for possible sex differences? For example, the ear rotator
Mhm.
is more frequently observed in females, just being attentive to the surroundings.
Actually, no.
No.
We had an effect of sex in the first study that male were lips licking more. Male,
Yeah.
like male
Dogs.
dogs were doing lips licking more than females, but
No,
it was
about,
just one evidence,
yes, about
like in one study, never replicated. So I don't know which could be the reason. But about the ears,
we always
no.
put sex in the model, but it never came out anything else.
But it would be interesting to do this maybe in dogs that lives in groups outside. Because, as you say, maybe, I don't know, there is one that is more attentive to the environment and then is moving more the ears.
And now, coming to the other video, again, the black and tan dog. First of all, ears are not visible here. It's difficult to understand what's their ear position because she moves a lot,
All black.
then it's all black, so we can't code something we don't see.
Black dogs are bad for DogFACS.
Again, she does have lips parted and jaw drops because she has an open mouth. AD50 is a sneezing, it's a sound, so okay. It's a gross behavior. EU 109 plus 110, so nose wrinkle, as Julia showed you earlier, when she's drooling, basically upper lip laser plus nose wrinkle, exactly here, and soon after, at the end, yeah. She blinks a few times, and she licks her nose. Just after the sneezing, she licks her nose twice. And we had also another video, but I think we're going a bit long. You can.
So in this other video, I can show it to you, and maybe Anna, do we have time?
Yeah.
Okay, here maybe you can try to, like, if someone wants to have we volunteer some codes. So the
If you recall
ears.
some codes.
So what we do usually when we code, or I mean what I do, because then everyone develops his way to handle these terrible hours of coding and organize their mental like descriptions. So I go I watch the video, I just watch the ears. Like what are the ears doing? So for example here, the ears. I would some suggestion. Yeah, they are moving to the back. So here, as we can see, so the ears are staying up, very up. Also because this dog has a very high, the ears are very attached very high on the head. So I would code ears rotator like as here, and just at the end he's lowering a little bit the ears, because the ears flattener are just like backwards, and instead the ears rotator are just like rotating and not really backwards. And then what else you can see, then I watch the eyes, and we can see that the dog is blinking. So at the start they were ears adductor, and then they go rotating. I will show all of them. So then there is the blink that I say now. Blink like 3 times actually. And then I look at the mouth, and I do all the codes for the mouth. So here we can see lips apart and jaw drop at the beginning, and then you need to transform these to AU27, because this is a mouth stretch, not an AU26 anymore, because 26 is just lips apart, and then if it's stretched it goes to AU27. And AU27 and 26, they are mutually exclusive, so it means they cannot happen together. So it's even one or the other. And then you have AD, what happened here? AED19, because you can see the tongue. So these were supposed to be presented by Annika, but we took over all the presentation, but still she gave a lot of insight, because she's coding with DogFACS for much longer than we are doing. And so she wanted to point out what is the value of the DogFACS, just to repeat it again. So it's a standardized system, so it allows consistency across different researches and studies. As I point out in my presentation, the problem we have in dog behavior studies is that before the DogFACS, and still now, every research group develops its ethnogram, gives their definition of the behaviors, and then do the research and the statistics and the conclusion based on their definition of the behavior. We really are struggling to try to divulgate this system, because we really want all the dog research that research in behavior to adopt this DogFACS. So we can then compare our results, because even within the same group we have different results in one study and the other. So it's really difficult to have consistency and to try to understand something of these subtle behaviors. So if we don't adopt all the same ethogram, we lose at the start. So they have consistent set of guidelines and description, and the terminology is the same, so we can speak the same language. Then is a systematic approach, a comprehensive approach that captures a large range of dog facial behavior. So obviously, if you then need a particular behavior you're interested in it, you can add it. So we were adding some behaviors because they were not into the dog DogFACS manual, but this does not mean that we didn't adopt it. So we adopt it, and then we say, okay, we needed also this and that, and we added it. So we are really like, we say, please adopt the DogFACS, and then if you want to add or to say something more about it, add it to your etogram. It's objective, so it's based on purely observable and detailed descriptive facial action movement and reduces the personal interpretation and biases. And can be used for largely data-driven analysis. And finally, is reliable, so it needs an initial certification and also needs always inter-rater reliability that Annika presented to you before. And so if you want and if you are interested, and I also very much suggest also to the trainers and to the practitioner to have to read the manual. You can ask them, they just ask you why do you want the manual, and you can answer like, I'm a dog trainer, I want to deepen my knowledge about dog behavior, and then you have a different book to read in the evening. And this allows you to have a more deep understanding of the movements of the dogs. And then you became a little bit dependent, and then you are watching a dog and you see all the facial movement that before you were not seeing. But this is another story. So if you want, you can go to animalfacts.com. You can access the study and the manuals, then study it. And then if you want to be certified, you can also take a test that is does not take a lot of time. It's a bunch of videos. You need to fill in an Excel sheet and then send it to them, and they have a very, very good system. They reply to you and they allow you to take the test again if you didn't reach the percentage that they want. And they also give you feedback, so maybe like, okay, you maybe need to improve a little bit on the ears or on the mouth descriptions and so on. So it's really good, and I suggest all to you to have a look at it. So these are the references. Thank you. We were very late. Sorry.
Thank you. Any questions? Yes, we have Graham first.
Do you modify the test if, I think Anna said something about brachycephalics to different dog breeds that possibly have perhaps different expressions or not so well
So
expressed
No,
expressions?
that's
And also, if you're, I was just wondering when you were showing like the lip curling and the nose scrunching, for example, if the dog had a phlegm response, would you consider that?
if a dog have a
phlegm response.
Would you consider that a separate
Okay.
behavior?
Yeah. So the question was if we have a different ethogram for different morphology, you mean? Yeah. So no, it's the DogFACS is one, but as Annika pointed out before, when you design the study, you need to be aware that different morphology of dogs can have different facial expressions. So what is done usually is that you categorize, or you take one breed, or as we did, we had different breeds, but we only included shepherd-like and hunting-like dogs. So we excluded brachycephalic dogs and also dolichocephalic dogs, so like hounds that have very particular morphology. So we just kept these two general morphology that are also the more general one, and more spread out. And then in the statistic model, we had that factor as a control variable. Actually, I don't know about brachycephalic studies with DogFACS. I think
there's one in Budapest was shown with I think so there was a poster.
Oh, okay. So maybe there is one from the group of Budapest, but we unfortunately had to exclude them because there are not so many, and then if you just have like, I don't know, 20 shepherds and then 5 brachycephalic dogs, you're like, the statistic, this cannot work. So, but it would be worth to like do a study on brachycephalic maybe and compare it to, I don't know, shepherd-like dogs.
Did you build the database was built on shelter dogs or own dogs?
The DogFACS for the manual.
Yeah.
I actually don't know.
I think it was from YouTube
Both.
videos. Both.
Yeah,
Yes, because they are not very controlled.
So the study I showed about the comparison of the wolves and the dogs, they really took carcasses of dogs and wolves, and also in the paper you have lateral like photos of the muscles, like the facial muscles. So that was done on real dogs to study the underlying musculature of the dogs. But then I think, yes, the manual FACS was developed with videos of their dogs, shelter dogs, and so on. And there is one study, I think, from Cairo about the facial expression during storms. They did it, I think, with videos that owners were sending and then coding.
So sometimes in shelter dogs, you can see wounds or scars or even missed parts of the peanut that can affect. So I'm looking at the practical end of this. So this may interfere with the way we interpret the dog.
Yes and no, I would say, because in our first study we have few border collies with the ears not completely straight up, and even if one of the peanuts was actually a little bit bottomed, we decided to look at the whole video and try to understand what was the movement the dogs could make with that specific ear. We also had one dog that couldn't move her ear, if I can recall well. And you just try to rely a bit on the better ear, because of course then lots of ears movements are lateralized, but not all of them. So you can still see if there's a rotation, or in that case you just can, you can put a little bit of effort on coding the other ear. Because we had these issues with a few border collies and we tried to solve them like that. But yes.
Stefan?
Just to precise the point, each of these parameters are binary. Like, it exists or doesn't exist, or
No.
there is like intensity or frequency.
They can be coded as a duration or as a frequency. So we can both code if it happens for a certain amount of time.
So
if
depends.
It depends, of course, yes, of course, it depends on the behavior. For example, the ears movements are durations. We code blinks as frequencies, but
So yes, in the manual you can code the events, like blink, nose lick are coded as events, because yes, a dog, I mean, it can be done also a study to see whether, for example, the nose lick is a stereotyped behavior, and then you can go on and code the duration of in which you can see the tongue, for example. They did this, a group from Pisa, they did this with these open mouth signals that is a combination of different AU, and that they recognize actually it as a stereotype behavior. So they went on and see, okay, the duration is the same every time that this dog perform this behavior. Yes, it is. So they said, okay, it can be evolved as a signals, specifically a play signal. So you can code both as duration or as frequency. We coded the event like blink, nose lick, lip wipe as frequency. And then other behavior like the position of the ear, because it's a position, we decided to code it as duration. Then in our first study, for the statistical analysis, we consider it as a binomial, so presence or absence, because our test condition was 5 trials of 5 seconds. So a lot of time we had 0, 0, 0, like a long column of 0. So we, as well as Annika in her first study, considered the response as, is this behavior present in these 5 seconds or not? Because they are just 5 seconds. So you evaluate and you say, okay, for my statistical model, it's better if it's just a binomial. But for example, for the video tests that were 30 seconds, 1 minute of coding, then we went for duration for ears and behaviors that can be coded as duration, and frequency for blink, lip licking, and event.
Can you say again, what does the sneezing mean for the dog, the gross behaviors?
Sneezing?
Yes.
Sneezing is like a sneeze, a chum. Yeah.
So yeah, but what does it mean for the dog?
Oh.
we don't know. So we don't know yet.
We don't know. Actually, I think there was a study about free-ranging dogs in which they saw this sneezing when the dogs were leaving a place to go to another place. I would need to. I don't know. I would need to go on back and find this study, but I know there was a study reporting the mean possible meaning of this sneezing. We never did a study, and there is no recent study in the lab to. Also, because the problem with these behaviors is that you observe it very
to exclude
few times. I mean, we had yawning in our study. We were never able to statistically analyze it because we had 4 yawns in all our tests. So with 4 yawns, you cannot do any statistics. No.
Okay. And thank you. And the second question is, what variants can there be in brachycephalic dogs, especially pit bulls? So I guess dogs that have a shortened, like nose now.
Yeah. Yeah, I mean, pit bulls are not brachycephalic, so we we included them as hunting-like dog because they had floppy ears, squared face, and soft skin around the mouth.
I guess the question is, what would the action units variation be for dogs whose faces are formed a little bit differently than dogs with
I don't
long
think that
faces?
we answered this earlier. Actually.
Yeah, I think there are variation, but it does not need to be another manual for the brachycephalic dog. So I think you will just not observe some behavior. So you will not observe nose wrinkle because they cannot wrinkle. Yeah, they already have these layers of skin that are already wrinkled, so they cannot. You will never observe a nose wrinkle. Then you will probably be very effort to lift the upper lip, so you will also not observe it. So you don't need another manual for the brachycephalic dog. You just need, you will not observe a lot of action units. But I don't know a study in which they did this, so I cannot for sure say to you, okay, they observed brachycephalic for 24 hours for 1 month and they never observed nose wrinkle. Maybe some brachycephalic that does not have this degree of brachycephalic, maybe they can still wrinkle there. No, they should investigate this. Yeah, thank you.
Okay, so we need to move on with our presentation. It clearly has generated a lot of interest, so thank you so much for this tutorial. So our next speaker is Marcelo Feigelstein. Can you come here, Marcelo? Is your presentation here?
Technical assistant is it.
Yes. Thank you. Hello, everyone. Are you okay? Are you still with that? My name is Marcelo Feigelstein, and we'll talk about how AI can make animal lives better. So this is the AI part of the day. In the agenda, we'll talk about myself and about the work we are doing in our lab, and then small about my PhD work. And as usual, we are talking with people that are talking about training dogs, right? And what is the best way to check if your dog is well trained? To bring a cat to the room. So I will talk about cats, and then I will talk about, I will connect my research with the Annika research and with Parma research, DogFACS, so you will understand what we are doing with AI. And then future work, towards what we are doing and which kind of tools we are trying to develop with AI, okay? Okay. I'm not a veterinarian, not a dog behavior. I'm coming from the AI, okay? My PhD, my first degree, second degree, computer science. So now you understand that I'm coming from the AI, from the computer science, and not from the animals. But all my research was to develop tools, automatic tools, to identify emotional states in animals, okay? This work was done as part of the Tech for Animal Lab. That what we are doing here is to develop tools to monitor shelter dogs, for example, or to, as Anna explained you, we're working to monitor health of tigers, big cats, or for example, to monitor states of sheep. Okay. We are collaborating, and all the time we are looking for future collaborations. So if people are listening to me, we are all the time looking for animal data. Okay, we are currently collaborating with Sao Paulo University, with Lincoln, with Elephant Neighbor Center in Kenya, and with DogFACS, Israel Guide Dog Center, with a lot of places, and we're always collaborating with people that bring to us data. Okay. What is animal emotional research from AI point of view? Any guess? Okay, I will skip this slide because all the morning you receive it. Basically, there is a stimuli. The animal is producing an emotional reaction that the way we want to identify is visual. We are developing non-intrusive visual-based tools. Okay, so we are not touching the animal. We are just looking. Okay. By doing that, we are trying to assess the current state, welfare state of the animal. We are trying to improve the animal-human communication. It's like if we have an application, I will show you. If we have an application that can understand what happened with the animal, we will understand better what is happening, and maybe we will contribute to the long-standing question about the conscience of the animals. Okay? Sorry, dog people, I'm trying the cat to the room. Okay? What you see in this image, if you ask DALL-E, do you know what is DALL-E? DALL-E is an AI tool. You can ask a question or send a sentence, and DALL-E is bringing to you the image generated by AI. So if I ask how is a cat suffering pain? Show me a cat suffering pain. This is the result of the computer. Okay, what do you see here? Do you think that this is a cat in pain?
Can be enough, potentially.
Okay, my guess is that this is more like to be a baby crying. Okay, and now is what you say humanization. AI is humanizing the cat, and then is bringing an image of a cat like a baby crying. Okay, but this is not reality. Now I will show you what is a real cat in pain. Okay, guys, this is your turn. You need to tell me who is the cat on pain and who is the cat not on pain. This one? Okay, good guess, but it's what is called UCL Elizabethan collar. Okay, it's because it is in the hospital and you're assuming that it's on pain, and you're right. This cat is on pain. Which else? Which other? The blue blanket? The left?
The left one.
The left one?
Yes, on the left.
How? How do you recognize?
The eyes are wide open.
There is a palpitation on the right eye. I guess, okay, it can be because of the.
Okay, so what?
And it's like when you have this unsymmetric opening of eyes also.
Okay, so this is the reality, and this is very difficult to do, to recognize a cat on pain. It's one of the most difficult animals to recognize pain because cats are hiding their pain. Okay. So, how will we do that? How will we do that? Okay, this is the reality. In the left, there's not pain. In the right is the most pain, and in the middle is the pain level is increasing. So, how veterinarians are doing, and how we will try to do that. Okay, I will show our dream. Okay. I hope that we have sound here.
Yeah, we have. Just play.
Okay. So basically, we're trying to get to develop a no.
Next slide.
To try to develop methods based on AI vision that we can take a picture or a short video of a cat and tell if the cat is suffering pain or not. Okay. This is what we're trying to do. This cat is on pain, this cat is not on pain. Basically, this is what we are trying to do. Why? Why we are trying to do? Who has a cat at home? Okay, you are a dog person with cats. Okay, good. I also have a cat and a dog. Okay. If you have a cat, it's very difficult to detect if the cat is suffering pain. If you don't detect the pain, you are not taking it to the vet. If you are not taking the cat to the vet, it's undertreated. And it's not getting pain relief or something that you can do for your cat if you detect the pain. Okay? So if we are able to detect the pain, okay, AI will not replace the vet. The AI will give more work to the vet, because you will take the cat to the vet. The vet will revise and identify the pain. The vet will give a pills or something to a medicine to the cat. So the pharmaceutical company will sell more products, and then at the end the cat will feel better. Okay. So it's a win-win-win situation for all the parts, and the AI is not coming to replace any of the integrants of the chain. Okay? Why we are trying to do it visual? Because it's non-intrusive. We are not touching the cat. It's automatic. You not require any training, just to take the picture, and objective. So it's pain or no pain, and it's not depending on if you feel better or not good with your cat in this day. Okay? I want to explain you how and where we are standing with this research. And the first, I will show you two papers we presented in Nature Scientific Report, also presented in CVPR. This is one of the most important congress on computer vision. The first paper was developed with Professor Mills and Professor Luna, and the second paper was prepared with the Hanover University with the Professor Volk, and also with what we did in this research was to classification of images. Take an image, facial image of the cat, and decide and the cat is in pain or not pain. So what we did, we took the image, okay, and just a second, we take images of cats on pain, cats and not pain, and then I know that most of you doesn't know anything about AI. I know, but I will try. I will explain you what we did. We take images of cats on pain, images on cat not on pain. We did something what we call pre-process of the images, and then we train an AI model to differentiate to know when the image is on pain, when the image is not on pain. This is basically what we did in two different methods. One is what we call deep learning. Deep learning, I know that you don't know, but deep learning is black magic. It's like somebody is coming from other planet, is looking at the images and knows to respond. Now it's in pain, now it's not pain. For us, it's like black magic. It's very difficult to understand what the machine is, how the machine is taking the decision. With this method, we reach 74% accuracy. Okay, reasonable. The second way, we want to take a decision that we can understand why the machine is responding what is said. Is pain not pain? Why? We're trying to find explainable ways. So we based the decision not in all the image of the cat. We took only 48 points, landmarks, on the face, okay, of the cat. And then we perform what we call splitting the face of the cat on different regions, on the eyes, on the mouth, on the ears. Why we did that? Because I will explain you how vets are recognizing a cat on pain. And then we classify using these points, okay? And then we reach also 74%, okay? And then we understand what the machine is doing with the points. I'll explain you later. I'm coming back, and now I show you this. If you take your cat to a vet, and the cat wants to understand is the cat on pain or not, the vet will first look at the ears. If the ears are up, the cat is okay. If the ears are down, the cat is not okay. It's a combination, okay? Then it will look on the eyes. Eyes are open, the cat is okay. Eyes closed, the cat is not okay, okay? If the, how do you say, whiskers. The whiskers. If the whiskers are down, the cat is okay. The whiskers are up, the cat is not okay. Okay? And then you scoring. The scoring, you say, okay, it's okay, not okay. It's looking all the picture. Okay? So we try to do the same way, splitting the face on region and then classifying the points, and then we got 74%. The first data set, yes.
What was the procedure that made you decide that something?
Good. How?
Please repeat
the question was, how do I know that the cat is on pain and the cat is not on pain on the image? Good question. We took on the first data set, we took what we say images from before and after surgery. Cats are undergoing surgery, so we know it's not for the purpose of the research. We are
just wondering what kind of surgery.
Orthopedic, ovarectomy of females. Okay, it was in Sao Paulo University.
Which surgery?
Yes.
Just for females.
It's just females and just short-hair British cats. This was the first research, and then we believe that maybe those results are only applicable to this kind of cats, only females, and only this kind of surgery. So we come with the collaboration with Annovert, with Tijo, Professor Volk, and then we extended research to different kind of breeds. Multigender is all females and males, and then different kind of pain, because now we are not talking about surgery pain, we are talking about different procedures or different cats that are coming to the hospitals, and then the pain is recognized by vets and scored according to behavioral and facial scoring, and then we have the data classified with low score is no pain, high score is high pain, is pain. And then we apply the same techniques, and then we reach also very good results, okay? And this is the result. This is the research of the cats, okay? This is the research, indicating us that is doable. Just a second. Don't take it and don't look at the slide. We got good results for multiple breed, multiple gender, and multiple reason of pain. So it's possible to do with the eye, okay? This is the beginning of the research. What we also wanted to do is to explain. So where on the face is how the machine is recognizing the pain. Where in the face the machine is seeing the pain compared with the vets. Yes?
After the chirurgical operation for the cats, it's also pain. You make it also the database after the operation, not just operectomy or castration.
Other kind of surgery? Actually, we don't have in the data. I don't remember if with Vitijo we have a post-surgery. I don't remember. But this is the beginning. We need to develop a foolproof or reliable application. We need more data in different situations. Yes, I assume that the different kind of surgery will bring different. So, in order to develop an application, we need multiple sources of data of different kind of pains and different kind of cats and breeds and gender. Okay. Yes, thank you. And what I was saying is that not only we want to recognize the pain, we want to see how the machine is recognizing the pain. So we developed the first work on animal recognition, and that is trying to do what we call explainability of AFI models. And what we discovered is that the machine, the most important part of the cat, or the cat face, to recognize pain is the mouth, okay? That is not compared with what we are saying with for example, if you took your cat to the vet, the first part that the vet will take a look is on the ears, but the machine is focusing on the mouth, and now we are trying to understand why, but we don't understand why. We see that the mouth is the most important part of the face to take the decision for the machine. Okay, this is the difference between machines and vets. Okay, so for example. I will not confuse you with the eye. We look. Do you see the pictures? Do you see that there is a red part on the image? We see the red part. The machine is looking at this part of the image, and then we combine with the landmarks and see that in average the machine is looking at the eyes and the mouth, and not at the ears at all. This is part of the questions that the AI is raising, and we need to understand for future research. Okay? We were the first non-invasive, not intrusive pain detection of cats. It's important to say that we are not inducing pain to the animals for our research. It's totally ethic. We are not causing pain or inducing pain for the research, so it's very important for us. And we were the first to introduce what we say explainability into this area to try to compare how machines recognize pains compared with vets. Okay, and then now I need to connect you to what we talk on the morning. The second, we are not only talking about pain on cats. We are also detecting pain on sheep, and we are hopefully in the coming, I don't know, I hope it's already written, but we are discussing. We want to publish the first paper on sheep that is increasing by far the already known work that was 60-something% accuracy. Now we are reaching 85% accuracy on pain detection. Also, again, we are taking picture of a sheep and then deciding if the sheep is on pain or not. And we are not only we are showing that the machine is performing well, the machine is performing better than the vets. We are comparing what the vets are saying against the machine, and the machine is performing better than the best trained veterinarian in the experiment. Okay, that is very important to say that the machine is sometimes are better than us. Okay, and now is with Parma and with Annika. We have I don't want to explain. Tali will explain later. Okay, just paper we published with Annika and with Tali. Tali will talk. I will talk only on the part that we use DogFACS. Now is the connection. We have taking a picture, taking a video. Okay, we trained AI to automatically decide in the specific AU is present or not on the video. What those people from Parma took 1 year to code the video. So we show basically a pilot of models detecting automatically if an AU is present or not on a short video. And based on the coding, we train a different machine to identify emotional state, if the dog was frustrated or not, and then we reach not very high accuracy like Tali will explain with deep learning. I saw you deep learning is the black magic, but we understand, for example, that there are some this is an example of Annika's video, and there we understand that this flattener was an indicator of frustration in the experiment. Okay, so how we did it? We automatically train a machine to take the video and extract AUs, and then another machine to translate AUs to emotions, and then we identify how the machine, again, explainability, how the machine is taking the decision. We understand that this was a sign that helped the machine to decide if it was, we are talking about frustration or positive anticipation. Okay? So this is the connection with the dog part. And the current and last but not least is taking videos of rabbit, okay, and then decide. I will not give you to guess. I put you the state. No pain you have on the left, pain you have on the right. Okay, what do you see? What do you see? What? One is not moving, so we understand that maybe, not maybe, veterinary knows that a rabbit on pain is not moving, or sometimes it's not moving, but not all the time. Sometimes it's moving with pain. Okay, and then yes, there are a lot of signs. So I can train you right now how a vet is identifying pain on rabbits. It's different than cats, it's different than sheep, and different than horses. You need a trainer. You need somebody that will train you to identify the pain. Again, I'm just trying to do an application. Okay, what we did with that, we reached very high. This is a different paper that was published 1 week ago. And again, in Nature Scientific Report, we show 85% very high accuracy, identifying pain in rabbits using videos, okay? And I just can tell you that we are trying with different animals the same technique, and we improving our results very much. And now we are trying to compare what we did with the cats with videos. And our first results are showing that we are proving it's much better to see a video than a single picture. That is logic, right? If you see a single picture, you can take a decision. If you see a short movie of two minutes or 1 minute of the same animal, you will have a lot of information. And besides that, what we are doing is try to understand now how in a video the machine is taking a decision, okay? And we are extracting pictures. We're extracting from the video. You have 2 minutes of a video. We're extracting what we say the top 20 images. So what are those images? Those images concentrate the most pain and no pain information of the data, and then we will give it to the researcher, and then we'll try to identify where are the signs of the pain on those top images. Okay. So now you understand better what we are trying to do with emotional research. We are trying to improve our way to detect emotional state or pain. That sometimes pain, for example, is not detectable with FACS. There is not a pain. It's not, we are not smiling or moving your eyes or something. It's like a contraction. So this is not action unit. You need to take a picture and decide if an animal is on pain or no pain. So it's more difficult that an emotion. Emotion is is short term, but you have a representation like kind of facial expression. In pain is more difficult. So this is what I'm trying to do in my research, and I get my PhD 3 days ago. So thank you very much. I hope you enjoyed the lecture, and if you have any questions.
Thank you. Questions? Please
Yes.
repeat the questions.
I have 2 questions. First of all, why did you said you use as a gold standard to determine if there is pain present or not on cats the opinion of veterinarians?
Okay, so your question, if you use as gold standard opinion of veterinary.
Why didn't you use physiological, objective, more treatments like blood pressure, heart rate?
Okay, good question. What is the reason we don't use other indicators like blood pressure or something else? Okay, first, if you touch the cat with anything, we are influencing the cat. Okay, you are influencing the cat, and if you try to measure the blood pressure of the cat, it's totally you will alter the state of the cat. Okay, you're right. We would like to have more indicators of the status, but basically we are trying to develop non-intrusive tools. And then in surgery, we know that the cat is on pain or not pain. With the in veterinary environment, you are right. We will want more accurate indicators, but it's difficult to get those indicators, the values, without altering the state of the cat.
So my goal as a vet, when I've done surgery on an animal, is to prevent pain as soon as possible. We say, so at the end of the surgery and during surgery and before surgery, I will use a lot of pain medications.
Yes.
Okay. So how did you know?
Okay, we work with.
Did you hold the pain medications, or what did you do in order to make
Okay.
sure there is pain present?
I can explain you what we did with the Sao Paulo team do. Okay, they know the average time, decreasing time of the painkiller. Okay, so they know after X time that the painkiller is not working. Okay, so
This is what they want to measure.
they measure in the time since they gave the first doses, okay, they know also to read pain indicators and facial indicators on the cat. They also they know pain indicator, facial indicator, and behavior. Besides the surgery, they're doing what we said scoring, facial scoring, behavioral scoring. So maybe we have cats that are suffering pain and not showing the pain. We know that there are those cases. And also there are cases that cats are showing pain before the surgery. So we are also managing those cases before we are training the model, not, in order to not confuse the model. You're right. Okay? So what was the second question?
So the second is, do you have an effect with cats' colors? Because maybe the camera cannot detect the facial expression. If it's a black cat, for example,
Yes.
it's going to be harder for the software to identify.
Yes, we didn't try. We try with the data we have, and the data we have includes cats of multiple colors, especially the second data set. The first data set I don't remember, but also we have short-hair British cats of many colors. Okay, and one of the techniques we are doing is we are removing the color and moving the picture to gray, but the machine is. It seems the machine also in rabbits. The machine is not using the color. We are removing the color, moving the picture to gray, and we see that we are not losing information. We are gaining information. I don't want to. I can explain it later. To moving three images in a single image. We are superimposition of images, and we are gaining temporal information. It's like the machine is more important for the machine to see if the animal is moving or not. It's more important to see that instead of seeing the color. And we know it. We know that. We see a great improvement on the accuracy. Okay? Yes?
I suppose that you use scale indicators of pain. Like you have the Glasgow scale.
Yes, in the second data set of Hanover, Tijo, we use the scale to score the pain level, and then to before 3 or 5 is considered not pain, above 5 was considered pain, and then this is the level of the data set. This is the way we level the data set.
Okay.
I don't remember it was Glasgow or different.
Yes.
And I want just to stress the fact that pain for veterinarians and for also me especially is very important to detect, and chronic pains are very difficult to detect even in dogs. And in the brain there is a connection with the amygdala between pain and fear, and the loss of pain can trigger anxiety, and this sort of tool for me is fabulous if it will come to an accuracy of 90% like it should be for a medical tool. Then I will be able to measure the pain of the cat or the dog that is coming for
Yes.
consultation with anxiety, whatever. And now we are so aware of this part of the problem that even in some veterinary centers for behavior psychiatry, they are using painkiller before giving any other drugs to be sure that a pain can be eliminated, because they have no objective other measurement at their disposal, the tool at disposal to measure it.
I agree. So for the YouTube, I will not repeat so long question. It's pain identification is very important for researchers and for behaviorists. Okay, okay. But you answer your question is also for you. It's very difficult to distinguish between a dog or a cat on stress or a cat on pain. So this was one of the difficulties in to build our data set and to explain that those cats are on pain and not on stress. Okay?
Yes, sorry, we will take the questions because the food is already getting cold and we still have 2 short presentations.
Okay,
to go.
thank you very much.
Please come to Marcelo in the break. Okay, our next presenter is George Martwell. This will be a short presentation.
Hopefully, yes.
Yes, George. Keep in mind, we are hungry.
Yeah, I felt it. It will be short, yeah.
Think of the
But not too short.
Yeah,
Let
sure.
us still feel.
How to break that? How to, like, here? Like, press here?
You can have a
Okay, great. All right, so, hi everyone. Nice to see you all. I will speak about a little bit about facial landmarks and their automated detection, and for like different applications of facial landmarks. So we heard a lot about action units, facial movements. Yeah, that's a familiar picture for you now. I saw the pain in your eyes when you spoke about manual annotation of all these different action units and different movements in the dog's faces. So the question is how we can improve that. And the possible answer could be facial landmarks. I don't know if, it's playing. So, here you can see facial masks, and we are pretty familiar with this thing. And the case is that these facial masks are actually based on facial landmarks. Facial landmarks are specific points on the faces. Here is the human face. And you can see like there are a lot of points, and they are all connected with human face anatomy, and they could be used in different ways. So here you can see two types of the landmarks annotations, and the second the right one is a bit more complete and refers to more facial muscles than the left one. So using these landmarks, I will speak about applications a little bit later, but all in all, we can use these facial landmarks for humans now to do different things. And the question is, can we use these special points on animal faces to automatically detect these specific points and actually detect the changes in the animals' faces, like geometry, track their movements and stuff. So a little bit about applications. So the thing is that when you detect landmarks automatically on videos or on images or even in real time, you can, during experiments or tracking the animal, you can estimate geometry, for example head pose, or to estimate where the animal is looking currently, or do different tasks connected with the geometry of the faces. So for example, to automatically recognize the breeds or face types and such stuff. But more interesting part, we heard about it today. So you can, using facial landmarks, you can track and detect the motions, and as Marcelo just told us, do pain detection in cats, and estimate the inner state of an animal just looking at it. And for that, we started, as you saw, with cats. So we developed a data set with cat facial landmarks. And all these landmarks are connected with the cat facial action units, basically, and with the FACS. And these allow us to imply the landmarks in different studies. So this is so these landmarks are all connected with the facial anatomy of the cat. So why we do that? To create an application that will track the landmarks in cats. So, but not in cats, just in animals in general. So for that, we use neural networks. So I won't dig deep into the AI stuff, but still it's very classical regression tasks. So having an image, you can predict the positions of the landmarks. So for cats, we have 48 of them. So it works pretty fast. Not like currently, it's not like real time, but it's still processing like I guess I remember 5 images per second. So there are there is a place to improvement. So how we do that? We zoom in several times into animal's face to make more precise detection, because if you measure angles, for example, or gaze of the animal, you need to understand precisely the position of the specific points. Or if you want to, like, I don't know, measure the how the animal is blinking, you need to measure the coordinates very precisely. So it's important to zoom in to detect. And actually, this is the example from model for cats which we've developed, and it's working now. And just to show you, we started, as I told, with the cats. Here you can see a video how the landmarks are detected. And yeah, so our goal is to make this for as much animals as we can. And for dogs, we just started our work, and now we are on the face detection step. But we really hope to make our model work for different animals. And yeah, so our challenges are, as you can see on the top image, the detection, it's not very accurate now. So for example, the right ear of this cat is not detected very good, but still, so there are places, there is a place to improve the model. And also, as you are mostly our dog people, so we plan to move to dogs and to different animals, because as you can see, even for the tiger is like, for us it's a big cat, but for computer it's not like that much. Some of the landmarks are detected alright, but some of them are not. So even with the slight movements between breeds and animal types, there is a high jump from the AI's standpoint. And yeah, so we want to collaborate and to create, first of all, a landmark detection system for dogs, and then for other animals. And the last thing that I will say, that using these landmarks, it is possible to really understand and to imply all these things that you spoke about today. And it is possible to do it with a less effort you spend the time and effort you spend now. And in my opinion, it's a great thing. It's a great instrument to automatize and make the animal-computer-human interaction more efficient. That's it.
Thank you. Questions?
Out of curiosity, how many frames do you need to have a basic training for?
Please repeat the question.
Yeah, so the question is, how much data do we need to train a model? And actually, that's the most important and most milestone. No, I don't. Whatever. So I think that just to start a model to work somehow good, I guess 1,000 images. Yeah, and
Of the same animal?
yeah.
Okay.
So, but you can start from.
Not the same individual.
Yeah, just an animal.
Okay.
So the quick answer is that you can take like 100 of images and train your model on these 100 images. It will work bad. Then you'll predict with this bad model on more unannotated images, and just repeat this thing, just adding more data, just correcting the results you have. Yeah.
Just a question and a remark that in dogs, there is so much discrepancy in the extreme morphology. Like when you take a bull terrier, you take a
Yeah, that's correct. So the question and remark was about the dogs have a lot of differences in appearance and face structure, and that's a really good question. So when creating the data set for dogs, when training a model for dogs, we need to make sure that we include all these, like at most as we can, like different structure of faces. So yeah, that's a real thing.
Can you use transfer learning that is based on human and cats for training dogs, or the differences are too big and it's better to start from scratch?
All right, so the question was, can we use transfer learning? For those who don't know what's that, is like models trained for humans, for example, because we have a lot of data for humans. Can we imply these models for different animals? The question is, if you are doing that for, like, for example, 5 landmarks. So, for example, you want to detect eyes, nose, and I don't know, mouth or something. It is possible. But if you want to like detect like very small details and like specific of the particular animal anatomy, you need to create a model specifically for this animal. So you need to differentiate the animals. But if you want, again, if it's like a simple task, it is possible, yes. Yeah.
So, it's a different lines model for pain, for emotion, and for the other things?
So the question was, do we need different models for different tasks?
Detect the emotion and pain
Yeah.
and something else?
Yeah, so basically when you have this landmark detection model, you have just positions, like the coordinates of the specific points of, like, on the image or on the video. And you can do everything you want with these numbers because they are just like coordinates, they're just geometry. And if you want to detect pain based on these like points, you can do that. If you want to detect emotions, you can do that. So it's like an instrument for you to explore and to understand the animals.
For human also?
Yes. So I guess there are instruments of like emotion estimation and pain estimation for humans now, like existing, but they exist because we have a lot of data for humans, and it is not true for animals, unfortunately.
I guess I use CNN for the notes. So in the last 2 years, one body of work that trying to show that CNNs are really bad at out of context samples and not really good in stability, exactly, especially when you consider different environment, different lighting conditions, etc. So I guess if you want to make an application, it would be resilient to this kind of standard. So have you considered, have you measured the stability metrics for your application?
Yeah. Okay. So the question was, like, what exact models did we use, and how to, because not everyone is familiar what's the problem you're talking about. So the quick answer, this zooming strategy is like making the models work with the very particular parts of the animal's faces. So for example, for cats, I have like 5 models, one for like 1 ear, 2nd ear, 1 eye, 2nd eye, and a whiskers region. So when I do that, I crop all the rest information, and because of that, models are pretty, like, they do pretty good. So because if you take just one model and give it the cat's face, it will not detect 48 landmarks. It will like perform very badly. But if you zoom in, you work with less landmarks and you do, like, crop out the not important information. Yeah.
When training the model, do you use, I assume you use tagged images, so you already have landmarks on them, right?
Yes.
Who is tagging the images? Do you need experts or do you do it yourself?
So we have a person that who annotates these images, But again, when we collected our data, we did like this step-by-step improvements. So first we annotated a bit of images, then we like corrected the new predictions, and through time it became more stable and performed better. Yeah.
Okay, thank you. We need to switch to the next, and thank you so much.
Thank you.
Our last speaker for this session is Tali Bonet-Chitrit, and your presentation is here.
Hi, I'm Tali, and today we'll talk about deep learning for recognizing the emotional states of dogs. It's based on a paper published last December on Nature Scientific Reports, and if afterwards, after this talk, you still have questions or suggestions, I'll be happy if you contact me. A brief overview, we'll start with motivation. Okay. Then we'll present the data set, explain our approach, explainability of the neural network, and then we'll summarize. One of the most basic definition for emotion is some kind of reaction to a stimuli, and today it is widely agreed that this is not unique just to human beings, but also animal experience emotional states. And it is not just scientifically interesting, but also ethically important, because if we think about animals under our responsibility, pets, farm animals, and so on, they rely on us for their welfare, and we need to let them experience good welfare and avoid negative experiences. This can also help us predict their behavior if we understand their emotional states. And other things we can learn is how emotions have evolved and what's common to human beings and animals in that aspect. A main channel to understand human emotional states is facial expressions, but most mammalians produce those facial expressions, and they are assumed to convey information about emotional states. Despite this connection between facial expressions and emotional states, there are not many works addressing these topics. This is mainly due to the absence of designated controlled data sets. And this is more prominent in dogs because of the big morphological differences in their faces. We'll start that again. We had the great opportunity to work with Dr. Annika Bramhost, who shared her data set with us. She built it during her PhD, and it is very controlled, in very controlled setting with strict protocol. And it is also built only with Labrador, so this standardized these differences in the dog faces. These are some more technical details about the data set. I won't go too much into that. As explained before, Annika in her work used the DogFACS to annotate her videos and found some connections between action units and the dog emotional state, frustration or positive anticipation. However, in this research, we use deep learning technology. Deep learning is inspired by the way human brains learn from examples, and it can find very sophisticated patterns just by itself without help of human annotation or decisions. And it is data-driven, so data is the engine behind it. We need a lot of data to make it work. And it is known to get state-of-the-art results in many computer vision tasks, and we tried it here. A quick overview of the pipeline. So we took each video and cut it into frames. We worked on each image individually. In a pre-processing stage, we cropped out the dog face, so our deep learning network would concentrate only on the face and not on other face, body parts. And then we had the deep neural network that was trained to classify an image as a positive valence or a negative valence of the dog. And we tried several options for that neural network. Afterwards, we summed up all the classification results we had, and according to a majority call, decided what was the valence of the entire video. So this is a summary of the options we tried as deep neural networks. These are all networks, architectures that were proved to be very successful. And there's the combinations between the network architecture and how the initial weights were obtained before we trained it. These are the results, and you can see that the best result was with VIT, Vision Transformer, that was initially trained with Dino. We got 89% of accuracy, high above the other options. And this is not just, didn't just happen. We believe this combination would be the best because Vision Transformer and Dino that were introduced in the last few years by Google and Facebook have very special features combined together. Vision Transformer can measure relationship between image patches, which previous architectures were not very good, not at high resolution of the image. And combined with Dino, it seems to find very easily interpretable features that are biologically interpretable for us. And they are rich enough to separate very small differences in the objects, such as the eye posture or the ear posture, things a human expert would look at when deciding the balance of the dog. Our next challenge was to try and understand what did the machine see. How did it get this high accuracy? Because though deep learning have very good performances, very high performances, it's a very sophisticated algorithm, still considered a black box, and explainability research is still in its infancy. And we used the method called heat map, which is taking the input image and then by using an algorithm designated for that, highlight the characteristic that most influenced on the output of the network. This is an example of an image fed into a neural network that was looking for cats. And we can see the cat area highlighted here, so we understand that indeed the network was looking on relevant data, which makes sense also for us. So we did some tests with the explainability. First thing we did was trying to compare the different heat maps that were produced by different backbones we tried, by different neural networks we tried. So in each row, you can see on the left the input image, and next to it, the 4 heat maps produced by the different networks. And the most left one is this of the winning combination, the Vision Transformer trained with Dino. And you can really see how it uses more facial areas and how these areas are localized so much better than the other options that are sometimes really blurry. Next, we looked at videos that had no action units in them. So the annotation couldn't find any DogFACS action units. A human expert could not decide based on these videos what valence was the dog in. Yet almost 80% of those videos were correctly classified by our model, usually focusing on nose and mouth area. And in the other 20% where the classification was wrong, we saw really blurry, unfocused maps. So indeed, I think there was no information there to rely on. Lastly, we tried to find a relationship between our heat maps and DogFACS action unit. Try to connect between our model and some behavioral biological concept. And we used the ear flattener action unit since Annika found it to be strongly correlated with negative valence, with the frustration. And if we looked at positive videos that were wrongly classified as negative one by our model, we saw that in the majority of them, the ear flattener was very massively apparent. So it seemed to confuse the model and make it decide that this was a negative video. So it seems it relies really on similar features to those we would use. And these are some examples of negative videos that had a lot of ear flattener in them. And again, we see that the machine concentrates a lot, many of the time, on the ears and sometimes on other facial parts, which should be further investigated. So we saw that deep learning can give us a very high accuracy, automated process to a very scientifically and interesting and important questions about emotional states. And explainability method can enlighten some behavioral and biological concepts. And to make this work better, we need the expert involvement. We need more data to use in our models, and we need help in analyzing this data and understanding it. And what we most need is assessing our explainability methods to make them better so it can be useful for animal behavior experts. So if there are any questions.
Thank you. Questions? Okay, I guess we are too hungry for questions. So we'll take a break. Okay, thank you, Tali. So we are taking a 30 minutes break, and we'll be back with more exciting talks.
This time we are going to include the Barcipalic breeds. So this research is automated analysis of dog respiratory sounds. This is a joint work with our college from Hanover University of Veterinary Medicine. So today, with the increasing demands for Barcipalic breeds, that is flat-faced dogs, for example, this pug or French bulldogs, so there is more welfare concern in the spotlight of the popularity about the health problem with this species. Barcipalic species health issues from extensive breeding. That means that all of us want this cute pug with big eyes. So it's creating a health problem because of the structure of their head. About 42% of the extreme Barcipalic breeds are affected by BOAS. That BOAS means Barcipalic obstructive airway syndrome. It's basically a chronic disorder in the Barcipalic breeds. The symptom of it is respiratory diseases that we can hear in the sound. It have a heat intolerance that, for example, even after 10 to 15 minutes of exercise, they can already have some kind of respiratory problems. And this could also lead for distributed sleep. Today, the impact of BOAS and the challenges that in the post-surgery, 50% of dogs don't survive a post-BOAS surgery. That means that early planned surgeries tend to have better outcomes. And that means that we want to have an early detection of these BOAS symptoms of course, we want our dogs to be healthy. So about the diagnostic of the BOAS, so today the traditional way that is more manually, it's pharyngeal occlusation. That is the trusted and established method. And this is, of course, rely on improved efficiency and expertise of veterinarians that would need to check, of course, the dogs. So our idea in this research is to have complementing with AI. We want to add AI to this diagnostic, so that we still have the veterinarians that check the dogs, but we also want to add some AI tools to help him, to be like a second opinion. So AI offer potential enhancements to these established methods. It aims to consistent data-driven insights to support veterinary expertise. Now I will give some sound demonstration. So we clearly see that we have here some breathing problem. About the evaluation in the diagnostic in the human medicine, as it's more advanced. So today the traditional methods are similar. It's using stethoscope and manual accusation. And this is, of course, limited by human hearing and interpretation. We need a doctor to do such a thing. And there is a modern innovation. There are many startups. For example, there is the Simo Medical Solution that's developed a coach monitoring technology. And there is other startups that are using automated coaching monitoring systems, breathing analyzing smartphone application for respiratory sound analysis. And this is basically to make a transmission from a manual to automated data-driven diagnostic. So here our vision is to do the similar way, the similar path, that to move from stethoscope to application. So today veterinarians are using stethoscope for osculation, and we want to add a data-driven interpretation. And today there is the data-driven interpretation based on year of training and experience of the veterinarians, of course. So our vision is to make some kind of digital platform and application for the dog's owners. They can, in real time, to have an analysis of their dogs, to get an early BOAS detection, and to personalize feedbacks, because At the end of the day, we want this app to be suited for the dog's owners, so the personalized things is also an important aspect. About the data collection, so the data collection was done by the University of Veterinary Medicine in Hanover, Germany. More specifically, it's for Jana Turko, that she's done all the data collection. The study specifically used 69 pugs and 70 other Barciphalic breeds. And there were healthy dogs and age over 2. And the recording process was the dogs participate in 15 minutes treadmill test, because we want them to have an exercises then to see if there is a Boas patterns. And the respiratory sound were captured using electronic stethoscope. To move to the AI in the Boas diagnostic, the idea is to AI offer us objective sound analysis. It's proven the potential in the human world, as we saw before, but also there is a potential in the animals world in the sound analysis. That, for example, there is many researchers that using AI to distinguish between type of birds solely based on audio and AI. So our idea to do the same thing, but for the respiratory pattern. And this is eventually to complete the traditional experts that we still need the veterinarians to do the checking for the dogs, but maybe to add another tools that can be some kind of baseline or a second opinion for the veterinarians, or also the dogs owners themselves can just by applying this application to see some kind of analysis for the dog's breathing pattern. So we analyzed the respiratory sound to determine and predict the Boas outcomes. And we also wanted in this research to detect a specific breathing noises, including the Boas cervity. And the idea is to utilize tailored algorithms for accuracy and reliability. The algorithm itself, so first of all, we have the raw data that Jana collected. Then from this raw data, we took some important features in the sound itself. For example, energy features, features that are more related to the pitch. And then to use AI based on those features that will give us eventually the prediction. And the result of it, we use this AI on 100 of audio samples from the Barciphalic breeds. And this is complementing to the traditional diagnosis methods. We got a high accuracy in the Boas outcomes. We also got 80% accuracy in specifically breathing noises detections. And the significance, it's demonstrating the AI transformative potential in the Boas disease. And this also paved the way for objective data-driven canine health assessments, as we eventually have here an AI model that just like that can give the prediction. About future works that we want to do. So first of all, it's a real-world testing. We use right now a more a controlled environment. That means there isn't noises from the outside world. So to creating a model that working with more real world with noises inside it, it could be, of course, the next steps. Also the application development, as we spoke before, we want that every dog's owner can have the application for tracking their dog's breathing pattern. For now it's for the Boas, but maybe next it will be even other type of problems in breathing. Another thing that could be interesting is more personal diagnostics, to develop algorithm that not generally detect if there is Boas or not. So to create a model that maybe making more monitoring for the dogs and maybe have more specific, can get more specific information about the dog's breathing patterns and not in general. So to conclude this research, so first of all, AI is revolutionized the Boas diagnosis. We achieve a good accuracies. And the road ahead is to create really a platform for the canine diagnostic. For now, it's just for the Barcipalic breeds, but maybe for even more types of dogs, of course. And to make an app for the dog's owner, a real-time buzz detection, and of course it's important the early diagnostic, the personalized feedback, because if we want that the platform will be user-friendly, it needs to be more suited for the dog's owner themselves, and of course the proactive care. Just for before the end, to give many thanks for Jane Turkos, Dr. Sebastian Meller, Holger Volk, that they do with us this research together, and they help us a lot with the data collection, and yeah, and that's it. If there is some questions.
Any questions? Yes.
Do you happen to check correlation between the detection or the intensity of the Ebolas and the practice-to-palate ratio, or how flat exactly is the dog?
Can you repeat the question and then?
Yeah, can you repeat it?
Yeah. Okay.
I was wondering if you checked if there was a correlation
Mm-hmm.
between how ROAS was expressed, like how bad it was, how noisy the dog was, and the flatness of the dog, what's known as the practice.
So we did more on the audio aspects alone, so we didn't really enter to this. But yes, I think it's important aspect because we have a correlation between the sculptural structure and of course the buzz outcomes.
And one more thing, are you planning on maybe trying it on cats, practice-to-palate cats as well?
Yeah, I think it could be interesting. Yeah.
We would love to have such data.
Yeah.
Anyone
Yeah,
can
if we
give
have the
us.
data.
Yeah, I have it.
You have it?
Okay.
So it's a done deal.
Yeah.
That's our next project. Okay, any more questions? Yes?
What if you compare it to data of dogs that are not practice-to-palate but have some kind of respiratory problem?
Yeah, it could be interesting. I mean, our data was mainly on this type of dogs because, of course, they mostly have these problems. But sure,
It
could
would
be.
be interesting to see
Yeah,
the
yeah, to
difference.
see
That, you know,
the
this
difference.
dog just has sniffles and this is a practice-to-palate.
Yeah.
Okay, thank you so much, Ariel. And now we have time. And you want to use your own?
No,
Oh,
it's on.
okay.
Yes.
So our next speaker is Dr. Tal Asif from Lod Municipal Shelter and Hebrew University.
Hi everyone, so if everything will go up.
Okay, good. So after you all ate a lot of lunch and you're ready to sleep, I had a friend once who was an anesthesiologist, a veterinary anesthesiologist, and she said, if you were asleep by the end of my lecture, then I've done a good job. So,
Please stay close to the
yes, oh, I'm
microphone
sorry, I'm sorry.
because your joke was
Yes,
based on
oh.
the participants.
So I'm a shelter veterinarian. Hopefully you'll stay awake by the end of my talk. So till now, everybody, we're mostly talking about the technical aspects, the ways to gather data, which is all very important. But I'm going to talk about the end point as a clinician, okay, the end point view, and this is why I'm here today, and this is why I'm working with Anna. How do I use that? Good. So being a shelter vet, okay, and a shelter director, basically my ultimate goal is to get all the adoptable animals in the shelter to be in forever homes with responsible owners, okay? Now that sounds like a great ultimate goal, but there are a lot of small things in the way that may interfere to me as a shelter vet to get to that. First of all, adoptable animals. Which animal is adoptable, right? Second, find forever homes. Who guarantee that I just got a call today from one of my coworkers that someone brought back the dog he just adopted, right? And responsible owners. Okay, that's a different conference. That's not for today. Okay. So what we're going to talk about today is the way I see it as 4 circles in the shelter. Now, the first one is pretty much obvious, the physical health of, we'll stick to dogs, okay? But because everybody talked about dogs, most of the speakers talk about dogs today, okay? When I say dog, I mean dogs and cats and rabbits, as far as I'm concerned, okay? So first of all, physical health. That's pretty obvious, right? We want to know, we want to make sure that the animals that are under my responsibility are healthy. That's easy. If it's limping, then there's a problem, right? We understand that. The second part, as you can see in the circle down, I'm not used to stay in the same place. I'm trying to keep it, so I'll just jump, so you'll say, okay? So the second circle, as you can see down there, can you see it? Yeah. Now, yeah, can you see it? No, right? It fades into the skin. That's the problem with technology. Yeah, I know. I can use them later on. So the second circle is the behavioral health. Okay, and it's not always common for the common person to understand that behavioral health is a huge, significant part from the entire health of the animal. Okay, so I look at behavior, and Stefan is going to talk about that, I'm sure, later on. But I look at the animal as soon as it gets into the shelter and assess the behavioral health. Now, behavior will change as the animal go through the process of the shelter, from getting into the shelter all the way to hopefully find a home or return to the owner, right? But I need to assess that as well. And if there is a behavioral problem, we're going to talk about this later. I need to get to understand that there is a problem right at first. Okay, as the sooner I'll know, the easier it will be to fix it. Okay, but that's Stefan's area. Okay, now these are still pretty easy to understand. Now we're talking about a more vague definition. The first one will be welfare. Okay, we always talk about welfare, but when I talk to colleagues around the world, let's say Southeast Asia, okay, it's okay for them to keep sick animals in the shelter. We have an outbreak of something like a distemper. Distemper is a very bad viral disease for dogs, okay, and they will keep all the animals alive in the shelter and wait for them to die because it's a bad karma to euthanize an animal. On the other hand, my other colleagues at the other side of the world in the United States will euthanize everybody, right? To prevent the outbreak. I don't know which is right. There's a lot of cultural thing going on in welfare. Okay, we're going to talk about that later on. And last but not least is adoptability, right? I want these animals to be out. What makes an animal adoptable, right? And hopefully, with whatever was discussed later on today, earlier on today, we're going to give some answers. Okay? So initially, because not everyone is from the field of shelter medicine, I'll just go over very briefly the background. First of all, the 5 freedoms. Did anyone ever hear about the 5 freedoms? Oh, good. Good. Okay, good. So for those of you who did not hear about, the 5 freedoms are basically are driven from food animals, surprisingly, and basically it's the freedom from hunger and thirst, okay? The freedom from discomfort, the freedom from pain, injury, or disease, okay? And the freedom to express normal behaviors, and freedom from fear and distress. Okay, these are like the basic things that I need to make sure that are happening in my shelter as a shelter director. Okay, and I'm trying to base everything in the shelter on these 5 freedoms. Everything I do, everything I see, is based on that. And just a sec, I don't know what happened here. Okay, and then after that, there's some guidelines, okay? We have the Association of Shelter Veterinarians that they wrote some guidelines that were renewed to just in late 2022. And they basically set the standard, okay? And in every different place in the world, and for example, in Israel, there is a pretty vast law and regulations that declare what can be done and not can be done by law in Israel. For example, right, I cannot put a cat in a carrier to be his normal place of residence. It's against the law in Israel. There's no legal definition in the United States, for example, but in Israel it's forbidden by the law. Okay. In some cases, I have to make sure the shelter's dogs are being walked out of the cage at least once a day. This is a requirement of a law in Israel. Okay. Okay. So you see, we'll figure it out. Okay. So let's talk about a little bit about physical health. Okay. So I'm going to tell you a story. I just spent a family vacation in Copenhagen 2 weeks ago. And when I got back, I went into the shelter. I saw one of the dogs, and he was going like that. What do you think this dog had? Like that. A bit of head tilt to them. What does he have? An ear infection, right? So apparently nobody at the shelter, no one of my staff, have seen it for the past week, right? I came like a week after, and I see the dog like from 50 meters, I see the dog going like that, okay? If I had something, I'm looking at you guys as the tech people, to give me a signal, okay? To know that something is wrong with that dog, I'm sure someone would treat it. They just didn't notice because they are so occupied with their daily assignments and job, and you know, it's really hard to work in a shelter. It's hot, it's humid, it stinks, everybody's barking at you all the time, bosses and animals, right? So I can understand why they miss that. And there's a lot of emotional, there's a lot of mental stress on the workers that they can sometimes miss things. Not because because it's their fault, because it's hard, right? And if I had some kind of a tool like that to be able to see, oh, this dog is limping, beep, 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 go see that. Vet, go see what's going on with that dog, right? That would be awesome, okay? Also, so one of the basic things I'm trying to monitor in the shelter is make sure everybody's eating, everybody's drinking, hopefully everybody's eating, okay, everybody's peeing. Let's say in cats, if a cat is not peeing, that could be a huge problem. This could be a life-threatening problem. It's more common in cats than in dogs, and I want to know that, okay? And I want to know if the cat is not peeing because it's stressed out or because it has some urine blockage somewhere that could threaten the life, right? So again, these things that physical health is important, right? And we're going to see later on that physical health is connected with welfare and with behavioral health. Okay. Yeah, okay. If I'm talking too much, say something, okay? Okay. So again, behavioral health. Okay, we call it it's not a psychological or emotions. We try not to stay in the emotion parts. I'll leave it to the experts. Okay, I'm looking at behavioral health. Okay, that's the definition for us in the shelter. Okay, and it's an integral part of the animal well-being in the shelter. I take care as much as I take of physical health and as I do on behavioral health, okay? And it's really important, like it's important that I will see the minute the dog starts tilting his head or scratching his ear, I want to be able to recognize when the dog is starting to have an obsessive compulsive disorder. When does that Malinois start circling? Before it starts circling, it's going to show me signs. And I want to know these signs ahead, because if I get something, some markers that are going to show me the signs, I'll be able to treat that dog and hopefully find a home for that dog. Because once a dog is having behavior problems, it's harder to find homes. And when they have behavior problems, it affects their emotional state. They get more stressed. The behavior problems are getting worse, and it's a vicious cycle. And unfortunately, oftentimes the situation is so bad that I think it's abuse to keep them in the shelter. Okay, I hate to say that, but when we look at reasons we are euthanizing animals in the shelters, I'm talking about the entire country right now, most of them will be because dogs were not adopted, and most of these dogs are not sick. They have behavior, health problems. Okay, and we can hopefully we can solve these if we initially diagnose them and treat them and make sure those dogs are going on the right path other than the wrong path. Okay, obviously we want to make sure that we're keeping the daily routine, and we want to, like I said, and give them some stimuli, hopefully that it will keep their welfare intact. Okay, now once we have normal behavior of dogs, people will more likely to adopt them, right? We had a big seizure of dogs, a big So we caught some dogs from a person in Lod, okay, because he was mistreating them, okay. And these dogs they're small dogs, which are pretty attractive to most of the adopters. It's like pincher mix, but they all have huge behavior problems, and they were not socialized, and they're not used to people, okay? And we need to make sure their behavior is normal before we can give them to homes. It will be really easy to find them homes, but we need to make sure we deal with the behavior problems before. Right? And on top of that, it's easier to get dogs for adoption if they know like basic commands like sit or something. That if we're gonna put someone who's coming in to see, who is looking for a dog, a potential adopter, and they're gonna see the dog is looking at them and he's sitting next to them, right? You all want to take that dog, and instead of the dog that was circling in the yard and only trying to escape, right? It's gonna be a huge difference. And again, if I'll have a good behavior, if I'll be able to monitor that behavior, and if I will be able to monitor the effects of my enrichment, okay, to see if I'm getting better in the way that the behavior the dogs are described or demonstrating, then I'm on the right path. And like I said again, most of the return adoptions are due to undesired behaviors. So today, someone brought back a dog from adoption back to our shelter, and he says, "Oh, the dog has diarrhea." And I told my colleague, "You should tell him diarrhea is a temporary state. We can resolve that." "Oh no," and the dog is biting by the kids and it's not, and it's chewing the sofas, and so again, these are chewing the sofa, biting kids. It happens. He doesn't want the dog. Okay. Once they got to the point, well, it's a different talk. But once they got into the point, they don't want the dog, and they're in the shelter. It's irreversible at this point. They're not gonna take the dog back home. Okay. This problem should have been solved earlier. Before we should have better explanation to these owners about what to expect. But this, again, I'm trying to focus and stay focused on the artificial intelligence tools and new methods to measure behavior, and not to talk about the more soft quantities of shelter medicine. But again, so basically, that guy didn't want the dog because of behavior problem. Okay, it's a typical puppy behavior problems, but again, if I could work more on the dog and get better results
by training the dog, hopefully, maybe he wouldn't bring the dog back. But that's a different story. Okay, so we talk about physical health, we talk about behavioral health, okay? And now, as you can see in this graph, there is also correlation between welfare and physical health, okay? So what they've done here is it's actually, this is a study that was done on cats. They have, you see the small, the mixed 1, mixed 2, and large. These are the sizes of the kennels in which the cats were in. And as you can see, the LR, the percentage, is what percentages were out of the shelter alive. That's live release. That's the name of the term. Okay, as you can see, the bigger the kennel or the run or the cage was, the better survival percentage for cats in the shelter they had. Okay, so what happened basically is they had bigger cages. They had better welfare. They didn't get, mostly what happens to stressed cats, they're getting an upper respiratory infection in the shelter. And then it's getting worse. They stop eating, and then we start with vicious cycle of other medical problems. Okay? So we increase the welfare. They are less stressed. They can express normal behavior better. They get less sick, and they get better, and they get out of the shelter alive. Okay? Okay, so this is my main problem as a clinician. There is no clear measurement for animal welfare. Yes, you know that? You know that? Good.
We know it.
Okay, so
wait until the next talk.
Yeah. Yeah, so there's this shelter quality sheet that you can use in order to assess welfare. The problem is, like, there's no good validity. It's not very good valid, and it's not very very well standardized. And this is the reason why it's a bit elusive way to actually check welfare. We need an objective way to test welfare. I need something to show me, okay, you're doing it right, you're doing it wrong. Okay? And this is where you guys are in. Okay, I'm talking about this part, right? Because this part, I've seen, this part is mostly like the clinicians, and this part is more the research. Sorry, Stefan. Should move to that stuff. But, okay, so basically, I need you guys to give me tools so I will be able to, I will be able to see if what I'm doing is right or wrong, if I'm keeping the welfare of the animals or not. Okay? Okay. Since I don't have too much time, okay, we're gonna move to the most vague term. That's adaptability. Okay. So what makes an animal adoptable? So in Israel, everybody they come to the shelter. They say, I want a small white dog that doesn't shed hairs and does not bark. So what I usually tell them, okay, I know perfect place for that. You can go to Toys R Us. There are a lot of toy dog over there, and they don't bark, they don't shed hair. No, okay? A dog is an animal, okay? It needs to be treated right, okay? There are some quantities that I can make better, like behavior, okay? There's some other quantities I cannot change. I'm not gonna saw all the legs of all the Malinois that I have in order to make them shorter so they will fit into homes, okay? But again, if what I'm trying to do in the shelter basically is say, don't tell me the breed, tell me what are you expecting from a dog to be? What do you want the dog to be able to do? And again, you guys are getting into that part too, because you can assess, okay? You can assess the dog's behavior. And you can, well, it's not going to be 100%, because the way dog is going to behave in the shelter is going to be a whole lot different than the way the dog is going to behave outside the shelter. I mean, so I like 2 years ago, I adopted the dog from our shelter. So she used to pee and poop in her run, right? But once she got into the house, she never pee or pooped once, okay? So, and again, it's going to be a process, because she's going to be acting in one way in the first 3 days, and then different way in the first 3 weeks, and then different in the first 3 months, and then it's going to be some kind of routine, right? Okay, so they're going to express most behavior problems are going to be within the next 3 weeks, the first 3 weeks after adoption, right? But it can give me some, if I'll be able to know, okay, this dog has a lot of energy, obviously it does not fit the adopter who's 70 years old and lives by herself at the 5th floor, right? Because it's going to drag her all the way down the stairs, right? And I'm going to get the dog back. But I need these tools to be able to better understand the dog's behavior to some level, okay? And then I can ask the potential adopter, what do you need? What are you looking for? And then I can do the match, okay? And also I can tell the adopter what to expect. Okay, this dog will do this and then and that, and won't do this and won't do that, right? Okay, so let's try to conclude and wrap this up, because I really try to do as fast as I can in order to keep up with the day. So basically, animal welfare, adaptability, and physical and behavioral health are tightly connected. Okay, there's a good correlation between all these terms. Okay, and eventually, when I pay attention to all these components, I can make these dogs to find homes. If I'm gonna neglect any one of these components, impaired welfare, not taking care of diarrhea in the shelter, and not checking the behavioral health situation causing obsessive compulsive behavior, it's gonna damage my adoption rate. Okay. Behavior and behavioral health is an integral part of the shelter's work. Okay. And it's easy to neglect it, and we used to neglect it for a long time. Okay, we did not pay any attention to behavior, I think, until at least in government or municipal shelters, we didn't pay attention to behavior until at least 2015. The dogs would just sit there, and hopefully someone will come. Okay, we have made huge progress in that, and hopefully this day will make another progress in the near future with what you guys are doing. And what you guys are doing is amazing to me as a clinician. Okay, and hopefully it will help me to fix some of the parameters of a dog that I can fix, to make them better and make the best potential of that dog. Okay. And we need some ways to objectively measure the quality of life, right? Because once we have an objective, I can know if I'm getting their welfare better or worse, or nothing is moving, right? I want to be moving to a better quality of life for the dogs in the shelter, rather than decreasing quality of life, right? Because if I'm doing something right, I need to change it, because at the end I care about these dogs. I'm not afraid to say I don't sleep well at night. If tonight's gonna be a storm, and I'm not gonna be sleeping tonight. Yeah, it's gonna be a lot of rain tonight. And I already called the shelter and I told them, hey, you need to get ready, because I want to be able to sleep well tonight, because I know they close the shades and there's not gonna be any rain coming in, right? And the last thing that I need from you guys is to get some markers on animal behavior. When the dogs are getting worse, like they're getting into the path of developing an obsessive compulsive behavior, I want to know that. I want to know that, because if I can stop that right at the beginning, I can save this dog's life. If I'll get to the point that this dog is circling in the run, then it's too late most of the times. Okay? And I think that's pretty much it. These are my references. And
Thank you so much.
Any questions?
you need to define specific symptoms for model to look for. So do you have, like, for example, like a dictionary or like some kind of list of symptoms to look for? Can you define such a thing?
Well, that's a question for Stefan more as a behaviorist. But yes, I can see when the dog is getting less active, less interested. For example, a very good example would be you go into the shelter. Is everyone has been to a shelter here? Okay. Well, if not, you're more than invited, and if so, you're also invited to our shelter whenever you want. Okay. But basically, so I go into the shelter every morning and every end of the day to check all the animals. Okay. As the shelter director, I want to know what's going on with the animals. So if I walk inside and I see all the dogs will come towards you and they're going to stand up and bark, right? If you're going to see the dog that doesn't come to you, that's the most problematic dog. This is the dog, but again, this is a pretty later on the stage, but you're going to see, and I start seeing things already in the intake exam. When I do a physical exam on the dog, the way the dog is going to behave, okay? I will know most of the times what's going to be later on. But this, again, this can be changed throughout time. It depends how are we going to do what we're going to do with the dog. Did I answer the question? Perfect. Anyone else? So they're either all asleep or was very good. Oh, yes.
Hi. So thank you for your presentation. Just a question, perhaps a remark. When you speak about behavioral health, don't be afraid to cross the river. Don't be afraid to say mental health. Why I'm saying that? Because behavioral health, you have lots of sick dog is first of all the dog which is showing you a behavior which is not normal in the context in this intensity or frequency. Meaning like a dog that is not eaten, that is not drinking for more than 24 hours, this is behavior. Right?
Yes, totally.
Okay. So when I hear your presentation, I say to myself, wow, it's a sort of mix, and I was uncomfortable finally because of the wording. Like, behavioral health? No, let's go, mental health. Cross the river, really.
So I'm just going to say it to those who are watching us at home. So basically what Stefan says, being a behaviorist, is don't be afraid to cross the river and go from behavioral health to mental health. Okay, and I'm taking that note. Okay, the way I was taught
it's
is
not a critique. It's
yes,
just,
yeah.
it's just to prove something.
I agree. So the way I was taught was do not call it mental health because it's not psychology of people. But I am taking that note and I agree. Dogs do have mental problems. For sure. I see them all day. Yes, go ahead.
Yeah, so this is a question from YouTube. How about using CBAR, ASPCA, Safer Test, or MATCHA 2 as tools for behavioral and welfare assessment and guides to behavior modification plans in the shelter?
Oh, that was a long question.
Yeah. So there's a lot of tools, I guess questionnaires.
Like
such as
CBARC.
CBARC, ASPCA, Safer Test, and MATCHA, like tools that are not automated, as I assume, that are just questionnaires. And the question is, what about using those for welfare
So
assessment?
the problem with most of these questionnaires is there's no inner validations and not very well validated. So they're not objective enough most of the time. So because they're not objective enough, they can cause bias at the results. And this is the main, like I said, this is the main problem for me as a clinician. I do not have an objective, non-biased tool to assess welfare. This
I
is why.
think CBARC is validated, but it is for owners, but you,
Yes,
those
well,
dogs don't have owners. So.
For dogs in a very specific environment.
Exactly. Okay, very
Julia.
I just have something related. Like they are validated, but so they are questioned to the humans. So you already know, like what you are responding. Like you would want something that, like, take into account something that you don't see and you don't know, because obviously a questionnaire I answer in the evening. Oh yes, this dog was doing this, this, and that, and I would not like perceive what I didn't perceive.
Okay, so
This
basic.
is what we need. Like if you have a video that is video recording and analyzing something that you don't see, but this questionnaire is just your report. Of
Okay,
the day.
so basically what Julia is saying is that these questionnaires are based on observation that we do, and they're not validated enough because it's based on personal opinions, subjective observations. Anything else, guys? Okay,
Okay, thank
Very
you
good.
for this thought-provoking discussion.
thank you.
Okay, and our next speaker is Tiziano. Tiziano Travain. Will you use your laptop? No. Okay.
So good afternoon. My talk will be about infrared thermography and the telemetry as methods to assess dogs' welfare and emotions. Okay. So my introduction will be very short because I don't want to repeat the things that other people have already said, but we will speak a second about emotions and welfare, what are they, then we speak about the infrared thermography, the principle and the application of IRT, and finally I will outline a telemetry case study that we made with shelter dogs, and we are ready to publish with the collaboration on Anna and her team. So this quote is quite famous, but it doesn't settle the matter of what an emotion is. Luckily, we have a definition by Fox. So an emotion is a brief event. It consists of a coordinated set of responses, which may include verbal, physiological, behavioral, neutral mechanism. It is usually triggered by an external or internal stimulus. Again, something that Julia already said, emotions are characterized by arousal and valence. These are linked by a Cartesian axis system in which we have different states. Again, okay, this one is new. So from an ethological and biological point of view, there are the 4 questions of Timbergen. These 4 questions are divided in 2 couples: the proximate causes of a behavior or any biological structure, and the evolutionary view of this biological structure of this behavior. If we apply these to emotions, we can say that the ontogeny of an emotion is the gene interaction between them, among them, the gene interaction with the environment, parental care, and precocialization. The mechanisms that rule an emotion are neurological, hormonal, and there are cognitive substrate. The evolution, we know that the emotions are unchanging in structure and function in a very long period along all the vertebrates' evolutionary history. And the function of an emotion, usually an emotion is needed to motivate the expression of an evolutive strategy to optimize the fitness of an individual. So the emotions. There are 6 emotions according to Ekman's model. The first one is joy. It is an intense, positive affective state. It is event-driven and it is short. Then we have fear, that is intense and a negative affective state. This one can be short or be prolonged in time. It is triggered by someone, by something, by a situation. There are many different layers of fears. Okay, disgust. This one is triggered only by physical contact. I know that is weird, but the basic disgust as emotion is triggered only by physical contact, and the perceived feeling that being in contact with something can lead to some kind of contamination. So its function is actually preventing poisoning, preventing intoxications. Then we have anger. It is clearly bound to fear. Again, it is an emotion that can be long in time or very brief. It is triggered by a perceived challenge, a perceived threat by someone else, by something, by a situation. And it motivates us to be more aggressive or more intimidating towards our target. Sadness, this one is complex because sadness can be triggered by many different things. It triggers coping mechanisms that are quite very studied in humans. On the other hand, in animals, it is a very difficult emotion to explore, even because there is a strong cognitive component for this emotion. Last but not least, surprise, Disney Pixar did not provide us with a cute representation, so we asked an AI to generate one. Actually, we asked an AI to generate a prompt for an IA image generation. So, even if it is not present in Inside Out, it's a very, very interesting emotion because it arouses interest and it motivates explorative behavior. It is very important for the learning. And what is maybe the most interesting things, it is that it requires a mechanism for comparing an expectation with the current reality. So these are the 6 emotions from this model. The research are proceeding faster about emotions, so there are many other models. Another one has 8 different emotions, so these 6, and then there are expectation and acceptance. Some other use even amusement, boredom, and so on. There are many, many different models. I showed you the most important from an historical point of view. So again, animal welfare, we just listened a wonderful presentation about, so I won't focus that much. So we know that animal can feel emotion. We know that animal welfare is important for the studying of emotions, and we know that emotions are important for animal welfare. Again, these are the 5 freedoms. They were developed in the UK in the 1965. So it is important for the animals to have these 5 freedoms. However, the absence of negative emotions cannot be considered sufficient as a condition for calling the animal welfare done. So the animal should be in a state of mental and physical health, as we will talk just a little bit away, while in harmony with the environment provided by the man. So this is the current definition of welfare. The tricky part now is how to assess this welfare, because now we have a definition of welfare, but how we assess the welfare. We have seen this morning, we've seen just a little bit ago, that it's very difficult. So there is agreement that a combination of different parameters should be used. We can use behavioral parameters, physiological parameters, cognitive parameters, even because some of these parameters can be ambivalent. Their meaning is not that simple. For example, we had the question before, what does this mean in dogs? That's quite tricky. Even very common behaviors like lip licking could be tricky because in different situations they could mean different things. We have 1, 2, 3, 4 different studies in which lip licking was correlated to different emotions caused by different situations. So, okay, my first method will be infrared thermography. So, what is it? How does it work? Infrared thermography measures electromagnetic radiation emitted by every object that has more than 0 Kelvin. So, basically every kind of item. it quantifies the superficial temperature based on the electromagnetic radiation, and then it generates a representation of the corporal temperature. We can use different scales according to our needs. So what we have here, no, we don't see the mouse, okay? So on the right, you can see the scale that it was used for this imaging, but it is not clearly the only one that we can use. So why the infrared thermography? Stress and metabolic system are correlated. There is the HPA axis, that there is the increment in catecholamine levels, cortisol levels. All these things usually increase or decrease the blood pressure. The blood pressure changes the heat production, the emission of this heat. Infrared thermography can be used in different species. The tricky part is that different species react in different way to different stimuli, and even speaking of the same species, different area of interest in the body of the animal react in different ways. For example, we have the nasal temperature that decreases in cows during positive emotional states. However, the nasal temperature decrease in macaques during emotional states, and then there is the comb surface temperature in ants that has an ambivalent behavior because it decreases both during a positive event and during a negative event. So again, the same parameter can be tricky if it is analyzed alone. So when we, after reading the literature, the existing literature, when performing our experiments, we decide to use as our area of interest the lacrimal caruncle. So why? It has 4 characteristics that make it very interesting. It is rich of capillary beds, and it is innervated by the sympathetic system. It is sensitive to both pain and stressful events. It responds to change in blood flow, and there is changes in its temperature because both the sympathetic response and the activation of the HPA axis. So after a pretest in which we explored whether there is a correlation between rectal temperature and eye temperature, we exposed our dogs to a negative event. We went to a novel clinic, novel for the dogs clearly, and they were exposed to a standard examination visit. They were exposed to exploration of the oral mucosa, palpation of the abdomen, osculation, palpation of the lymph nodes, and after that they just waited some minutes with the owner while the vet was faking, giving the last advices, making some kind of recommendation and so on. So the second experiment, on the other end, this one was performed at our partner's lab in Milan. We exposed the dogs to a positive event, a very obvious one. The owner was giving palatable treats one every 20 seconds to the dog. And again, we had a baseline phase in which we collected the baseline temperature, and an after-treat phase in which we wanted to see if the temperature dropped to the baseline values. Finally, the third study. This one was a simplified version of the strange situation. The original strange situation was proposed in 1969 to explore the attachment styles in a mother-child relation. We proposed this simplified version in which we had a separation phase. The dog was alone with the experimenter using the thermographic camera, and a reunion phase in which the dog was reunited with the owner. Again, a final phase to assess the temperature of the dog after the experiment. So, the results. We obtained good results from the first experiment because we saw a peak in eye temperature during the examination phase. Then the second experiment had even better results because the peak is more intense. Sadly, the separation protocol was not enough, maybe, for triggering a thermal response. So, as I said before, the temperature alone is not enough as a parameter, so we added some other parameters. In the first experiment, we coded the behavior. In the second and the third experiment, we coded the behavior, and we used the polar heart rate monitor to assess even heart rate and heart rate variability. So today, I'm not going to talk about heart rate and heart rate variability because there's no time, but I will show you something about the behavior. So in the first experiment, we thought that the movements of the dogs could trigger some kind of eating in the dogs, because we all know that if there is an intense physical activity, the body will be hotter. However, we saw that dynamic behaviors in dogs during the examination, so where there is our peak in temperature, dropped because of freezing reaction to the vet palpation, to the vet manipulation. Other things that support the things that the high temperature peak was motivated by the stimulus was the fact that during the second experiment, the dogs had a peak in the tail wagging, and they stopped to pay attention to the environment while focusing on the owner, and specifically on the owner's end. The behavior of being focused on the owner's end was present only during the phase in which the palatable treats were available. That's quite obvious, I know, but it supports the claim of the thermographic data. The potential pitfalls of the thermographic data. So it is very, very dependent from the external ambient. During the, we can see that the separation protocol did not give us positive results. So there is not a difference between the baseline and the two central phases. Why? We have mainly two options. The first one that is supported even by another study published by a Japanese author whose name actually is missing, and that is the stimulus is not strong enough to elicit a thermal response. This is true even both for positive and for negative stimuli. The other problem that we have found is that we found a very, very high difference between temperature of dogs that we explored in summer and those who were exposed to the experiment in fall. So how in Italy it's quite hot like here during the summer. That summer was particularly hot. There were 24, 26, 37, 35, 37 degrees outside. And even if we allow dogs an acclimatation period inside our building, it was probably not enough. So this was quite a mess, and probably it had messed our data, and this is a potential pitfall. So it is important that infrared thermography is used in a controlled environment. The other potential pitfall is that the thermographic camera itself could be of some disturbance to the dogs. So the thermographic camera, for being effective, it has to be used about 1 meter away from the dog's muzzle. So this can be perceived as threatening or stressful for the dogs. The point is that the good news is that this kind of behavioral response was found by us only during the veterinary visit, not only during the other experiments, and other researchers have pointed out that they didn't find these reactions. So maybe the environment played a decisive role. So being in this novel vet clinic with this guy pointing this finger towards the muzzle was to some extent stressful. in a more familiar environment or during a positive situation, this doesn't happen. So maybe it was just the environment. So now, after our studies, others were published. I will show you some of them, just a few, because time is running out. I want to outline that I won't speak about the thermographic use in vet medicine, because we know that it is very commonly used for the detection of inflammatory conditions and orthopedic problems, but this is not the point. So the first one is this by Rimmer and colleagues. They proposed again a simplified version of the strange situation. This one was in 5 different phases. The important part of this experiment actually is the area of interest. They proposed to use the back of the ear, which is interesting because they actually found something, but there are some problems in using the back of the ears. The most obvious one is that it is not an available area of interest for all the dog's breeds, and the floppy ears are quite difficult to analyze in this way. They used a fixed infrared thermographic camera, so they didn't have the operator with the dog during the separation phase, which is very interesting. And the next one is the one by Lash and Dici. So during this, they assessed the pain for 17 dogs that were castrated, and they assessed the personality with a questionnaire. So what they found is that there were a drop in core temperature caused by pain, and the extravert subjects showed a greater eye temperature. So in the extravert subject, the drop in the temperature was lower. However, the behavior was different because they had higher pain score. So even if the drop was less intense, the perceived pain using the questionnaire was higher. So this is very useful because it indicates a potential use of personality in the assessment of pain, and it shows a practical use of infrared thermography. Finally, this one is a study performed in Australia. They analyzed the eye temperature of more than 500 racing greyhounds before and after the races. So their questions are still open because the racing rules are quite harsh for the data gathering. But what I would like to point out in this experiment is that now the areas of eye used for the analysis of the temperature are more than one. So the technology that are developing in the technologies are doing our work in a more effective way than 10-15 years ago. So the closing remarks about the thermography. So the negative event trigger a drop in physical event, and while the eye temperature was increasing, the positive event gave us a variation in eye temperature. Again, the temperature was higher during the event, while the separation protocol didn't give us any kind of variation. What can we conclude? Actually, that maybe thermographic camera seems to be able to assess the arousal, so if there is some kind of difference in temperature, the dog is aroused. But we cannot discriminate the valence of the emotional, because both in the positive and in the negative event, we had an increase in temperature, in eye temperature. So what are we asking to the AI now? So automated analysis and data gathering for the practical settings. We would like to, our dream is to having an automated target recognition because, for example, we had a discussion with monkey people that had monkey in a captive setting. It was hard using the thermographic camera in a long time study because the monkey will move inside the cage, so this will let the camera to lose the focus, so the data won't be continuous. We would like to see the AI recognition of stress and AI-based prediction of temperature from the behavior. So why so? Because they could be very useful for pain assessment, they could be pain welfare indicator, even and the stress and arousal indicator. So this may answer at least partially of the question of the previous speaker. So what are the symptoms that we need for the recognition of pain or stress assessment? The temperature, the eye temperature, the thermographic camera can give us some kind of hint about these signals. So this is the final aim of using the thermographic camera and the artificial intelligence. An automatic recognition and maybe in the future an automatic response to these problems. So the telemetry. Telemetry are subcutaneous chips. They are implanted into the chest. They are removed after the experiment. They measure a lot of physiological values: respiratory rate, pH, body temperature, muscular activity, and so on. Collected data are sent to a receiver, usually placed a few meters away from the animal. So, pros and cons. There is a reduction of animal use if you are speaking about animal use for research purposes. There is a reduction of distress because, okay, there is the surgery procedure, but once the surgery is done, the animal is not touched, is not disturbed during its daily routine, and the data are continuous, so they can be recorded for a long period of time, and for they can be recorded every day for more than 1 day. So this produces a very large amount of data, and this makes the analysis very complex, and this is where data scientists shine, because it will be very difficult without them. Telemetry is available for a wide range of species. It is currently used in a wide range of species, but apart from the surgery, the other negative side is that the cost is not neglectable. The new technologies are making it way cheaper, but the cost is still not so easy to face. So our study was involved 8 mixed breed males. Their age is estimated to be less than 5 years. They were living then in a rescue shelter since not less than 3 months, but no more than 2 years. So the data collection, we collected behavioral data, heart rate, core temperature, and muscular activity every day, every minute, for 4 weeks. So we had a week of baseline, so the normal living of these dogs. Then we proposed them 3 different environmental enrichments. So the more obvious one, toys and a cot for the sleeping. We paired them with a spayed female for a week, and finally an operator went to visit them 2 hours every day in their box. So this the experiment was performed a lot of years ago. So actually, this is not the normality in which dogs are kept in shelters in Italy now, but back in the ages that was a situation. Okay, the work is still in progress. So what was our aim? We would like to assess if the 4 weeks were similar in terms of behavior and physiological parameters, in order to assess what environmental enrichment could be effectively used to enhance dogs' welfare. What we thought is that not all enrichment could be accepted in the same way by all the dogs, and if there is some kind of correlation between physiological parameters and behavioral ones. We developed 3 metrics for the analysis of physiological data. So the predictability, so how similar the dog's days are to an average day calculated using the date of the baseline data. A cyclicity meters, so the average difference between the day activity and the night activity. Again, we are speaking only about physiological data now. And on a sleep quality metrics, so the number of times dogs awake from sleep during the night and how long does they sleep during a night period. So we coded manually 3 dogs. These are not behavioral data for the whole month because it would be impossible to manually code a whole month of an animal life. We randomly chose different fragments during the week in order to create an artificial day from midnight to midnight. What we see now is that there are inter-individual differences in the behavior of these dogs, and that some of them reacted differently to the different stimuli. For example, there is an increment in the sleep time of a dog when the female is present. So this dog slept more with the female living in its own box. The physiological data, what we have seen is that the stimuli are lowering, stimuli values are lower than the baseline, human and female are lower than the toy, speaking about predictability. So all stimuli enhance unpredictability of the physiological patterns during the days. Specifically, human and female stimuli are not different, and they are more effective than toys in creating this variation in the day activity. The cyclicity, both female and human have higher values than the baseline, so human and female enhance the difference between the night activity and the day activity. And finally, the sleep quality meter, maybe, okay. Just the female seems to improve what is the quality of the sleep in dogs during the night. In some extent, we can say that this improves sleep quality. It is debatable if this is a welfare indicator and how to use this indicator. But the fact is that the presence of the female enhances the sleep time of dogs. So the final remarks, as we have seen, inter-individual differences seem strong. Environmental enrichments affect dogs' behavior and dogs' physiological data. And speaking about physiological data, the human presence 2 hours a day and the female seems to impact the data more than just toys and a better bed. Again, what we expect from the artificial intelligence is a AI-based, maybe in real-time analysis of physiological parameters, and this can be used as diagnostic tool, and it can be used for husbandry or shelter. The final aim is the automatic recognition, and again, maybe the automatic response to these kind of problems that we can find in sheltered dogs. And that's all.
Questions?
The
Okay, so the question was the variability of the dogs used in the telemetry experiment. So are you speaking about the sample? So what are the differences between the sample, right? So here, right? Okay, so yeah, they were all males, they were all mixed breeds, they were all adults, but we don't have a precise indication of their age because they are stray dogs that were taken into the shelters. The unique precise data that we have is the moment in which they entered the shelter, and we decided to use dogs that were living for a long time inside the shelter.
Any more questions? Okay, then thank you again. Okay, our last speaker is, oh, please be careful, the long-awaited Stefan Goer.
Okay, so good afternoon everybody, and thank you Anna for this nice invitation. So I'm a veterinarian, I'm a clinician, and my field of expertise is mental health, so I cross the river that my previous colleague has some difficulties to cross. And even I will go further and I will talk about psychiatry, veterinary psychiatry, and I brought you a brief history because you will see that the first time that animal psychiatry appeared in the scientific literature was like 100 years ago. In France by Fernand Méry in a scientific review. Then in the 60s, a book named Animal Psychiatry was published. And in this book, there was a very, very important and straightforward sentence. Once we agree on the existence of an animal psychology, we must also admit the existence of an animal psychopathology. Meaning that if, and I think that everybody here agree that an animal can feel emotion, can be sad, can be happy, and is driven by motivation, and he has also cognition, and he has also mood, all these systems are brain systems that can dysfunction. And when they dysfunction, then there is a pathology. And then in the 90s, there are 3 main books and reference books that were written in France by Patrick Pajat, in Canada with Gary Landsberg, and United States in Karen Overall. And they talk about behavioral medicine, and they were, and they are still, really important books. And in the 2000, finally, the scientific community and the academic system veterinarian decided to create a specialization in behavioral medicine, and there is now 2 international specializations, one in Europe with the European College of Animal Welfare and Behavioral Medicine, and one in the States with the American College of Veterinary Behavioral Medicine. And for the last 3 years, a little change is coming with books with psychiatry, veterinary psychiatry written on them, and they are written by specialists. Sergei Dannenberg is a veterinarian specialist, American and European. 2 months ago, a new book from an Australian specialist was published on psychiatry of cats. And I have the great honor and pleasure to write a book in French with other specialists, Dr. Sylvia Masson, Gérard Muller, and others. And I have also the pleasure to tell you that this book is now translated in English and will be published next year by Springer Nature. So my goal today is to try to make a link between AI and the clinician that I am. And first, I have to more explain what is normal and what is pathological, finally. So when you talk about a normal dog, we talk about homeostasis, meaning that according to the time, the dog is always coping with his environment. There is some changes in the environment, but they are mild, and the dog has all the capacity to cope all the time with these little changes. Like he's hungry, there is food, but he has to go in another room. Or he's thirsty, there is water. He's tired, there is a place to rest. Okay? But sometimes, from this situation, suddenly there is an intense stress. And the dog is entering what we call an allostatic load, or reactional state. For example, this dog on the right of the screen is exposed for the first time with the new vacuum cleaner of the family. And this new object is very noisy, is very strange, and so the first reaction of this dog is fear. Okay. But with the time, because it is in a big apartment and the dog can explore this object from a distance, and finally he gets used to it, he gets used to the noise of the object, and he will be used to it, and finally we call that habituation. He will spontaneously return to a normal adaptative state. So this is like a sort of arousal, a sort of reactional state that will spontaneously, because of the skill of the dog and because of the environment, the dog will be able to come back to normal. But sometimes it's not the case, and from this allostatic load we go to an allostatic overload, meaning that it is too much. The dog can't cope anymore. And if I take the same example, so this time it is in a very small apartment, the vacuum cleaner is very, very noisy, the dog has no strategy to have a distance from it, and finally he gets sensitized to it. And there is a sensibilization and conditional emotional response, and even it can go to what we call generalization, anticipation, and he will finally develop fear from noises that are not linked immediately to this vacuum cleaner, like other noises of the apartment and perhaps to the apartment itself, and don't want to go back after walking outside. So we have now a phobic dog. He is now in a pathological state. This is pathology. The dog can't cope anymore. And to be able to return to a normal situation, to homeostasis, you see how hard work he has to do, desensitization, counter-conditioning, extinction, and all this behavioral modification will be, how can I say, efficient only if before we can balance
the dysfunction brain of this dog, because as you know, the more fearful you are, the less you learn. So how do you want that this phobic dog can go across all this protocol of behavioral modification without getting a medication, a drug treatment that first will balance the function of his brain, and the dog will be able then to go inside the protocol of behavioral modification and get back to a normal state. And more than that, the environment is not the only factor of pathological state or even reactional state, but also genetic vulnerability. Not all dogs are the same. And you can have a dog with a strong vulnerability on the right edge of the figure, and you see that even a mild stress will trigger a reactional state or even a pathological state. And on the opposite of the graph, on the left side, with very weak vulnerabilities, even if the stress is very, very strong, the dog will stay in a normal adaptive state, and we say this dog is very resilient. Okay, so now we have normal, we have reactional, and we have pathological state. And how I can present you the pathology, the different I would say pathological disorder, of dogs. You can organize them. You can make a categorization according axis, and you will see how it's convenient to understand and to measure, and then we'll go with the link with the AI. So the first one is the axis of fears. Okay, fears, basic emotion, and the more the dog will be in the green zone, the more the dog is in a normal adaptive state. And the more we go to the age, the more we have pathological state, and the more we have very strong symptoms like aggression. Example, so this is a puppy, 4 or 5 months, and in 4 or 5 months of a puppy, I will not expect this sort of behavior. You see how he's restless, you see how he's worried, you see how he retreats, you see how he stands. We talk a lot about facial recognition. I'm sure that our researcher here have a lot to say about this dog. Another example, another fear, but this dog is freezing. It's a social fear, and you will see how he's avoiding the eye contact. You will see also his legs. He has a compulsive licking, and this is why you have a color of his legs of orange color. He's not doing anything with the toy, with the interaction that I try to get with him. So on this sort of patient, we can already imagine all the tools of AI we can put on him to measure a lot of things. Another one, a social fear again. There is no sound, but he's barking by the time I'm trying to have an interaction with him. So he threatened me because he wants to push me away. And as you see, there is also a tail wagging, but this tail wagging is more an appeasement behavior, and at the same time, he's taking contact with his owner. There is lots of information here. The second axis is axis of self-control. What does it mean? We are talking about inhibition here. How far a dog can not react to a stimuli. How far a dog can not react to a not relevant stimuli, and when he's reacting, how far his reaction is adapted to the context. Okay. The first dog here, look at him, is able to interact with this ball. I didn't say play for purpose, for hours. This dog is suffering. It is an addictive behavior, and if you look at him, and perhaps we can have also AI to measure it, for me, this dog has no pleasure at all. He is like an automat. Okay? And now you can't, if you don't stop it, he will not. Again, there is no sound, but the owner now says stop. When he says stop, he stops, but look at the craving. Okay? And when you have something, a compulsive behavior, you can't stop, and you have craving, this is addictive behavior, like when you take drugs. Another one, which is an ADHD dog with compulsive behavior, which is scratching the wall all the time. So you can imagine he scratched the wall for 1 hour in my consultation room, what he did to the house of his owner. Another one, ADHD dog also. So again, problem of inhibition. And you will see at the beginning, first of all, he's panting without reason. This is a conditioned room. It's not hot inside. He didn't have any physical exercise before. So he's very high level of arousal. And you see the exploration is sort of boisterous. And look at that, it's coming, that. He's even reacting to the movement of his own tail. Okay, so he can't not react to the movement of his own tail. This dog is suffering. This dog has a mental health problem. The social insertion is not a good translation. Social integration, sorry for the mistake. Again, the more you are close to the green zone, the more you are a normal dog. And, sorry, before, social integration, what does it mean? I'm talking about hierarchy here. Hierarchy, sorry. Meaning that how far a dog can cope with the rule of his group. Everybody knows here that, perhaps not, that dog is a social species. And when you are a social species, there is always a hierarchy. There is always social rules, because you are a social species. And the capacity of a dog to recognize the social rules and to cope with the social rules, or to cope with the absence of social rules, is the problem of social integration. And so, sorry again. With this dog, it doesn't want to come. Okay, perhaps now? Yes. So this dog is on the bed of his owner, and with his toy. And again, there is no sound, but you see the threatening. So here the dog is sending a very clear message. Now, and in this context, my rules are, this is my toy, this is my bed. Okay? Why? I don't know. Perhaps because he's obsessed about it. Perhaps because there is no rule and he needs rules. I don't know. But this behavior is not a normal behavior. Attachment. Attachment is based of the social, the dog owner bond, okay? And in the attachment, if the attachment is balanced, everything can be okay, but when you go to the age, you see that for the other axis, it's always aggression that are the main difficult symptoms, and in attachment, it's panic attacks. Panic attacks that can go even to the dog to hurt himself. Like I have lots of patients that have jumped from the windows, from the, how do you say, the third floor, for example. And look, there is 2 dogs at the beginning. Okay, only one is suffering from a problem of attachment. And you will see now his reaction after the owner left the room. He's immediately tense, he's immediately hyper-vigilant. And now he is going to try to cope, meaning that he wants to find solution to be reunited with his owner. And he's looking to the windows, which is obviously an exit, and it doesn't work. And then, again, he's winning now. There is no sound, but he's winning. And now the door. And he will then be restless. And again, the anxiety can grow. And you can't see the other dog, because the other dog is perfectly calm, that you saw at the beginning, that you really see for several seconds, and he's coping with the situation without problem. This one is not coping with the situation at all. Okay, so we have this axis, and finally, when you think about it, you can draw the dog according to the axis. Is this dog is in all the axes in the green zone, or one is green in fear, orange in self-control, red in attachment? And even so you have axes, so you can imagine numbers. We didn't do that for the moment. But here AI can really can be of great help, finally. So if I want to insert AI in my consultation or for the assessment of my patient, I wanted to explain you what is a veterinary psychiatry consultation. It's limited in space. It's a room consultation. Perhaps we can go for a walk around the clinic, okay, but it's limited. Then it's limited in time. It's 1 hour, perhaps 2, but most of the time, no more. It's according to a systematic semiology that I'm checking all the axes, but it's not enough. I'm checking the communication. I'm checking, for example, food intake, sleep. We'll speak about sleep because this is a very big challenge, how assess sleep, for example. And it's based also on the veterinarian observation, passive, like just observe the dog. And you can be very precise in your observation, or you can be active. You can trigger behavior by street or toys or noise. It's based on owner's interview, because the dog will not show me all the behavior that I need to make a diagnosis. And finally, I have to answer several questions. First, where are we? Normal adaptative, reactional, or pathological? Why is it so important? Because if I conclude that it's pathological, it means that I have here a brain that is suffering or in dysfunction, and I have to give medication to balance and then to begin the behavioral therapy, behavioral modification, environment modification, obviously. Then I have also to make a differential diagnosis in behavior and in not behavior field, meaning that it can be like this dog wants to escape. Okay, but is it fear? Is it a lack of self-control? Is it a problem, another problem? Is it in pain? Pain is a very, very important subject for us, because we know the link in the brain that exists between pain and emotion. Another example, skin problem. We know that there is a big
I will say, discussion between the skin problem and the behavior, because skin problem can trigger anxiety, and compulsive behavior or anxiety can trigger skin problem. So we have a list, and finally we take the main hypothesis and we go to the medical treatment if needed and therapy afterward. So I worked with Anna. Anna was like a magic fairy that came to my consultation room like lots of years ago. And we did nice research, and we show that when you put an anxious dog confronted to a dog robot, and you will check the interaction, the anxious dog will move less than the control group. Okay? It was what we expected, but it was nice to prove it. The second thing, second research was about ADHD dog, and we show that the movement patterns of ADHD dogs are not the same that control dog. I found also in the literature that, sorry, there is lots of things, but one was on how now AI or Wearable were able to recognize behavior types in dogs, like standing, sitting, etc. And there is one that is still in review as far as I saw, that is very interesting, where AI is assessing a directed behavior in dogs. So, as Tal told you, I'm a clinician. Guys, I'm expecting a lot from you. And I need a medical tool, like my colleague in internal medicine. They took blood, they have numbers, and they know, okay, the inflammation, anemia, etc. So it has to be adequate, it has to be accurate, reliable, rapid, and I have some needs. The first one is sleep. If you can find me a way to measure sleep in this quality and quantity, and our percentage of REM sleep there are. Because this is the most difficult thing to measure. If you ask the owner how many hours your dog sleep, he will say 10 hours. But you will not know if it is sleep or resting, what is the level of arousal. Second is assessing the discomfort during a behavioral therapy. If there is trainers here, they know how it's difficult to do desensitization or counter-conditioning, because the main challenge is not to sensitize to the dog more. Like all these behavioral modifications are based on the exposure to the object of fear, but on a small level. And all the time you have to check the dog. And if the dog is too much fearful, you are not going in a desensitization protocol, but on a sensitization protocol. So if I have a collar, if I have a camera, if I have something that say beep, 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 stop, this is sensitization, stop, it will be very nice. Another one can be how we can assess more our diagnosis during a psychiatric consultation. Okay, we diagnose an anxious dog. Okay, it's an anxious pathological state, but if we'll be able to say 5 out of 10, and at the beginning perhaps it will be 8 out of 10, and then we give a medication, we give a protocol of behavioral modification, and after a month the machine say it's 5 out of 10. It will be very, very nice. And the last one is a tool for early detection for pets owner, like an application on their phone. There is already lots of things with image and videos to measure pain or to measure behavior, and we can add even some questionnaire, a short questionnaire, and just to know how far the dog is away from the normal situation. And then to say, beware, you need help. Don't stay like that. And this will be very nice to prevent those dogs to suffering. So I'm looking forward to the future, and I'm happy to answer your question if you have.
Thank you. You have a lot of requests from us.
Yeah. And if you have requests from me, I will be very, very happy. I have the feeling that researchers put away all the pathology, the mental health. And so sometimes, for example, when you talk about your experience and the strange experience, okay, the strange situation. The strange situation, I was surprised by your results with the thermography, because the anxiety, the biggest anxiety is most of the time in this situation, what we call separation anxiety. And I was surprised that you didn't find something. And so I was thinking, but he has always normal dogs. And this is it. And because now there is papers that were published about the strange situation with normal and pathological dog, and even we found that insecure and secure attachment in dogs, the percentage in the population is very close to the percentage of humans population, which is very amazing and interesting. Yeah, there is a question over there. Okay, so yes, what is the difference between anxiety problem and separation problem? Okay, so it's a very good question, because when we work as a veterinary psychiatrist and we make a diagnosis, we make two levels of diagnosis. The first is the pathological state. And pathological state is which brain circuit is dysfunctioning, okay? And if I say anxiety, so I know that this is what we call the cortical, striatal, etc. loop. Okay, so, and I know that if I want to change that, I have to work on noradrenaline, dopamine, whatever. Okay. And then you have what we call the disorder, the illness, okay? And you can find anxiety in problem of autonomy, which we call separation anxiety. But this dog that is treating his owner, it also can be anxiety, okay? And this dog that has a compulsive behavior, perhaps is also anxious, because not to be able to stop is very anxiogenic, okay? So my point is, in one disorder, you can have several pathological states. I can have an anxious dog, but this dog is also depressive, and this dog is also impulsive. It can be, okay? So the pathological state take you to the brain, which circuit doesn't work as it should, where does it dysfunctioning, and it takes you to the medical treatment. The disorder takes you to how it is expressed, and finally, where does it come from, the etiology, how it will be evolved, and what is the behavioral treatment. So it is a very nice organization, and you can't be lost. If I take from exercise, I didn't. Okay, so the axes are disorders. Okay, so we use the word nosographic disorder, meaning that it's a classification of the disorder. But again, when you see fear, you remember, you are in fear, you can be phobic, but you can be anxious. What is the difference? Phobic is when you react to a very precise stimuli. There is always a stimulus that you can point out. Okay? When you are anxious, you are reacting to all the change of the environment. Okay? External or even internal environment. Okay? So you can't finally say, okay, this dog is fearful, but I don't know why. This is anxiety. Okay, so and if I stay in the same axis, you can be impulsive. Take this dog with a separation anxiety. So he's anxious, okay, because okay, he's alone, but this is a change of an environment. It is not something that is fearful. There is no phobic situation, and he's also perhaps compulsive, like he's scratching the door for hours, and even it is painful, but he will go on. There is no stop signal anymore in his brain. You know, it is clearer? Okay, thank you.
Thank you. Any more questions? Yes?
I have a short question. So you mentioned that one of your requests is tools for the clinician, and the other request is tools for the owner. Which do you think is more important?
Does he have to choose?
Yes, thank you, Anna. Thank you, Anna. I think the both are important, but the both are not on the same level, because what the owner can measure, we have to help him. Like it has to be very simple questions or very directed question in the precision of the context and everything, and perhaps also something with the AI that will help without any intervention of the owner. In my consultation room, then I have another eye, and I can say, okay, you know, I don't need AI to tell me if it's anxious, phobic, impulsive. I know it. Okay, I don't need you. But I need you to precise it. Give me a number. Like, I take a dog, okay? I check, you know, his eye is very blank. There is anemia, okay? He has a loss of blood cell, of red blood cell, okay? But there is difference between 1 million and 3 million, and I will not see it in his eyes. It is the same. Like, I want to stress that psychiatry is like all field in it's a medical field, and we are so much craving for tools with number. And we can do without, we do without for a long time, and it's okay, but we can be so more precise, and it will be also, you know, for me it will be like a release to say, okay, they come with the dog, and you know, they say, oh no, there's no much change. I say, shit. Okay, I give the medication, back. You do everything, yes. Okay, then I see the dog and say, it's not so anxious for me. It seems that there is something that's happening. And you know, I just described the dog in my computer. I didn't take a video or anything. If I have a tool that say it was 8, now it's 5. So it's very satisfying. And it's very like, okay, you see it's 5, there is improvement, this is a good treatment. Go on, perhaps a problem of dosage, I don't know, but it will really help.
Also with the interaction with the owner.
Sure.
Okay.
But for me, like to sleep better at night, even.
Thank you.
Yes, for sure. This is a big part for the behavioral therapy, all the behavioral modification, and I talked about desensitization, conditioning. Now I give it always to a good trainer because owners made so much mistakes that not by purpose, okay, but they, as you said in your presentation, that when you began to make this evaluation of the face, you train yourself to be more aware of the blinking, of small licking, everything. They don't pay attention to that. And it is already sign of discomfort, and it's already a sign that stop, you have to stop. There is sensitization here. And my colleague Sylvia Masson used to say, just check the face of your dog all the time. He's talking to you all the time, but you don't pay attention because it's a problem of training. So if I have a good trainer, for me, the trainer is the master of the communication. He knows everything in communication between dogs and humans, and it is a translator. Okay.
Okay, thank you so much. So
Thank you.
Thank you. So we'll take our last break of about 20 minutes, and then we continue to our last session. So we will be back in 20 minutes. the chief veterinary scientist at PetPace, which is the best collar available today.
That's right, lecture is over.
Yes.
Thank you. So I would like to start. Can you hear me okay? I need to talk here, right? Okay. I'd like to start with a story of a cat named Oscar that appeared in the New England Journal of Medicine. This cat lived in a nursing home in a dementia, final dementia department, and he had the unique capability of predicting which patient, which resident is going to die. He would go up to a patient's bed, curl by their side, and that was a sure signal for the staff to call the family and say their goodbye. And no, not because the cat was killing the patients, because it was predicting that in their final hours. Nobody knows how it did it, but it was a very high accuracy. As the quote from the doctor in the journal, "No one dies on the 3rd floor unless Oscar pays them a visit and stay a while." In a similar note, but completely different methodology, people from Stanford University tried to do the same thing, tried to look to create an algorithm, a machine learning algorithm, to predict which patients in a hospital are going to live beyond 1 year. And the way they did it, they took 200,000 medical records. So they're not talking to physicians, they're not talking to patients, they're just looking at medical records and trying to predict those patients are going to survive beyond 1 year or not. And they did it with significantly more accuracy than any physician would have. And what's interesting is that the parameters they looked at, what's available in the medical records, was not the same parameters that a physician would look at when they look for symptoms, the way they're trained to assess a condition and gauge symptoms, but rather technical things like how many MRIs did they do, or how many prescription drugs they received. So the point I'm trying to make with these two examples is that, one, huge amounts of data at our disposal can predict many things that we could not do before. And the second point is that the things that we use to make those predictions are not the standard or the traditional symptoms that we are using. Computers find a way to look for signs that we as physicians were never trained to look for. So it's a brand new world. So the world I'm going to talk about, just for terminology, is called mobile health. It's how we use mobile devices to in the health and medical fields. Specifically, we are, my company, PetPace, is in the wearable technology world. Where is this message? Okay. And I'm going to go through these slides briefly, unless you have any questions. I understand that this crowd is a little more technological than what I thought, so I'll go through those quickly. The technological basis for this revolution of mobile health is, first of all, the ability to create very, very small but very accurate sensors. Together with IoT, Internet of Things, universal connectivity, we can connect anything now and collect data, which leads to big data. This is actually an old slide. This is from 2016. Back then, 90% of the world's data was created in the last 2 years. We are eight years from then, so it's probably around 6 months. So the amount of data in the world is doubling roughly every 6 months. So it's huge amounts of data, and what entails is that standard statistical tools just don't apply. You cannot use normal statistical or traditional statistics in such voluminous data. So this leads to AI, artificial intelligence. The beauty or the strength of AI is the ability to digest huge amounts of data. But the limitation is that we don't always know or understand what it is doing. The machine
is learning something, we don't know what it is learning. It is making decisions, but we don't always know the rationale behind these decisions. Nevertheless, the results are tremendous, so we can still go for it. And the final component is cloud computing. The ability to store a huge amount of data and access it in real time from anywhere, anytime. These 5 components are behind the revolution of mobile health. Why do we need them in veterinary medicine? I think my colleague here already made a very good point of why we need it. Simply because pets don't tell us how they feel. In fact, they do their best to hide symptoms. A study, a very large survey by Zoetis, looking at thousands of medical records of pets who their owners are convinced that they're healthy. In fact, a third of them had significant medical issues that required treatment. The owners were just not aware of it. Not because they don't care, because pets do their best to hide their symptoms. And the second reason is that once they already have a condition, it's very difficult to treat them because you don't know how they respond in their natural environment. As a veterinarian, you only see them when they come in the veterinary hospital. They behave completely different in the hospital as opposed to at a home setting. And the pet owners are not always there to watch, and even if they were, there's a lot of bias and a lot of objective difficulties to assess the pet's condition and response to treatment. So we would like to monitor pets to detect diseases, and then once they have a condition, we want to see how they respond. So with this in mind, we created PetPace. It's a startup company, an Israeli company, that developed a smart collar that collects a range of physiological and behavioral attributes. The basic signals that we collect are temperature, pulse, respiration, activity, posture, calories, HRV, heart rate variability, which is an indicator of pain and stress and many other things, and GPS, so location data. Our first version was launched in 2015. We are now, actually these days, launching our next V2 version, which has a lot of improvements compared to the first one. And I'll go in a little bit about how we do certain things. First, we talked about big data. So this is the big data that we produce at PetPace. On average, an estimated amount of data for an average dog that lives to be 13 or 14 years old will collect close to 20 million data points in our system. We already have thousands of pets using our collars. So we have over 1 billion data points already. And to be honest, we're only scratching the surface of what we can conclude from this data. There's work for 100 years to come. One of the things that we are focusing now in the company is to apply AI to this data in order to develop what we call health programs. So we're looking at specific conditions and we try to help, and the goals are depending on, for each condition it could be different. It could be early detection of a disease, it could be classification, whether this is a condition A or condition B, help with managing a condition, like detecting response to treatment and adverse effect, etc., relapse. So for each different condition, we want to define a goal. In very generic terms, the process of developing a program like that involves first, as I said, defining the goal. Then we go into a data collection phase. So we collect, we recruit hundreds, even thousands of dogs. Some of it we do ourselves, some with collaboration with universities all over the world, some with pharma companies. We collect data on specific medical conditions, and then the next step is to develop the data features. So trying to understand out of this data, what are the statistical features that help us predict
the goals we want to achieve. So just like the people from Stanford who found that the number of MRI was an important feature, this is the work that we do in phase number 3. It's not necessarily what I, as a veterinarian, can say, you know, look for this symptom or that symptom. It's statistical factors that are relevant. Then we develop an algorithm. We have data scientists. It's magic to me what they do. I mean, they explain it to me, but it's still a very much of an art. AI, I'm not sure how much experience you have with an eye. It's not a machine that you push data from one side and you get results from the other. There's a lot of art and know-how that go into it. And once the model is done, it goes to the production team to create a feature on the app, and it goes to market. So some things that we already completed and some that are still in the pipeline. So one thing we completed is the Daily Wellness Index. This is a daily assessment of the pet's overall health. It's a score from 0 to 100, telling you how healthy your dog is in very general terms. We use data of over 2,000 pets, medical records, and biometric data. We identified patterns of sick dogs compared to healthy dogs, and we used a model called XGBoost. I'm going to explain in the next slide how it works. And we achieved an accuracy of 80% in predicting on a daily basis the pet's overall condition. So what is XGBoost? It's an AI model that is based on decision trees. Decision tree is the way the system looks at thousands of data points and decide that a certain data point is important, and it starts from there. So in this tree example, so this is the tree, and if we zoom into the top of it, we see that the first question the model is going to ask is, what is the median activity level of this pet? Is it less than 1.525? Why did it choose this factor? Why choose this value? This is what machine learning does. So then the answer, it's either true or false. Either it's above or below it. And then if it's true, you go to the right. And then the next question is this an intact female? If yes, if so, you go this way. If not, you go that way. And then the next question is this age category is above 9 years old. And then is the mean pulse less than 62.445, et cetera, et cetera. At the end of this tree, a decision tree, all these questions, there's a conclusion. This dog is healthy or not. Now imagine that in not just one tree like that, but 1,000 trees like that are running on the data every second and determining whether the pet is healthy or not. And then the cumulative answers of all these trees give you the final prediction. And this is very robust. As I said, we achieved 80% accuracy. We will improve it. We are working, we already know how to improve it, so it will get better. But we believe that 80%, if given on a daily basis, is good enough, because even if we missed it on the first day, we missed it on the second day because it falls on the 20%, very quickly, just statistically, we will hit and we'll give the right prediction very quickly. Another feature we developed, we call it the personal health profile. So we use machine learning to learn the normal values, the normal range for each individual pet. So just like when you look at blood tests, if you ever had your blood taken and you receive the score board with all the different parameters and what's the normal range and whether your result is above or below the normal range, this is the same thing, only it is based not on a generic normal range of the population, it's on the normal range of this specific pet. So it takes us several weeks to learn what is the normal range. We create the normal range for each pet, and as long as its values fall within that calculated range, it is green, it's fine. As soon as it deviates above or below, we can alert you. This is a very, very powerful tool to detect changes from routine. 1/2 of a standard deviation will be detected within 5 days. So very minor changes in a pet's condition, its behavior, its physiology will be detected very, very quickly. It's a very, very sensitive tool. We know how to detect pain in animals. We did based on a study. The initial study was done by North Carolina State University. It was published last year. We completed it with Colorado State and also the Hebrew University, the veterinary school in Israel, and several commercial companies. Overall, we looked at more than 200 dogs. We identified more than 20 attributes that distinguish healthy from dogs with joint disease, which causes chronic pain. And again, we use a model called XGBoost with certain enhancement, GBTD. And overall, the accuracy of detecting pain is 85%. This is really revolutionary because for the first time, there's an objective device you can put on an animal, and it's more accurate than the method we are using today in veterinary medicine, which is owner's questionnaires. One more tool I wanted to show you. This is something that is not part of the application, but we provided to researchers that we work with. This is an analytic tool that we can customize to the researcher's need, and we call it the Affective events. Essentially, it allows you to see data before and after an intervention. So it could be giving treatment or doing any manipulation or whatever, and then the system very quickly and with a click of a button will show you the data before and after. So you can see the effect of what you did. Did it change the pulse? Did it change the activity level? Did it change behavior patterns? And you can play with it. You can put any numbers of dogs in there, and you can play with the dates and amounts and all kinds of filters. And with a click of a button, you can see if what you're doing taking the effect you expect or not. So all of these are already up and running and working in our system. We are working on additional interesting stuff. One of the top programs on our list is epilepsy. We want to be able to detect seizure events. This is a common and devastating disease, and there's a very big gap there. Veterinarians need to know if the medication that they're giving is working or not. And the number one question they want to know is, do you still have seizures or not? People don't know the answer to it because we're not with our pets all the time. Sometimes seizures happen in the middle of the night, so we don't see it. And our system will be able to detect it. These are just examples of how we can see it in the data. We can see a sudden and unexplained increase of pulse, burst of activities, changing in posture patterns, very typical pattern of temperature changes. So we can see these events. The challenge now is to teach the system to detect it automatically and to be able to distinguish that from chasing a squirrel or having a vivid dream. So it is a challenge, but we are on the way to achieve it. Another program that's going to come at the end of this year, hopefully, is the ability to predict when dogs are going to go into labor. Anyone who had a dog that's pregnant, whether it's a private or professional breeders, know that understanding or knowing when it's going to happen is crucial because you need to prepare for it. You want to have your veterinarian at hand. You want to take the day off the next day. You want to be prepared for whatever is going on. Our system can predict it. We see multiple changes. We see changes in pulse, in HRV, in posture, in activity data. It's actually not a very difficult thing. Pregnancy is a very dramatic event, and the vital signs and all the parameters just go crazy. So it's not a very challenging thing, to be honest, to predict it. We are working with working dogs all over the world, the US, Israel, Europe, Australia. It is a very interesting subset. These are different dogs. They're not pet dogs. They behave differently. Their physiologies, actually, they're adapt to stress and temperature differently from pet dogs. So it's very interesting to work, but
this is where a lot of value can come in, because these are very valuable animals. A lot of money and effort are put into raising them and training them, and they would work until they drop. So it's important for us to keep an eye on them and prevent them from getting hurt. So we can see a lot of things about them, and forces that the military or police forces that we are working with already changing the way they handle them based on the data. So for example, we can see that dogs, when they go home with their handlers to sleep at home, are much more relaxed. They sleep better than dogs that are staying in a kennel. So this is a dog that's on a day off. It's not working. Oh, sorry. But you can see the difference between being at home or being at the kennel. The kennel, every time some dog sniffs something and starts barking, and everybody wakes up and starts barking. At home, at least they get some rest. Even when they are at work, you can see the difference in the pulse level, among many others, between being on the line. So these are dogs from the checkpoint on the US-Mexico border. So they usually go to work for like 45 minutes, and then they rest, they work, they rest. So you can really see the difference between the time they're on the line and in the crate resting. So based on that, they're already changing the way they handle them. For example, the dogs in the Israeli police who are being trained to attack, you know, these exercises when somebody comes with a big sleeve and the dogs needs to attach. They do this training and they put him back in the police car. Based on our study, based on our data, they found out that it takes them a long time to recover their HRV. It takes them 30 minutes to recover their HRV to normal levels. So if they put them in the car right after the exercise, they're still aroused and stimulated. They're going to correlate being in the car with an aroused state. So they don't want that. So now they change the protocol. They let them cool down for 30 minutes, and only then they would put them in the car. There are a lot of studies going on all over the world. Some are being already published. This is a study from the University of Maryland. They looked at adopting dogs and matching them with people with veterans with PTSD. And they used activity and approximation data to find the best match. On the right, this is a study just came out last month from the Hebrew University of Jerusalem. They used CBD, cannabis oil, to treat pain in dogs, and they used our collars to assess the effect. And these are just two out of many studies that are going around out there. And each study like that, we also use the data to develop our programs. The other front that we are going to work on in the future is to expand to other species. The collars are already being used on obvious things like cows and horses, but also on zoo animals and even bears. And this is a partial list. So the technology is there. It's just a matter of effort and time and priorities. And that's it.
Thank you.
Yep.
Thank you, Asaf. There have been some really excited remarks on the YouTube channel from people watching us remotely.
Oh, okay.
Yeah.
All right.
We have about 50 participants
Great.
remotely, and they are really excited.
Excellent.
Is there any specific question or just a big wow?
Both, but also questions, but I don't know, maybe
Yeah,
people here first.
sure.
Yeah.
I just wanted to ask you whether these last words about the working dog were published, or
This one?
the one about the sleeping quality and the decreasing of arousal after work.
No, it's an internal study done by the Israeli police department together with the Hebrew University. I don't know if or when it will be published.
Because they're very interesting.
Yeah. Yeah, we just provide the technology. I don't have any control on writing or publishing.
I have a curiosity. Sometimes I work with wildlife, so I would like to know how much lasts the battery, and if there is a way to remotely collect data from the collar.
Yeah.
Could you please repeat the question for the remote participants?
Yeah, so the question is how long the battery lasts, and is there a way to remotely access the data? So,
far remotely, so hundreds of kilometers.
yeah, so the collar can connect in one of three ways. If there's Wi-Fi, it will connect through Wi-Fi. If there's Bluetooth, so you're walking with the dog and you carry your cell phone with you, you can connect through Bluetooth to the cell phone, and from there it goes to the cloud. And if neither is available, so the dog is just somewhere, it's going to connect through cellular. It has a SIM card inside, so it has cellular connectivity. So in real time, you have full access to the data anytime, anywhere. Regarding battery life, this depends on the form of using. So the more you rely on cellular, and the more you will activate your GPS, the faster the battery would run. Under normal circumstances, so a pet dog that most of the time is at home, maybe goes on a walk a couple of times a day, the collar, the battery would need to charge between 30 to 40 days. So about 5 weeks. If you go in what we call emergency mode, your dog ran away, and you're just now putting the GPS up to update like every second, continuously, and we shut down everything else just to find your dog. In this mode, it will last about 2 days. So it really depends on how you use it.
I was speaking at a long time period wildlife study, so putting the collar on a jackal, on a wolf, and then recover the collar after some months. So that's the point of the question, but you answered my curiosity.
Okay. If the collar is not in range of any, so there's no cellular data, right? You're in the middle of, I don't know, the Arctic, whatever. The collar still has an internal memory, and it would hold about 1 week of data.
Okay. Nice. Thank you.
You're welcome. Yes, please.
What is the market price of the end user of one collar?
One collar for pet owners is between $600 to $800 a year, depending on the features you want. For veterinarians, it's $700 a year. Yeah, the $800 is for 3 years for pet owners.
Are you collecting data from other the world?
From what? I'm sorry?
Are you collecting data in your company from the install base, from all your collars in the world?
All the users.
Yeah. We actually have, I mean, obviously we have access to all the data. If you are a veterinarian and you have patients wearing the collar, you could also have access to all of them. Yes, please.
Russian colleagues buy database for Jane Fox's study?
Hopefully very soon. As I said, these days we are launching this next generation collar in the US. Europe or the EU are going to come next. I'm not sure what the legal situation in Russia is. It's not part of the EU, but I mean, if there's EU and FCC regulations or certification, is it okay? I'm not sure, but it's a matter of time, probably a few months.
What about foxes?
We have people using it in wolves. I assume, we haven't validated it for foxes, but they're not that different from dogs, so it's probably going to be fine.
Okay.
Great. So yeah, the question from the comments. So Sophia asks, how did you come up with this app, first of all? And what she asks is, how long was it from like the first idea to the first app version, and how many people were involved in the beginning? And she adds that so many patients, dogs presumably, with behavioral problems actually have subclinical epilepsy. That would be amazing to detect it, and that would be great to decide for the hormonal supplementation after neutering the patients.
So the first, I think, draft we had for this technology was in 2011. It started in my kitchen with my golden retriever who had to wear all kinds of devices on her. the idea was very simple. Any veterinarian, and there's some veterinarians in the room, know how frustrating it is to have a patient come in for an exam and the owner swear that it was fine until yesterday, just today it stopped eating. And you check them and there's cancer all over, or the kidneys are shut down, or diabetes is already full blown. And the reason is that these diseases have been developing for some time, but owners only now recently realize that something is not right. Because, as I said in the very beginning, pets don't tell you what they feel. They actually hide their symptoms. So when they come to the clinic and we check their vital signs, they're off the chart. So the idea is, what if we can measure the same thing we measure in the clinic, but we want to measure them at home continuously, long term, identify the very early changes to clue us in that something is developing, and have them come to the clinic a long time before they would have otherwise. So early detection of diseases, preventing this needless suffering, and giving peace of mind to pet owners. So this is this was the idea. We started, as I said, 2-3 people in a kitchen. Very quickly we grew to a full company. We have over 30 employees now. In late 2015 we launched the first product, so it took us 4 years to develop the first collar. The reason was that at that time there were no sensors that could measure these things outside of a hospital setting, so we had to develop our sensors actually from scratch. 2020 we started working on our next generation collar, and we're launching it now. And yeah, we're very excited about it. I agree with behavioral problem. I think the point was made earlier that behavior issues may have a medical basis to it. So you always have to make a good diagnosis, because the treatment is not always pure behavioral. Sometimes you need to treat the medical problem before you can achieve any improvement in behavior.
Even if it's behavior, in your research protocol of development of the device, did you have any point say, okay, so there is a change, okay, in the daily movement or heart rate or what you measure, and did you have you think about a questionnaire or something? Okay, something here is not doing good, so we have now an assessment system to know, to check if it is a behavior problem or not.
So it's a good question. What we have right now in the system is ability for the user to add notes. And the notes become part of the medical record, and then you can analyze it, the data, like with the effect, like with this tool that I mentioned. You can assess this one. You can assess those things and see how they respond. But at this point, this is where it is. It's not more advanced than that. We see ourselves not as a diagnostic device. I don't think, even in my most positive, I don't think we'll be able to, just based on temperature and pulse and activity, we'll be able to tell you, okay, you have disease A or B, but we can flag that something's not right, and then the veterinarian, together with pet owner, will need to come together and figure out what's going on.
Remember, in my presentation, I talk about early detection.
Yep.
Like something is going out of the green zone.
Yep.
And it's time to check. I'm telling you because it's existing. There is questionnaire. There is something that you can put, very simple questionnaire you can put and say, okay, we see that there is some difference, so can you check that? And you have more data, and even the machine then can say, okay, when I have a pulse like that or any data that you have, there is a connection with something in the behavior that is going out of the green zone.
Yeah.
You will never say this is pathological.
Right.
I agree with you 100%. But you will say something is changing out of the balance, and you have to go to consultation.
So You're correct. This is part of our MRD. This is part of our future development. Right now, we're raising the flag. We're telling you what we're seeing 1, 2, 3. Are you aware? So, for example, just last week we have a client who received alerts that the sleep quality of the dog was 7 standard deviation decreased in 1 day. So immediately all the flags come up. It turns out that they traveled outside of the country. They left their dog in a kennel, and they called the kennel and said, yeah, the dog doesn't sleep, barks all night, just feeling miserable being away. So they had an explanation for the data. So that closed the loop, but I agree with you. Many times it's not that obvious, and receiving data, manual data from the owners or the users definitely can increase the potential prediction value of the system.
Anyway, if you need collaboration here, especially veterinarian, behavior medicine,
Great.
it's really great to improve and go further in this direction.
Great, appreciate that. One of the programs we're working on is in anxiety, so I'd be happy to collaborate. Great.
Great. One thing came out of it already.
Absolutely.
Thank you so much, Asaf.
Thank you.
Okay, so
Yep.
yeah, thank you. Our next speaker is Nareed Farhat with a short presentation.
Hi, I'll try to make it quick. I know you're all tired. I'm going to be talking about automated analysis of dog behavior and mainly using tracking for the automated analysis of dog behavior. We saw many interesting and hard to get data today from different angles, to get landmarks, to get movements, to get so much specific data needed for specific analysis. I'm going to take it back to an easier type of data that comes from shelters, comes from, like the left image in the bottom is from the veterinary of Stefan. He just saw you the pictures. And we can't really do landmarks on these images. We can't see the faces of the dogs. We can't see their emotions, they're in pain or not, but we can always do tracking. I'm not going to tell you how tracking works. I'm just going to tell you that it's usually easy to do. We can do tracking with even small data sets. We can achieve good tracking using machine learning. But can tracking actually give us any important information? Okay, we have the tracking. We know where the dog is at a certain time. Does it give us any important information? This is what I'll be talking about. I will explore a few case studies that we already did and explain the different approaches and the promising results. I see them as promising, hopefully you will too. Okay, so that's basically what I just said. But first of all, what is tracking? I mean, mainly what we work with tracking is not only images, because images don't give us a lot of, images don't give us a lot of information using tracking. We use tracking on video data to see where the object, being a dog, a person, both, are located in a time series. Like in the video, given a video, we can see where the dog is in a certain data point. This is tracking that the left image, which is the result of the tracking, I'm going to be calling it trajectory in the presentation. Just so you know, trajectory is the coordinates of the detected object throughout the time, throughout the series, the time series. There are many tools to get tracking. You can either get tracking of one object, two objects, body parts of objects, lots of different tools. Some are paid, some are free, some are online, some are easy to use, some are harder to use. It's a rabbit hole. If you want, I can give you recommendations. But today I'll be talking about one tool, which is called Blizer, which we developed in the lab, Tech for Animal Labs, Tech for Animals Lab. But Blizer is not only a tracking tool. Its title is an AI-based digital platform for automated analysis of animal behavior. Now, the jump from tracking to animal behavior is what we'll be exploring today. The process we do can be simple and can be hard depending on how deep we dive in it. The first few steps are just what we said. We have a video, we do simple tracking, we get trajectory. We have where the dog is in the second number 5 and second number 10. Afterwards, we do something called feature extractions. Feature extraction gives us the features, and these features, we feed them into a model. The model can either be a statistical model, normal statistics, or can be something way more complicated. Some models that I know, some I don't. It can be different things. This is the general process we do. The features we didn't talk about can be also many different things. They can be human-chosen features. The animal researcher can come and say, okay, I have a set of 30 videos. I want to know how fast the dog is moving in these videos. The feature here is speed. It's quick. The human chose it. The animal behavior probably has a reason for choosing speed. We only calculate it. They can also be automatically extracted. Some features that we did not think about, but the machine can have them, or learned. The learned features are, I will keep them for the case study, which will be explained better there. This is the same process, but simply put in different wordings, just so you'll know who does each step. The most used, I will say, because it's the process I used most in my previous years working in the lab, is the statistical analysis approach. In it, we have a data set. A human collected this data set, usually a veterinarian or an animal researcher. He has a research question. He collects the data. So a human collects the data. He gives it either to the data scientist, or he learns how to do the tracking himself using an automation tool, and the machine does the tracking. Afterwards, we do the feature extraction, the feature selection, sorry. So the veterinarian, the animal researcher, sat down. While writing the research question, he probably has in mind some features that he wants to look at. These are the features he chose to see, chose to calculate. The feature calculation, the machine does it, and there's the result analysis, usually done with statistical analysis. A more hybrid approach comes to say, okay, let's swap the statistical analysis with different analysis. It's more machine learning or deep learning analysis, which is, if you go down to understand what machine learning is, it's just complicated statistical analysis, basically the same, but the machine does the complicated part for us. And then the third approach, which is the human-free approach, it says, okay, but let's remove the human part from choosing the features. Why are we only looking at speed and the movement and the interaction of the dog with a specific object, toy, how much it stayed near the door, how much it stayed near the chair? Let's leave the trajectory as it is and feed it to the machine. Let the machine decide what it wants to look at. This approach is, as you can see, human-free. The human simply collects the data, then the machine does the rest. Of course, with the data scientist doing all the hard job, but the machine does the thinking, I want to say. We'll explore 3 different case studies. Each does the single process. We'll start with the statistical analysis approach to the human-free approach. The first case study is the first one, exploring the dog-human relationship by combining FRMI, eye tracking, behavioral measures, long title. It was done in collaboration with Sabrina Carr from the Veterinary University in Vienna. Yeah, you probably know her. I will go quickly over the process because you probably heard a lot about it. So we have data collection. We have many, many videos of dogs in a room with 2 screens. One of the screens has
a video of the owner, the second has a video of a stranger. This is the data. We do tracking. We track where the dog is in each second of the video. In this case study, we didn't only track the dog's location, we also tracked the nose, the head, and the tail, the beginning and the ending of the tail to see the tail wagging. Tracking nonetheless. Doesn't matter if it's body part or a whole object. After we did the tracking, we talked to the animal specialist. They said, okay, we want to see specific features the dog does. We want to see how much time did the dog spend in the red area on the right or on the left. We want to see how much time the dog spent in the blue area closer to the screen. How many times did the dog actually touch the screen using his nose? This is the feature selection phase. The specialist decided what he wants to see. What do? We simply code them. We either have them or we add them to the machine. We code these features. Given the speed of the analysis of the automatic analysis, we can easily calculate them once we have the tracking and the definition of the features. We can already see it's much faster than someone actually watching the videos and calculating how much time the dog spent in area X, area Y, and much more accurate. Now we have a long, long list of all the dogs and all their features. We give them back to the animal behavior. He takes the features, does some statistical analysis, and gets results. Are they good? Are they bad? Not important to the talk. They were good, but they are statistical analysis nonetheless. Simple as that. A different case study, one done by an alumni master student and Stefan here, checks something similar, but the process is a little bit different. It's the hybrid approach this time. Data was collected. It's videos of dogs in the vet with a toy. Tracking was done. This time we tracked all the dog and the toy. Then there's the feature selection phase. Again, the veterinarian and the animal behavior said, okay, there are specific features we want to see. We calculate them. We did the distance, then how the straightness of the dog, how straight does it walk, when did it first start playing with the toy, how long did it play with the toy, and movements, different features from the trajectories. Again, we have a long list of features like before, but this time, instead of doing normal statistical analysis, we did something a little bit smarter. We took the features, we fed them into a classification model. A classification model is as simple as it is. It takes data and it gives you a number between 0 and 1 when you're using with one class. With that, does this image contain a dog? And it tells you, I'm 90% sure it's a dog, or I'm 0% sure it's a dog. Here we gave it all the videos, all the features extracted from the videos, and we asked it, which dogs do you think are pathological? We didn't really ask it, which dogs do you think are pathological, but we gave it the different classes. So it gives us a score for this dog, and it worked well. It looks very similar to statistical models, but with one big benefit. Classification models and machine learning models in general can be reused. I can say, okay, I did this great model. It does tell me which dogs are different than others in terms of their behavior, and I can put it in a tool. I can put it in an application, in a website, simply in my computer, and when I have a new dog that comes in the same room, playing with the same toy, I can do the trajectory and I can give it to the model, and the model can tell me its prediction. It doesn't only prove my hypothesis for the current data set, it can also work for future data that we collect. That's a big plus that the shift from statistical models to machine learning models provides. And the harder approach, which is the human-free approach, it's a recent paper we did called Digitally Enhanced Dog Behavior Testing, Getting Help from the Machine. It's still in review. Hopefully you'll see it published soon. We did it with Teddy that was here. He's a machine learning expert, and colleagues from Belgium, which are animal behavior experts. We'll again swiftly over the data. I know you're all tired. The data has videos, almost 40-second videos of dogs in a stranger test, as they call it. The dog enters a room, there's a stranger sitting in the middle of the room, and the owner sits on the side. Nobody does anything for 40 seconds. The stranger simply crosses its legs and brushes its hair, not touching the dog, not giving any importance to the dog. Okay, again, we do tracking. This time we tracked both the dog and the human. We received the tracking, and it was time for the feature extractions. We could, at this point, extract features. We could say, okay, the dog moved X and Y speed. The dog reached the person in this second. But we decided to do something else. We decided to take these videos and give them to a clustering model. The trajectories we have from the dogs went into a clustering model. Now, the clustering model does something a little bit different than the classification model said before. The clustering takes data points and groups them together based on similarity. Which similarities does it see? We usually don't know, but it did do a good job. How do we know it did a good job? These videos were also manually annotated by animal behavior experts, and we check if it did a good job or a bad job. Moving even further, we did something else. We took the clusters we got from the videos, from the clustering models, and we did a further model, a classification model, to try and group them into the groups, additionally, on the clustering results. And it did good grouping detection. I won't go into details into how and what. You can all read papers, so we know that. But the point is, no human interaction was in the process whatsoever. We only got the videos. We know there's a difference between dogs. We know some dogs belong to a certain group and others belong to a different group. We have the tracking. We send it into a clustering model, and we can already see there were the model could select the dogs that belong to each group together. So to summarize, the first approach, which is the approach I didn't even mention because we talked about all the day, is the no machine approach, all human. The human either collects data or does the observations in person, observes, documents, analyzes on its own. The the faster way is the machine tracks, the human chooses the features, and the human analyzes them using statistical models, statistical analysis. The hybrid approach does machine tracks, the human does choose the feature, but then we analyze them with machine learning models, which have the benefit of being reused to use them to predict on future data. And the human-free approach, the machine tracks, it selects the features, and it does the analysis on its own. And we can already see that it's working, and hopefully we can prove it further. Any questions? Okay, thank you.
I have one. I'm amazed by the human-free approach about the machine. So finally, I'm not smart at all, but I'm thinking that the machine you have to give some clue, like what does the machine exactly? Like, okay, there is a lot of going around. So this seems interesting. This is what is happening.
The clustering model, we didn't give it any clues. No, we just gave it the row trajectories as they are. And we only gave it the clue of you will find 2 different groups in this data.
Okay. So
that's the only clue we give.
To an AI that is like thinking and say, okay, this is interesting, so I'm going further and deeper in this direction. But this is like a decision of the machine.
It is, yeah. But I don't see it as so surprising because you too, we know that the difference is in the data. We know that the difference is in their behavior, and the trajectory simply encapsulates it in numbers, and now the machine can read it.
But looking at explainability, this is what we are putting at the moment. Like, it's a black box, so you want some kind of
But it's interesting because you are like very relaxed about it. Okay, we have a black box, everything is okay. And I am the opposite, like, okay, I have a behavior which is normal, pathological, I don't know, but I want to see inside the box, I want to see what is happening in the brain. And I'm not like, behavior is like some years ago that was, okay, there is a trigger, there is a result, and there is the black box, and I don't want to know what is happening with the black box.
She wants to know, but she's the one building the black box.
Just to give you a little bit of the context, this particular test was used for improving breeding outcome. So these dogs were also scored by experts, and they received some scores. So after the machine did its black magic and divided mathematically into 2 clusters, we wanted to see whether the clusters are indeed, here are the good scores, here are the bad scores. Of course, this was not perfect, but amazingly, it did divide well. So there is mathematical information in the trajectories, which also is intuitive for the experts. So
you check
the validation
the level of intelligence of the machine. Fine.
Yeah. I mean, the mathematical division of trajectories also reflected some meaningful behavioral information. That is the point. But we did not tell the machine, look at this angle, look at this speed, because that would be twisting its arm. Yeah. We tell it what is the best division you can do, and then let's see what is the correlation to what the people thought. But the people only come at the stage of evaluation of the result, and not in deciding through the process. So I think this is the novel thing in the last approach. Yeah. Oh, sorry.
Make a track if the camera located at the angle.
The camera is located at the angle of the room, not an overhead?
At the angle, not at the top.
Yeah, we have some shelter dogs data as well, that the camera is located from looks at the dog inside a kennel, and we can also track.
Distance and
It won't be, like, the benefit of having a camera on the overhead is that we can calculate the distances and the movements and the speed and the pace, and also translate them into our metrics, not pixels, to centimeter and meter and the speed. But if it's on the side, it would be a bit harder. You might need 2 cameras to capture all the view and also to translate into centimeters, meters, and the used metrics.
Yeah, I think we can recognize behaviors, but not measure distance because it's a distorted view. So you need some kind of mathematical,
So if you don't want the numbers in our metrics, we can measure different things, of course, from the side view as well. Yeah.
Yes, Julia.
And I just have a consideration about black box and human intuition. So we cannot describe what our intuition are based on. Okay? And it's the same with these machines. But are they changing whether the data scientist is you or not?
No,
it does not matter.
The clustering model is the same clustering model. I could run it and another data scientist can run.
Yes.
Depends only
Yes.
solely only on the data. Yeah.
Also, in this particular case, you could request the number of clusters. You could say, what is the best division you could do to 5 clusters? If we knew there are 5 different types of dogs. But we only requested 2 types because we had very fearful and normal dogs in this sample. So you decide what kind of clusters you want. The machine does its best, and then hopefully we compare it and see that there is biological meaning in the clusters.
Any more questions?
Okay, thank you. So now we have another short presentation by Dana Wilker, and then we will end with a very interesting talk, so stay tuned. And Dana is a trainer of working dogs, service dogs, and a cognitive scientist. So please also tell a little bit about yourself, because you are a very fascinating person. Wait. So I am Dana and this is Chance, and I'm going to talk about how we choose puppies for service work and on an app that we're currently working on in this lab. So basically we're going to discuss what a service dog is and of course characteristics that we look for in a service dog. And I think the most important topic about, like in this area, which differentiates service dogs from other working dogs, is the importance of how the handler's disability affects the choice of the prospect to begin with. So a service dog is defined as a working dog that is trained to perform tasks directly related to a person's disability. So this doesn't mean that a dog would follow a person around like Chance is doing right now, but would be actually task trained to do certain things. So some dogs are scent-based trained, and they're trained to respond or alert before some medical episodes, for example, with diabetes or with PTSD attacks. But other service dogs are trained to perform tasks such as leading the blind, alerting to sounds to deaf people, and of course to help with mobility impairments. So when we try to talk about what a service dog is and what it isn't, then we know that it is task trained. But what's special about it is that it's paired with a disabled individual. So the handler, the person who in the end of the day needs to operate the dog's working ability, is a person with a disability that the dog was trained specifically for. And then since the dog needs to be able to perform his or her tasks everywhere, then the dogs also go vigorous public access training. That is because in the end of the day, the dogs come everywhere. That means even hospitals, and they need to be behaving in a certain way in public. A service dog is not a therapy dog, which means it doesn't work with multiple people with disabilities. It works with a single person that it is trained for. It is not required that a service dog be handled by an animal-assisted intervention specialist, such as a therapist or an instructor. And it is not a pet, nor is it an emotional support dog. Even PTSD dogs, in the end of the day, perform tasks. We cannot measure emotional support. It is not a medical measure. Each person can report differently on how they feel, and this is why right now emotional support dogs do not qualify as service dogs. And then when we look for a service dog, then obviously we look for different things, but some things that we want to see in common with all of those dogs is, first of all, a rebound effect. So we want to see that when the dog is surprised, it can recover pretty quickly on its own. This is not something that is trained usually. It is something that the dog is just born with. We want to see a level of neediness because we want the dog to be dependent on the handler as much as the handler is dependent on the dog. And the dog not to wander off. In the end of the day, it needs to be very handler-oriented. We want to see high working drive, high sociability, but not extreme, so that people will approach the dog, other dogs will approach the dog. But we also don't want to see the dog approaching other people. And then this might seem contradictory, but we also want to see a good level of independence because sometimes the dog does need to decide and perform on its own. This does not actually contradict, in my opinion, the neediness. The dog can be dependent on the handler, but still be able to make its own decisions and perform as long as the handler is present around the dog. And the dog needs to be self-soothing. This is similar to rebound effect, but in the end of the day, like you saw today, Chance had to sit here from 9 o'clock with only one bathroom break. Needs to be able to put himself and settle without me having to pay attention to whatever he's doing every single second of the day. And so the project we're working on right now in this lab is an app that would help trainers choose prospects for service work. We usually talk about puppies from between 6 to 12 weeks of age. And then
right now, we have a problem of variability in the field because each trainer chooses the dogs according to their own experience, and what we see is a very high level of washing, which means many dogs either don't finish the training process, which is long, or they fail in placement. Once they're attached to the person, something in the chemistry doesn't work and the dog fails to adapt. And we want to find scientific methods to basically test behavior at a very young age, and in the end of the day create a large database that would allow trainers to consult with the app while testing the dogs. And so for that, we obviously cannot just lean on the experience or even the gut feeling of a single trainer, even if they're very good at choosing puppies. And so the closest thing we could find to a tool that would assess dogs was the Volhard's puppy aptitude test. This is usually done for pet dogs and for therapy dogs. And the test basically looks at different aspects such as social attraction, following, restraint, social dominance, elevation dominance, retrieving, touch sensitivity, sound sensitivity, and sight sensitivity. A lot of these tests are similar to the ones that are done on other working dogs, military dogs, but they're called in different names. And then there are specific rules for the test. So the location has to be unfamiliar to the puppies. The puppies are separated from each other when they're being tested. The tester, there's also a score that needs to be new to the puppies. In this test, the puppies are tested before they are fed, and the only first instinct of the puppy is considered. But then this did not actually fit with surface dogs because, like I said, we want to see a rebound effect, we want to see self-soothing. Obviously, the first response is not going to say a lot. I also wanted to see how the puppies actually behave within the litter, because in the end of the day, I want to see how they're socially influenced and if other types of learning than associative learning can be achieved later on. And so we changed some of the tests. So the social response test instead of a social dominance test, just because the dominance level around the dog doesn't really matter for service work. Same with the elevation test. I don't really care how the puppy reacts if I put them on a high table. They're never going to be on a high table in their actual work. I want to see how the dog reacts if it's getting picked up to a low height. I don't want to scare the puppy. I just want to see how it responds. So we do a drive test instead of a retrieving test. This means that I would not toss a toy and expect to see which puppy brings it back. I usually use a skinny toy to see drive and who gets to the toy first, who pushes the other puppies away. And then there's a stability test instead of a sight sensitivity. It's very similar. We still use an umbrella and open it, but instead of looking at the first response, we see how the dogs adapt to the change in the room. And then we added another test, which is a social learning test, which was important because, like I said, unlike the original test, we actually do test the puppies within the litter, and I want to see how they respond to each other. For this test, we do test the puppies after being fed. I want to see them at the height of their cognitive ability, even if they're a little bit more tired because they're fed. I don't want the hunger to actually influence the behavior during the test. And like I said, I do consider rebound. First response matters, but it's not the most important thing. If I see a dog running away from the umbrella, but then after half a second sits down, looks at the situation and comes back to check it, then that's what I would usually actually want to see. I don't really care about the first half a second where the puppy showed a fear response. And then both tests, both the original and the adapted version, score puppy between 1 to 6. When 1 is a very aggressive puppy, to 6, which would be an extremely fearful puppy. And then for a pet or a therapy dog, we would usually want to see a 3 or 4. But for a service dog, and that's where it gets tricky, the scoring depends on the patient. So a lot of patients would need a dog that is within the 3 or 4 range, but there would be some that I would prefer to match a dog that is more fearful, maybe a 5, and patients that I want to see a dog that's more independent, even socially reactive, not aggressively reactive, which would be a 2. And then when we assess disabilities, this brings many more factors in. Like I said, when we work with other working dogs, including therapy dogs, we usually don't really consider the handler. We want to see some characteristics that the dog would have, and then the person who's holding the leash doesn't really matter in the end of the day as long as the dog is trained. But since we want the dog to work for a specific person and we need that person to be able to actually control the dog, we need to assess the person as well. And then for the purpose of this lecture, and in general, disability right movements, the word function, I would prefer to refer to it as the level of independence of a person and not a level of cognitive abilities. I just want to know how much a person is able to take care of themselves in different situations in day-to-day life that the dog might be able to help with. And then usually in order to assess a patient, we would do an intake. This is something that is done by medical professionals or therapists, in which questions will be asked about the well-being of the person, how they would describe their day-to-day life, the causes, etc. The problem with that is that it is, like we said earlier, very individualized. In the end of the day, I, as the person who's interviewing, choose what to ask. There's a different setting for every meeting. Every patient would respond differently. And then I would get to my own conclusions about what a person told me, and I would make a choice according to that. And we want to minimize that. And so the issues are basically, they're skewed because of personal viewpoint of the interviewer, other interfering factors. Also, they're meant to be given by therapy professionals or medical professionals, not by dog trainers. If you don't know how to do an intake, you're probably doing it wrong. And so I started to look for qualitative questionnaires that are actually medically and scientifically already proven. And so we got to the HUDAS-2, which is a questionnaire created by the World Health Organization, and it assesses function, as in level of independence. And then it assesses things from different areas of life that would tell me as a trainer what I want the dog to be able to learn and how much this person can use the dog in different situations. And so it assesses the areas of understanding and communications, getting around, which would talk about moving inside and outside of the house, self-care, which would basically check all the ADI and ADR functions, including around other people. Getting along with people would be a more social interaction and relationship maintenance area, life activities in the household, so taking care of your house and day-to-day living. Life activities would be the same, but at work or school or whatever structure you are going to every day. And then participation in society is more broad, as in what you do over the holidays, and do you feel that it's accessible for you to go to the mall or things like that. And besides the fact that it is already, that people already did the job of scientifically checking that for us, this questionnaire is meant to be self-administrated. So there is no problem for a trainer or a person to actually fill that out themselves and get a very clear score. There are a few ways to assess the score, and the instructions are very clear. And then our only issue is that it doesn't assess symptoms. So I know how independent the person is, but now we have various people with various disabilities that can show the same thing, basically, which gives me some information, but it doesn't give me all the information, because obviously a person with PTSD would not need what an autistic person would need, and they would not need what a person with anything else would need. And so for that, we can use specific symptom assessment tools that were also proven in their own areas and are also self-administrated, or at least have been repeatedly used enough times to know that their scores are not influenced by personal beliefs. And so for PTSD, for example, we use the PCL-5, and for autism we can use the sensory profile score assessment, which would give us more details about the sensory issues that bother autistic people, which is usually the main symptom they want the dog for. For dementia we use DDS, etc. And then going forward, we would like to add more behavioral paradigms that would allow us to assess dogs for further throughout time, so following the dogs and throughout training and retesting them, but also using paradigms that were shown to be replicated, the score was replicated throughout the development of the dog, so for example the cylinder test. And then, of course, the most important thing, in my opinion, would be to continue to assess ongoing comparability with the handler, because the fact that we did it right the first time doesn't mean that this handler is not going to experience shift in symptoms and function level throughout their lifetime. This is how it is when you live with a chronic disease. And it's very important to see how the dog adjusts to that and how the handler adjusts to that, because in the end of the day, the dog and the handler are dependent on each other. And that's it.
Thank you. Questions?
Again, as far as I understand, most of the tests are in the older point of view. Like, you want to make a match between the dog skills and the need of the human being, right?
Yes.
Okay. So now I'm asking, what about the dog? Like, did you think about, in your test, made some assessment of this human being, is it compatible with this dog on the point of view of the dog? Meaning that in the point of view of the human being, the dog is perfect. But finally, the dog will have welfare problem because of his work, because it's a walking dog.
Yes. So I'll repeat that. You're asking whether we assess the quality of the care that the person can actually give to the dog when we match the dog with the person, and not only the quality of the dog when we match the dog with the person. And the answer is yes, but not within this app. The app is supposed to help the trainer choose a dog for a specific client. This doesn't mean that every person who qualifies for a service dog is fit to receive a service dog. This is true about any sort of treatment. The fact that we have some treatments that are available for specific conditions doesn't mean that everyone is going to benefit from that treatment. And obviously, if I see a person that is not suitable to take care of a dog for whatever reason, even if it stems from the actual disability, then for me, they're not ready to receive a service dog at that moment. And choosing how to, like, which clients to work with is part of your job as a service dog trainer. But obviously, in the end of the day, the fact that we look at those 6 specific characteristics allows us to choose dogs that would be better as working dogs to begin with. We would not just choose a dog because it's cute or because we think it's calm and it will adapt well to public access training or to task training. We would choose a dog that is an all-star in every direction. And this is not an easy task, because we talked here about matching the dog and the handler, but you also need to match the dog and the job, like you said, and also you need to match the dog and the handler with the trainer, because not every trainer is going to be able to successfully work with every successful dog or every fit patient, and this is something that is true for any therapeutic
work in the end of the day. Okay, so we thank again the speaker, and we move to the last very exciting speaker of the day. Thank you, Dana. Inon, would you like to use your own?
I will.
Okay, okay.
To be quick because I need to be out of here by 7.
Okay, okay. You need this?
No, I think I'll be fine. For a second. Okay, so hello. So my name is Inon Maoz. I'm from the lab for behavioral neuroscience in the University of Haifa. Actually, what I'm going to talk about is very similar to the last two talks that you had. We're also doing tracking of animals, but in a somewhat different way. We also have almost the same outcomes with the same decision making at the end, but we're using an entirely different software. So it was pretty nice for me to see something different, like similar but different. So I'll be going about that. So the first thing I want to show, I'm in our lab. This is not going. Yeah. So in our lab, the behavioral lab is basically a controlled environment. It allows the simulation of actual events while performing quantitative analysis of multiple parameters. As you can see, this is not operated. As you can see, it's basically an empty room. It's a large empty room. We can do smoke, we can do 360 projections. We can control weather such as temperature and humidity. We can go out to 95% humidity. We have a pet pace collar from Asaf, so we can also use that. Almost everything you can imagine. You can see the smoke machine. If you do a turbulence inside the air conditioning, then it turns into fog. So you actually can control how much the dog can see. As you can imagine, we don't only use it for dogs, we use it for even for humans. And we're originally come from the Faculty of Medicine. Right now we're not, we moved to the University of Haifa, but we are basically neuroscientists, so we come from the worlds of rats. So what we did mainly is to take a lot of behavioral tests from the rat world and to bring it to the canine analysis world. And it goes back, apparently. Okay, so let's see. I don't remember. So this is basically stuff that our lab is doing, if it will ever work. 1 second. Yeah, I tried on my screen, it doesn't. But okay. So this is some of the stuff our lab do. Canines in the field on the left with GPSs, cooperation in rats on the right. We work a lot with working dogs, mostly working dogs. This is an open field with the tracking of a dog. We will go into it further. This is the rest of the lecture will be on that. Other stuff that we do is special animals, such as subterranean animals that used in tunnels. You can imagine why we need that. We work a lot with the Ministry of Defense. And the last one is humans. We do a lot of stuff with humans, either EEG. We have auditory sustained attention tests, as you can see on the right. On the left, it's an FNIR, if someone knows what it is. But basically, we have a lot of projects in both humans, rats, and dogs. So it's kind of interdisciplinary, and we try to translate between all of the animals. Yeah, we do see humans as animals also. So we try to cross-reference. There was a question earlier about looking how humans affect dogs. So we have a project like that. I will start speaking, and maybe at the end if we'll have time. This is
not what I wanted to show, but okay, it wasn't in the right place, but okay. So first of all, we created a behavioral standard. We started running a tracking model. I will go over it further, but basically what we did is we started creating a behavioral standard. Why is it so important? Because currently many dogs are selected by certain types of for certain types of training and are unable to finish it. They start training, they're being invested with a lot of money and a lot of time and a lot of training, just for a lot of them not to finish their training. So what we decided to do is to create some kind of a behavioral test, so the dogs can go through and we can get as much data as possible in order to see which dogs might fit best to which profession, and also which dogs are most likely to fall from for any kind of training.
The tip is about to turn.
Oh, yes. Oh, nice.
It's just a hint.
Oh, this one is off now.
Okay.
Okay. So basically what we do is it's tracking research. We actually use I will show you some previously acquired samples that we took. We actually started the basic model in 2013, like almost 10 years ago. So this is something that is ongoing for a long, long time. The test itself was translated, as I said before, from rats. This is something that is being done on rats since the 50s, I think. So there's a lot of data, a lot of stuff that is known about the walking patterns of these animals, and we wanted to see if we can translate it to dogs and to see what we get. So we started, we have actually 3 stages. The first one is an open field, an empty room. The second one is the same room, only with 4 identical objects in the corners. And the third stage is that we replace one of the now familiar objects with a new one. The new one needs to be different in both size and color. It can be also different in shape, but size and color are the more important stuff that we focused on. And also between each one of the stages takes 5 minutes, and every dog usually wait about 10 minutes between the stages. It's okay if they wait more, but not less than that. So this is how it looks. And okay, at the end it works. So this is the open field. We let the dog enter from the door, and the dog is being left alone in the room. So this is the same thing that I don't remember the name that you talked about earlier about tracking. So this is basically what we do. We track the walking, we take of the walking distance, velocity, you'll see it in the end. This is the second stage with the familiar object. The dog is just inserted for 5 minutes to get familiar with the object. And on the third stage, which you'll see soon enough, we actually replaced one of the objects with a new one, different in size and color. And we see basically the most important stuff that we want to see is how long it takes the dog to react to the new object. So this is basically a measure for selective attention. This is how we look at it, which is the latency to the novel object. Right now I want to show you how it looks when the tracking software operates. So that we do it usually offline, but this is something that we do off-site. I actually went to all kinds of military bases across the country with a GoPro, recorded it there, and then returned to the lab and do it. Of course, we have our own room in the lab, which we usually use to develop new stages, new types of method in order to look at dogs. So this, what I'm showing you today, is the most basic one, but we are always developing to new stuff according to what's ever needed. Okay, I want to return to another video. This one. I will need to do this. Okay. So these are 2 dogs. The dogs are siblings. It was made on the same day, in the same room. Okay. The only thing different is the dog and the position of the novel object. So as you can see, it starts almost the same. They have the same search pattern. But now we will see something very different. The first one goes to the object and just surveying it. The second one acts differently. You will see it in a second. First of all, he stands next to the door, so you can already see something. Next, he's becoming extremely aggressive toward the novel object. So this is the kind of stuff that you can't see unless you perform this kind of experimentation. When we ask the people that are, it's getting too loud, but it continues from the entire time. The dog on the left just starts playing with everything, and the dog on the right just continues to attack the novel object. Yes?
But are they trained to do something like alerts?
No, these dogs are specifically kennel dogs. They were not trained for anything yet. These are about to be trained at some point. But these dogs are not any kind of, and didn't have any kind of training except being in a kennel in a youth village in Akko, which is a very good one with very good conditions. But yeah, so this is what we noticed. The reason why I'm showing you that is just to see how different two very similar dogs can be. Because when these two dogs were given to us to make this test, they said, yeah, these dogs are pretty much the same. They're siblings, their behavior is pretty similar. Of course, not very, there's one kid who treats more this dog and one kid who treats this dog more, and everyone thinks that his dog is the best, of course, as always. But when they go into such a test, you can see how different the character these dogs have, and as you can see on the right, there's something also very wrong, and we might need to consider them differently when choosing which dogs will go to each profession. We saw all of that. Okay, so this is basically the features that we measure. We actually also afterwards we did the stuff with the machine learning to let them choose whatever is important. At the end, after, as you can imagine, almost 10 years of work, these are the main features that we chose to focus on. But of course, we always let other people. We recently just hired a data scientist to go over all of the data to see if he can find something different from what we found. Currently, these are the features that we are focused on. So the first one is activity, that we measure for the distance of movement. The second one is velocity, like shown before. Freezing time. Freezing is a measure of anxiety. But as you'll see, not in all ages, which is a thing. Anxiety index. Anxiety index is measured as a percentage. It's the distance moved in the periphery of the room, near the walls, divided by total movement. This is on the first stage. So this is an anxiety index, which works a lot better for the majority of dogs. We will see it soon. Total exploration is time near each one of the objects, and the latency to novel object, as I told you, in the new object, when the new object replaces one of the similar objects. It's important to say that we already have about 250 dogs, more than that now. And the dogs, like you see, the ages vary very much. It's from 2 months to 96, but you'll see that when we did the analysis, we actually counted on that. So each age reacts differently. As you can see, age 9 to 19 months show a lot higher activity. So this is something that when you analyze something like that, you need to take into consideration. The red line is actually the median results. So as you can imagine, 50% were below that red line, and 50% above it. The fact that the black line is an average. So as you can imagine, there are a lot extreme. This is why we use the median. So what we did here, actually created a standard for all of these features in order to be able to measure them against any kind of dog that you'll try to measure. In this way, we can know if a dog's behavior is normal or abnormal according to his age class. As you can see, age class is very different. But this is only the activity. If we go to the next one, there's the freezing and and anxiety index. So what we noticed in the freezing, as you can see from age of 24 months, there is kind of what seems like a lot of freezing, like a lot of anxiety, but actually that's not the case. These dogs are sometimes, they're older, they're more familiar with certain scenarios, they just go to sleep. So it's not a measure of, for dogs above 23 months, at least in these results, it's actually not a measure of anxiety. So in this case, we chose to use the anxiety index because it's more reflective even at older ages. So it is important to know that at a certain age, not every feature will suit the dog as much. So we do need to look at that. Latency to novel. As you can see, from the age of about 3 or 4 months, they're starting to be around what we call a normal dog, like what you can see from here onwards. Of course, 2 months is too early, maybe even 3. About 5 months, you can already see that the result is exactly like a more mature dogs. This was something that was actually taken into consideration in the Israeli Air Force. They started training the dogs for certain things at an earlier stage because of results such as this. So as you can see, all of the features, we're trying to take them to predict all kinds of professions. The professions that you use here were mostly explosive detection, tracking, attack, and none. The none is the failure to complete the training. So this is because it's very hard to know how good a dog is at his job. This will be the best way to try to predict something. If we had a specific scale of how good is a dog, let's say a dog was picked by a trainer, and we work with really good trainers, but still, they're only human and they use certain tools, and there are most of the tools that the trainer uses are usually not standardized. I know there are all kinds of questionnaires such as CBARC and stuff like that. They're still being filled by humans. So you can take the #1 trainer in the world, you can take the #2 trainer in the world, you can let them fill the same questionnaire, it won't end up the same. So here we try to develop this kind of test where you take a video, you put it into a software, and you get the same result every time. Of course, if you do it at a different time stages, you usually won't get the exact same thing, but it's supposed to be on the standard scale. So you will be able to know, with 250 dogs, you will be able to know what can be considered normal or abnormal. So this is the entire thing here. Currently, all of the results you've seen are either for they're all from kennel dogs. There are dogs who are supposed to be working dogs at the end, but there are no domestic dogs here in any of the results. We are planning on doing it in the future, but not yet. So one of the first thing we did, other than the statistics, which is what you're seeing so far, we tried to use all kind of machine learning mechanism and other fancy types of statistics. Here we use the logistic regression in order to be able to predict which dog will be best for which profession. So this is the kind of software that we used previously. The stuff that we did later by working with data scientists, we try to neutralize each one of the features in order to see which feature is most important to which profession. So as you can see here, you can see that in blue there are attack dogs, in orange are explosive detection, in green none. So if if a line is leveled, then it means that it was the same whether it was high activity or this is for activity. So if it was a high activity or low activity, it was the same. So it actually doesn't matter. Even if it's a high probability or low probability, if it's leveled, it doesn't matter. So you can see in the blue that the attack dogs show a lot less activity, which is kind of surprising. But these are usually these dogs come from special forces. So usually they're very highly trained. So you get them into a room, they don't have anything to do, they don't have any exits, they stop moving. Okay, they will move really quickly when they need to, but this is basically it. And you can see that with explosive detection, it's kind of the opposite, where you recorded a lot higher activity. This is anxiety index. So here you can see something very interesting. You can see that almost all of the dogs, all of the professions show lower anxiety index. Some of them it doesn't matter that much, but in some, like the dogs that were excluded from training, they show an exceptionally high anxiety index.
The higher the anxiety index, the higher they might be excluded from training. So this became something that actually can signal a dog that might also show some kind of abnormal data that might, if it's I can't say domestic dog because there are no domestic dogs here, but this is the kind of dog that needs more attention. And most certainly needs it now and can't continue their training unless whatever they're going through is handled. Because something is going on with the dog, and this is like the red light that's supposed to come up. If a dog shows a high anxiety index in this specific test, this is something that the handlers need to take care of, or at least notice. Another thing is the latency to the novel object. Also, the green one. As you can see, the more time it takes them to go to the novel object, the greater possible probability it is for them to be excluded from training. This is another specific feature that is extremely important in order to know which dog shows some kind of a problem. So this is basically the tablet that shows which kind of parameter affects and how much is effect for each specific profession. So this is something that was adopted by the Ministry of Defense. This is something that they're doing in the Army and the police in a lot of places. I actually presented this specific lecture in all of those places. We are continuing to work on that. As previously said, working on known features is nice, but we do need to go into sometimes machine learning and AI in order to maybe see new things, and this is what we're currently doing. And we're always trying to maybe add new phases for other things, and we're always trying to search for new ways of analyzing our data. Currently, this is what we have. As I said, if anyone has an idea or thinks that our product might be beneficial for them, feel free to contact us. In the future, we are planning on doing the same thing with domestic dogs, and maybe add some different stages. I admit that I got a lot of new ideas just from sitting here today. Maybe showing a dog to the dogs and maybe seeing, well, as I said, it's a 360 room, so we can project whatever we like. So this is something that I need to think about. But basically, yeah, there is a lot of where to go with this, and we are doing a lot of similar stuff, and it's nice to see how other people think and how they take stuff to different directions. So thank you very much for everything you showed here today, all of you. And basically that's it. Okay. So I'd like to thank Professor Avi Avital. This is his lab. I'm a staff scientist there. So thank you.
Thank you so much. Questions? Alex, do we have a question in the chat?
No, not in the chat. So, I have a question. Sorry. Yeah,
even better.
Thanks a lot, Ray Bessie. So you said that there were no pet dogs.
Yes, there's actually one.
There,
one.
Just one.
Which was excluded from this data, but we did one.
Yeah, but you did say that some dogs were more involved with some individuals, right?
Yeah, usually dogs has trainers, and they usually have a specific trainer.
Yeah.
So these dogs come from all kinds of specific programs through the Ministry of Defense, for the Army, from the police. Some of them are supposed to be dogs that don't have a specific handler. They're supposed to be trained to work with multiple. But most of them has a specific, like most of them, these dogs, very small amount that are supposed to be like that. Most of the dogs has a specific, well-known handler.
Like a professional handler?
All of them are professional, except for one program when we taught PTSD adolescents to be dog trainers.
Right.
You can search for my name for the paper. But yeah.
Yeah, how would you anticipate though that different handlers affect the different behaviors of dogs that you're trying to?
So if I take the PTSD paper, then the effect of the dogs was not that great. The dogs were trained; they were able to do their task. But when we test them here, we can see that the anxiety index went up
since the basic basic task before the training. But even after the training, when I compare it to to everything we did here, we compare it to the other dogs. So after the training, they already are walking dogs, and when I compare their data to other walking dogs, they have a higher anxiety index and a lower latency to first. So yeah, so there is a trade-off in that sense, but mostly in a lot of cases the dogs actually change handlers, usually because, as I said, it's a Ministry of Defense, so soldiers get off at some point. They get discharged from the army, and sometimes the dog lives with them, but sometimes they get a new handler. So in that case, I can't say that we did that specifically, but in all of the stuff that we did with retrievers, we haven't seen something very significant in that manner. Okay. Anyone? Yes.
In the video, you showed us about the dogs reacting
Yes.
differently to the novel object. Do you evaluate also aggressive reaction towards the old objects when the novel one is added to the room?
It's not the same room, yeah. Of course, it's the different. We usually don't test two dogs at once. Because this might lead to aggression, this might, specifically not if no one else is in the room. If we put two dogs in the same space.
Two dogs in the room, and then, no. The question was different. I mean, it happens that some dogs reacted aggressively towards an old object after having the new one, the new object in the room.
No. I can say no because I made I did myself the majority of the tasks, and I can say that I never seen that.
The dog on the left started playing with the other
Yeah.
balls.
The special forces dogs once destroyed all of my balls, but other than that. But it wasn't because of aggressiveness. They were being playful and just threw them at the wall very hard. No problem.
Okay, any more questions? Then we thank again, Inon, thank you.
Yeah.
And you should come visit our lab more often. We are neighbors.
Yeah.
Okay, so thank you everyone for surviving this long day. I hope that you enjoyed. We still have quite a lot of people sitting here, and we thank our remote participants for being with us and for chatting and leaving your comments. Thank you. That's all for today.